महीने सिर्फ 15,000 रुपये से।
Good morning, esteemed guests. A very warm welcome to each one of you to the International Conference on Recent Discoveries and Innovations in Life Science, ECRIDLS 2025. I request all the respected guests and participants to kindly put their mobile phones on silent mode. I also request all the participants to take their seat. May I once again kindly request everyone present here to switch their mobile phones to the silent mode.
To come and stand behind the chairs, please, so that we won't waste time. As the dignitaries come, we'll make them to sit on the chair, so that before that we'll make our arrangement for the photographs. So I request all the student participants to come and stand behind the chair.
are requested to join us for a group photograph. Thank you, guests and dignitaries. I request you to please take seat. It's once again a kind request to all the guests to kindly put their mobile phones on silent mode. I once again request all the guests and participants to kindly take seat. We are about to commence.
Don't blame your brain lazy if you're struggling hard with procrastination, because it might be a result of childhood trauma that you have absorbed unknowingly.
As
for
flowers
years.
of
Almost
gratitude
72%
shower
children
upon the portrait
emotional
of our
abuse like
beloved
destructive
founder,
criticism, constant judgment,
Reverend
and unrealistic expectations that scar their belief systems forever. As a result, they develop anxiety, shame, and people-pleasing attitudes that stop them.
Dr. Bhaskar Pandurang Hivali, we pause to honor a visionary whose life was a blessing to generations. In 1947, with limited resources but limitless determination, Dr. Hivali laid the foundation of Ahmednagar College, the first of its kind in this district. A very good morning to one and all. It gives me immense joy and honor to address this august gathering for a truly momentous occasion, the International Conference on Recent Discoveries and Innovation in Life Sciences, ECRIDLS 2025, organized by the BPHE Societies, Ahmednagar College, Ahmednagar. Today, as the world witnesses rapid transformation in science and technology, this platform brings together great minds, eminent scholars, and aspiring young researchers to explore, exchange, and enrich knowledge in field of life sciences. This conference is not just an event, it is a celebration of curiosity, innovation, and collaboration that share the future. On behalf of our respected principal, Dr. Noel Parge, the organizing committee, faculty of Life Sciences Department, and student of Ahmednagar College, I extend a warm and heartfelt welcome to each one of you present here. At the very outset, I deem it a privilege to extend our welcome to the distinguished chief guest of the day, that is Dr. Bhushan Patwardhan sir, whose presence has added grace and significance to this inaugural session. Sir, we welcome you. I also extend my warm welcome to the Honorable Chairman of the BPHE Society, Dr. R.J. Barnabas, whose vision continues to stir this institution towards greater heights. A warm welcome as well to our respected Secretary of BPHE Society, Mr. Vishal Barnabas, who stands as a pillar of strength for all our endeavors. I also take this opportunity to welcome our distinguished dignitaries, keynote speakers, resource persons, delegates, faculty members, research scholars, and students who have joined us from near and far to make this academic gathering truly international and impactful. May this conference serve as a catalyst for new ideas, deeper insights, and fruitful associations that will shape the future of life sciences. Once again, welcome to Acredil's 2025. Music has a universal language. It transcends barrier, uplifts the spirit, and creates an atmosphere of joy and harmony. What better way to begin this prestigious international conference than by invoking the spirit of togetherness through music? It is now my pleasure to invite the Ahmednagar College Choir to present a beautiful Hindi welcome song titled Swagatam. Through their melodious voices, let us embrace the value of unity, celebration, and inspiration that defines the very essence of this gathering. Please welcome the choir with your warm applause. Thank you, Ahmednagar College Choir. Your music has not only welcomed us, but has also set a tone of harmony and positivity for the day ahead. The notes of your song remind us that when voices come together, they can create something beautiful, just as this conference unites brilliant minds to create lasting impacts. Every conference is built on a vision, a purpose, and a dream to create an impact, to enlighten us about what Ecredil's 2025 truly stands for, its scope, and its significance. I now warmly invite Dr. Noel Parge, the principal in charge of Ahmednagar College, to take the stage and share the very essence and objectives behind this international conference. Sir, we are eager to hear from you.
Good morning, everyone. Honorable dignitaries, distinguished speakers, respected academicians, valued sponsors, dear colleagues, participants, and students. On behalf of BPHES Ahmednagar College, it gives me immense pleasure to welcome you all to the International Conference on Recent Discoveries and Innovations in Life Sciences, Ecredil's 2025. Life sciences play an important role in addressing some of the greatest challenges facing mankind today. Challenges like improving human health, ensuring food security, and protecting our environment for the future generations. This conference is not just an academic exercise, but a forum where knowledge meets application and ideas turn into impact. It's a platform to share discoveries, inspire young scholars, create new collaborations, and pave the way for future breakthroughs in the field of science. Ahmednagar College has always been a hub for exchange of ideas and all academic disciplines for the last 78 years. Life Sciences departments of Ahmednagar College and Dr. John Barnabas Postgraduate School of Biological Studies has been forefront in inspiring young minds. At this juncture, I would like to acknowledge the continuous support and guidance from our Honorable Chairman, Dr. R.J. Barnabas sir, Honorable Secretary, Mr. Vishal Barnabas sir, in organizing this conference. Over the upcoming sessions, we will hear about the recent discoveries and innovations that are pushing scientific boundaries globally. On behalf of the organizing committee and BPHES Ahmednagar College, I once again extend a warm welcome to each one of you and wish you a pleasant stay in Ahilanagar. Thank you. God bless you.
Thank you, sir, for giving such an informative overview of Ecredil's 2025. Your words have enriched this gathering with clarity and perspective. As we move ahead with the days preceding, it is time to mark the formal inauguration of Ecredil's 2025, representing growth, knowledge, and sustainability. I now request the dignitary, our esteemed chief guest, Dr. Bhushan Patwardhan, the Honorable Chief Patron and Chairman of BPHE Society, Dr. R.J. Barnabas, the respected Patron and Secretary, Mr. Vishal Barnabas, Dr. Noel Parge, the Convener and Principal in Charge, and Dr. Ivan Arhana, the Organizing Secretary, to kindly join us as we inaugurate this conference through the watering of a plant, symbolizing the promotion of ideas that will take root today and bear the fruit of innovation tomorrow. Sir, we request you to kindly inaugurate the conference. Before us stands the coconut plant, revered across India as the Kalpa Vriksha, the wish-fulfilling tree. Every part of it serves a purpose. Its fruit quenches thirst and nourishes. Its leaves gives shelter. Its husk weaves into rope, and its trunk lends strength. Nothing is wasted. So too is the pursuit of knowledge. Every idea, every discovery, every effort contributes to the greater good of humanity. The coconut is also a symbol of purity and resilience. Offered in rituals as Shrifala, the fruit of the gods, it reminds us to shed ego and embrace humility. Just as breaking the hard shell reveals the pure, white kernel within, and like the tree itself, which bends with the storm yet never breaks, let our quest for innovation stand resilient, rooted deeply in values, reaching every skyward in aspiration. As this plant is watered today, it becomes more than a ceremony. It is a living promise. May this act remind us that just as a plant grows with care and nurturing, so too does knowledge flourish when shared and cultivated. Thank you, sir. Every conference is defined by the richness of ideas it brings together. The true academic spirit of Accredit 2025 lies in the diverse and insightful research contributions from scholars across the globe. To mark this spirit, we now move to the release of the abstract book, a compilation of all research abstract submitted for this conference. Enriched with an ISBN number, this volume not only reflects the depth of inquiry, but also stands as a lasting testimony to the innovation and dedication of contributors. The abstract book has been meticulously edited by Dr. Evan Arhana and co-edited by Dr. Prasad Lamroon, whose efforts have ensured its academic value and quality. Thank you, sir. As we move to the felicitation ceremony, let us take a moment to express our gratitude to the dignitaries who are present with us today. At the very outset, I request our chairman, Dr. R.J. Barnabas, to kindly felicitate our esteemed chief guest, Dr. Bhushan Patwardhan, also a proud alumnus of Ahmednagar College and visionary who has seamlessly bridged the worlds of ancient wisdom and modern science. As he receives the token of our appreciation today, may we reflect on his journey, one of relentless inquiry, ethical scholarship, and deep commitment to healing and knowledge. May his words, his work, and his presence continue to inspire each one of us. Thank you, sir, for gracing us with your valuable presence and for inaugurating this international conference. Next, I request our principal in charge, Dr. Noel Parge, sir, to felicitate our respected chairman, Dr. R.J. Barnabas, sir, as a token of honor and appreciation. Every institution needs a strong backbone and a guiding force that provides stability and vision. For us, that strength is Dr. R.J. Barnabas. From his years of dedicated service as a principal to now stirring us as the chairman of the BPHE Society, he has held with wisdom, foresight, and compassion. Not just an administrator, but a mentor and a custodian of values. His presence here reminds us that behind every successful institution lies a leader who dreams, dares, and dedicates himself selflessly. Thank you, sir, for being the guiding strength and foundation of Ahmednagar College. Finally, I invite Dr. Ivan Arhana to kindly felicitate the Secretary of BPHE Society, Ahmednagar College, Mr. Vishal Barnabas sir, as a mark of our gratitude. Dynamic, forward-thinking and deeply committed to the growth of this institution. Such is the persona of Mr. Vishal Barnabas, our respected secretary, who represents the spirit of progress and innovation. With youthful energy and steadfast commitment, he blends modern vision with the society's enduring legacy. Sir's leadership reflects a drive that pushes us to explore new horizons while staying rooted in the values. Thank you, Vishal sir, for your constant support and encouragement that continues to inspire us all. Sir, may I now request you to please address the gathering.
Good morning, distinguished dignitaries, the esteemed guests, learned speakers, respected faculty members, dear students and friends. It is with profound honor and great joy that I stand before you today as we inaugurate Credits 2025, which was organized by the Department of Life Sciences of Ahmednagar College. At the very outset, I extend a most cordial welcome to our chief guest, Dr. Bhushan Patwardhan, a distinguished academician and a visionary in the field of health sciences, whose presence adds immense value to this occasion. I also take this opportunity to acknowledge our chairman, Principal R.J. Barnabas, whose guidance continues to inspire us. And most important, all the members of the advisory, organizing, and the scientific committees who have worked tirelessly to bring this conference to fruition. I'm especially delighted to share with you one of our own alumni, Dr. Manohar Furtado, has been now appointed as a distinguished advisor to the John Barnabas Postgraduate School of Life Sciences. His remarkable journey from Ahmednagar College to become a global leader in life sciences is a matter of great pride for all of us. And his association will greatly enrich academic and the research endeavors. Ahmednagar College, with its long legacy of academic excellence since 1947, takes immense pride in hosting this international conference, which reaffirms our commitment to knowledge that serves society and advances the common good. This conference brings together eminent scientists and thought leaders from India and abroad, alongside the research of young scholars. I am confident that the deliberations here will sow seeds of innovation and bear fruit in classrooms, laboratories, industries, and in the society at large. May this conference be a beacon of learning, collaboration, and discovery. Thank you.
Thank you, sir. Your dynamism and futuristic vision truly serves as a motivation. It is time to turn our attention to a personality whose name resonates across the academic and research world. Dr. Bhushan Patwardhan is not just a chief guest today, but a towering figure of scholarship and innovation, whose contributions have left a lasting mark on science and healthcare. To do justice to introducing such an eminent personality, I now invite to the stage Dr. Ivan Arhana, Organizing Secretary of Credits 2025, to present the formal introduction of our chief guest.
Good morning, everyone. At the very outset, I extend a warm, heartfelt welcome to each one of you to ICRIDILS 2025. It is both an honor and privilege for me to introduce to you the chief guest of this prestigious conference, Dr. Bhushan Patwardhan. Before I share his formal introduction, it gives me immense pride to place on record that Dr. Patwardhan is a distinguished alumnus of our institution. Professor Bhushan Patwardhan is a distinguished academician with over 4 decades of experience in higher education, biomedical research, and institutional governance. A fellow of National Academy of Sciences and the National Academy of Medical Sciences, he is also an adjunct professor at the National Institute of Complementary Medicine, Western Sydney University, Australia. Professor Bhushan Patwardhan is a global thought leader in integrating traditional medicine with modern science. He co-chaired the WHO expert group for the Global Center for Traditional Medicine. His contributions to policy and education reform include key roles in the National Knowledge Commission, Planning Commission, Niti Aayog, and WHO Geneva. As former Vice Chairman of the University Grant Commission, UGC, and Chairman of NAC India, he played a pivotal role in shaping India's National Education Policy, NEP 2020, introducing innovative concepts like the Academic Bank of Credit, ABC. He is internationally recognized for his efforts to combat predatory publishing. As chair of the UGC CARE Consortium for Academic Research Ethics, he led significant initiative to uphold academic integrity, including a widely cited Nature Worldview article on the subject. Among his many honors are the Sardar Vallabhbhai Patel Award, Shastra Mahamana Award, Sri Ramnath Chopra Oration, and Waldemar Afkin Oration. His enduring contributions continue to shape academic integrity, transdisciplinary research, and global health innovation. He holds 8 Indian and 2 US patents. Sir has supervised more than 20 scholars for PhD, and he has received numerous research grants. With over 175 scientific publications, a scholar H index to has received global acclamation. The newest news is that Dr. Bhushan sir has come up with this latest book, Ayurveda for Kids, Discover the Secret of Health. Designed to make the ancient wisdom of Indian knowledge system, IKS, accessible and exciting for children. The young readers will discover how to live a balanced life by learning about the power of food, importance of daily routines, natural rhythms of seasons, and the healing properties of herbs. Aligned with NEP 2020, this book serves as a meaningful resource for both families and schools, fostering cultural confidence, promoting holistic thinking, and nurturing lifelong well-being in a fun and memorable way. With these few words of introduction, it is my profound honor to invite Professor Bhushan Patwardhan to grace us with this keynote address on novel trends in drug discovery and pharmaceutical research, delivered as the Dr. Vijay Khanna Memorial Lecture. Thank you, sir.
Thank you, everyone, for this kind introduction. Coming to Ahmednagar, now Ahilanagar is like coming home, back home, coming to our own institute where we grew and probably sang the same kind of a choir which beautifully sang by all of you. We were also amongst you almost 40 years ago, you know. Those great memories still continue, and so nice to see so many people. Means I have met some of them absolutely after 40 years now. And this college has a great legacy, and we were so proud and happy that we were part of it. During our time, actually, many of us left our seats in Pune University and came to Ahmednagar because that was the reputation, and we were blessed at that time with so many teachers. Can I have my slides, please? Yeah. So thank you, the whole group of organizers, and I must appreciate Manohar, who used to be our teacher at that time. He was doing his PhD when all of us were master students. And I was telling Manohar, and on my way to my classmate Lonkar, who is also here, that all of us, we try to find purpose in life. Not that every time and everyone gets it. But I think Manohar found it, and he has made this as a mission to give back to the alma mater. So thank you, Manohar, and thank you all, Tarun, Vishal, and the whole principal, Page, all of you, all of you have done a fantastic job in organizing such a high quality international event. I miss my friend Vijay Khanna. We lost him recently, and the theme of the conference and the theme of my talk, actually, I would prefer to have a hand mic if you have, so I can stand. Yeah, thank you. Very nice comparing and very nice introduction. Thank you. So, Vijay and we all were together, and during 1979 to 81 batch of, he was in organic, I was in bio, and many of us actually, remember that time also, it used to be called as Bioorganic Day, which you celebrated yesterday. And bioorganic, why this combination is important, I'm going to tell you as I move ahead. But who's going to move that, or I have a, right? Thank you. So this is what the memories of Vijay. Actually, the whole drug discovery started from here. In the screen, if you see, there is a one person, his name is Professor Malcolm Hooper. And he actually started talking first time about medicinal chemistry. And he used to be professor at Sunderland University in UK. And at that time, he was talking about structure-activity relationships, and computer-aided drug designing came subsequently later from those ideas, because at that time, computer-aided drug designing was not that advanced. So he was actually, Malcolm was the one who actually mentored Vijay during that time and inspired him from organic chemistry pure to go into more medicinal chemistry. And that's how Dr. Khanna spent time with Dr. Malcolm Hooper as postdoctoral fellow after completing his PhD under guidance of Dr. Ladwa, And during our time, we were discussing, I was from bio, he was from organic, and we used to talk about what can we do together. And actually the course, drug chemistry, started during such discussions. And then it evolved, and right from the title of the course to its content and the first draft of the curriculum, both of us actually worked together. So I miss Vijay very much, such a lively person, and such an intellectual and such a dedicated teacher, such a passionate teacher. Let me tell you, it's not easy to start a course like drug discovery or drug chemistry in a small place like Ahmednagar. It's very, very difficult, challenging. It was ahead of time at that time also. And Dr. Nathu also helped him quite a lot. And NCL that time was like our second home, you know. And all of us were so much connected to NCL. I remember Dr. S.N. Kulkarni's group was very much involved in this. And so why I'm telling you all this is what you see today, drug chemistry is a very precious course, and you must further strengthen and expand on that, you know. So I pay my love and tribute. I tried, Tarun, yesterday my best to find out picture of Dr. T. Barnabas. Now, I could not find it on internet. And somehow I wanted, because the person who actually shaped, Dr. Hiwale founded it, but the person who shaped it, you know, was T. Barnabas, followed by J. Barnabas. And with both of them, I had such a cordial and great relationships, you know, both of them. I mean, they used to call me not by my name, you know, and this name, and that kind of a passion both of them showed, which actually gave. And T. Barnabas was also member of the university's executive council at that time. And so all the permissions which were required, his relationships with those vice chancellors at that time were also so good that Ahmednagar College used to get all priorities at that time also. So I remember, you will see him sitting here, but I could not find his solo picture, you know. And all our teachers, you know, Dr. John, of course, Jay sir, and also their wives, Manorama, and I just, even after 40, 45 years, the whole scene is in front of me, you know, the kind of care and love. There's Sarala Barnabas, outstanding professor of English, you know, that quality, and the teachers, you know, Dr. Mawal, Dr. Balani, Mrs. Balani, Murthy, Pai sir is still here. I met him some time back. So it's a great legacy. One of the first professors of Ahmednagar College was Suren Gaskadbi's father. You know, one of the first 5 who actually founded. So he is also, Suren is also here with us. So I'm really overwhelmed by today's conference. This is not just a conference for me, you know. Because for us, getting invitations for conference means we are able to hardly accept 5% of the invitations for the conferences, quite frankly. So this is not just a conference for me. This is coming back home. This is giving back a small bit to what we received from this great land of Ahmednagar College. So thank you for this invitation. While we really recognize all those stalwarts who founded, we must also recognize all those who actually shaped the drugs and pharmaceutical research in India. You know. And except for the first one, Ramnath Chopra, Sir Ramnath Chopra, after whose name I was fortunate to deliver an oration at Indian Pharmacological Society, except him who is on the top, who is considered to be father of pharmacology in India, you know, and also the ethnopharmacological traditional medicine research or Ayurveda research is Colonel Chopra. Except him, almost everyone you see on the screen, I have been fortunate to work with them, interact with them, or get their guidance, you know. Many of the names you may know, Dr. Mashalkar you see on the screen, Dr. B.M. Hegde you see on the screen, Dr. Ashok Vaidya, many, the whole directors of CSR institutes like CDRI and many others, I pay my respect to them. So coming to the topic of today, you know, health, drugs and pharmaceutical research. I'm going to be a little brief. I'm not going to explain all the points, you know, because of the time shortage, but I just wanted to bring those points on table just for your consideration, because you are students of biochemistry, organic chemistry, zoology, microbiology. At that time, microbiology was just next door, you know. This was such a visionary thing, you know. In one building, you are getting practical, and that door was not closed. Nowadays, we see departments, you know, adjacent to each other, but then there is a door which closes in between them, you know. I don't know whether it is open even today, but if it is not, you should open it up, you know. Yeah, thank you. Health, drugs and pharmaceutical research. I must tell you that although there has been tremendous progress in biomedical sciences, means we have done wonders in biomedical sciences, but still we are facing many unmet needs. In fact, we are facing global crisis in healthcare. It is deepening. Although powerful medicines are there, antibiotics are there, painkillers are there, anti-inflammatory drugs are, new vaccines are coming up, and if we ask this question, with all this, are we really getting closer to health, or we are getting away from it, And if you compare it, what our forefathers were there, our father, our grandfather, and if you compare their health with our health, are we really becoming healthy or not? So what it is, where are we heading? We are trying to get some answers in this, Affordable and accessible health care is a distant dream, Means today in advanced countries like America also, it has become really like a nightmare, Healthcare has become a nightmare. Without insurance, you can't survive in such countries. So we are unfortunately going on the similar kind of a path, losing our own tradition and our own path, following something which is proven to be not good, not effective, and not advisable. So I'll not explain all the points which you see on the board, but let me tell you that biomedical research, this is a data not from me, but actually published in a most reputed journal, Lancet, and what John Ioannidis from Stanford, he did this paper. 85% of the research which happens in biomedical field is going to waste. What does it mean? It is of no use to either people or nature. That means more and more people are getting involved in Me Too research, incremental research. Most of the papers end by saying that more research is needed. So this is what is, there is enough data now. Most scientific studies are incremental to prior evidence, not disruptively innovative or non-reproducible. Many of them are actually non-reproducible. That is a big worry, which I may expand in a while. So biomedical research focus today must shift from mere symptomatic inventions, to something which is needed. Immunity and inflammation should be at core. Food and nutrition should be getting back on the table. Lifestyle and behavioral modification, mental health, stress management, health technology, and medical humanities. Not just pharmaceutical drugs, diagnostics, and therapeutics. Because we talk about healthcare, but the question is, are we really giving healthcare? We are giving sick care. We are giving medical care. We are not giving healthcare. Healthcare is a typical Western notion, and they started using term healthcare because they addressed basic needs of health. Nobody squats there on road, Means this is what they could achieve. Good, pure, safe drinking water, safe air to breathe, These are some minimum things which you require. Once you have that, then something else is needed, And that this call is healthcare. But we have to take care of first our basic amenities and basic requirements of health, which are nutrition, lifestyle, environment, and fourth is genetics. First three are in our hand. We can decide whether to go on a healthy path or unhealthy path, So this is what, so focus on planet, person, promotion, prevention, prognosis, and physiology over pharmacology. Today our focus is on pharmacology. We are losing physiology, and focus on health and well-being than medicine and treatment, because medicine and treatment is needed when you lose health. But first, protecting health is more important. Discovery should be a pleasure, Those who are working in drug discovery, we use this term like discovery pipeline. Discovery pipeline is not something very mechanical, It should be a pleasure. Research should be a pleasure. And because we have converted into a pipeline, from preclinical to clinical and to then regulatory review, out of almost 10,000 molecules which we get, if we are lucky, one might get approved. This is what is called the bottleneck or major challenge in drug research. We have so many molecules, but we don't have safe molecules which can be converted into drugs, and it takes 1.5 billion. Now the cost is even more, and maybe 15 years, if you are lucky, you will get one. So now the new trends what we are talking about, because technologies have been evolving, and every time new technologies come, hypes come. And we start expecting so much. I remember when genome was evolving, Human Genome Project, the hype was created. When bioinformatics was created, the hype was created. We thought that we are going to get into a magic-like situation by bioinformatics-like tools, we are going to get newer and newer drugs so fast, which has not resulted really in reality. The average rate of successful translation from animal models to clinical cancer trial, for example, is less than just 8%. So you can imagine what kind of a situation we are trapped in. US FDA, for example, approved almost 600 chemical drugs and 400 are biological. Remember now the shift is happening, already happened from chemistry to biology. And you will see that it is happening primarily because several reasons. One of the reasons is our earlier or even today we think that to manage something we have some target, and we have limited understanding of target in the whole system. So we have understanding of single target, and we can try to get a single molecule which can address that target. So one target, one molecule was the common way to discover drug. But now we are dealing with complex diseases, syndromes, polygenic diseases in which one target is not enough, And so safety also has emerged as a major problem. Safety, you would be surprised to know the list which you see on the screen, from 2000 to now, almost every year, drugs are withdrawn from the market. And remember, when drugs are withdrawn from the market, huge amount of expenses are going to waste. Huge amount of efforts are going to waste because, and then these questions come that if the drugs have gone through so much of regulatory careful evaluation, why they are failing after this? You will be again surprised that there are many studies which show that many of the clinical trials are non-reproducible. Many of the clinical trials go in favor of the sponsors. So what? Earlier we knew only this data regarding tobacco industry. We knew that tobacco industry handled in a particular way so that the results of the research went into their favor. But nothing different is happening, unfortunately, even in pharmaceutical industry. That is what is more worrying. Among novel trends now, let's look at this shift which is happening. The era of biologics in drug discovery is actually going very, very strong. Initially, organic chemistry drove discovery of small molecules, and therefore, at that time, at postgraduate school, when Ahmednagar College decided to establish biochemistry and organic chemistry in one building, that shows the vision. That shows the vision. Today, it has become a reality, not only reality, dire need that biology and chemistry must work together. Without that, you will not be able to address current or future problems, biologics, including biosimilars, monoclonal antibodies, therapeutic proteins, nucleic acids, cell and gene therapies, they are all reshaping biomedicine, And the future drug discovery lies in the synergy of chemistry and biology working together. The next revolution is from the fusion of chemistry and biology. And that's what I said, that what Vijay Khanna introduced by combining biology and chemistry together to form a MSc drug chemistry course was another visionary effort. This is just a small example just to give you that how the shift is happening. Earlier, we were dominated by small molecules. If you see here, small molecules and just little bit of biologics, and that biologics also mostly were vaccines, and not really therapeutic proteins or other products. Now almost 50-50, 50% whole sector is now occupied by biologics, and you will see that that biologics portion is going to go even more. And therefore, the need for now courses, even the pharmacy courses, we are now revising very drastically, because in pharmacy, there was hardly any biology component. So we started MPharm in MPharm in biotechnology at Pune University. That was the first course, MPharm in biotechnology. Because unless pharmacists know how to manage proteins as therapeutic products, their survival in the market is going to be very difficult. Today they might know how to manage chemicals as therapeutic agents, but handling or using biologics as chemical agents is not really very easy. It needs a very, very rigorous training, and that's what was missing. Among some of the trends, again, artificial intelligence, machine learning in drug discovery is coming in a big way. Targeted protein degradation, they call it as TDP. It actually degrades disease-causing proteins in a targeted manner. So this is what another trend. RNA-based therapeutics. Yesterday you might have heard about some of the RNA-based work related to vaccine. Organ-on-chip, micro-engineered system mimicking human organs, and these are some of the trends which we see. In pharmaceutical research, we saw that. In medical research, we are seeing now personalized or precision medicine. And that's what the actually basis of one of my research. In 2000, I hypothesized that Ayurveda is personalized medicine. And why? Because Ayurvedic Vaidya will give you medicine which is designed for you. If somebody else goes with similar symptoms, he or she may not get the same medicine. Why? Because that medicine is designed for your Prakruti, based on your Vat, Pitta, Kapha. So I hypothesized in 2000 that Vat, Pitta, Kapha has genetic connotation. And a small experiment which we did as a part of my master's student dissertation, on the first PCR which came to Pune University in 2002, Dr. Nathu would remember that, we showed by taking just one gene, because at that time whole genome was not possible, and taking HLA-DRB1 gene, we showed that the gene alleles were distributed statistically different in Vat, Pitta and Kapha. We published that, and we also presented it at Cold Spring Harbor Symposium in Pharmacogenomics in 2005. Now, a small study which started from a small lab, has grown into multi-crore discipline now known as Ayurgenomics. So this is what is the power of even undergraduate dissertation. Why I'm telling you is, so many students are here, don't undermine your power of doing innovations at even undergraduate level. If you get that opportunity, you must, and you have a very good legacy and very good facility on your own campus to do all that. Natural products have remained the foundations of modern days. Why? Because if you look at drug history, from where these drugs, today's drugs, from where they have come. If you go back to their origin, you will find that even today, more than 60% of the drugs which you will find in any chemist shops, I'm talking about pharmaceutical drugs, if you track back their history, you will find that they have history somewhere in traditional knowledge, including top-selling drugs like today's metformin or Taxol. Most of them have come through these routes. So, drug discovery, one of the approach along with this target-based approach and phenotypic approach, what we follow in our own research, we call it as reverse pharmacology approach. Reverse pharmacology approach meaning in normal drug discovery, we start by chemical synthesis, we create some molecules, we test them, maybe first on cells, then on animals, then if found suitable, then we take it to men or so mice to men. M in M is not gender discrimination, but just give you M and M. So this kind of a process from animals to human beings is exactly reverse, because if we use Ayurvedic medicines as a source, then people are already using it. So take them back to the laboratory. So here, from humans to laboratory, that's why we call it as reverse pharmacology. And by doing this kind of a reverse way, there has been tremendous short, but we are able to take. And for this purpose, we were given a huge grant by CSIR under the new Millennium Indian Leadership Initiative program, which we created a national network of institutions, and we showed that normally otherwise you would need a couple of crores of rupees, and more than 15, 20 years, we could do same work in hardly 15 to 20% of the cost in just matter of 5 years. And that led to what you heard, 8 patents and 2 US patents is result of that work. So it's a tested, successful, novel method for drug discovery, which is based on traditional medicine or Ayurvedic medicine. So 4 lessons I'm just going to share with you, which I learned during my 40 years of career. First lesson I learned at Ahmednagar. When I was doing my biochemistry, I decided that unlike my friends, and tomorrow you will see, or today also, you will see some of my friends talking to you. And some of them have really reached to top. Tomorrow you will listen to Chitra Manohar, who is now heading the new division in Roche in the US. And she will talk to you tomorrow. But that time, most of them were going in enzymology, evolutionary biology, or protein chemistry. We had an excellent amino acid analyzer, which was a luxury at that time. I decided I want to work on Ayurveda. And Dr. John actually encouraged me to do that. Otherwise, normally at that time, if you say that I want to work on some medicinal plant, people used to laugh. What are you doing with this jhadpatti and gaskad? You should not do, there's a great science are coming out, there are very good facilities, don't waste your time. But he encouraged me. And then I did my MSc project at Serum Institute of India. And why? Because Dr. Kapre was heading R&D at Serum Institute at that time, and Dr. Kapre was also alumni of Ahmednagar. So I could get. So you will see that how these connections work. Just Dr. John's one phone call to Dr. Kapre, and he welcomed me at Serum. At master's level, I could go there and do my experiments, because my work needed Clostridium tetani, which was obligate anaerobe, and it was not easy to do that. Later on, we established a small facility of anaerobic cultivation even in our microbiology department. So although I was biochemistry student, I was working with Vijay in organic for separation. I was working with Francis in microbiology for antimicrobial activity, and doing biochemistry in my own department. So this is how students also should work. You should not limit yourself only to what department you belong to. These boundaries or these walls are just notional. You should break them, and you should become interdisciplinary, because that is what is the future. You cannot get isolated, and you should bring collaborations, because my work, I remember, not only I did in Serum, but I did at that time even at Hindustan Antibiotics. Because one particular machine, which is simple machine today, which is known as sonicator, I just wanted to break down cells. There was no way to do that anywhere. So I used to go to HA, Hindustan Antibiotics, just for doing that sonication work there. So Hindustan Antibiotics was there on one side of Pune, and Serum Institute was there on other side of Pune. But that time, traffic was not that bad, so I could do that. What I'm telling you is, again, students should take your dissertations seriously and try to do something different, not just incremental. Your past student might have done something, just do something with some other culture and just complete your thesis or dissertation. This shortcut will not help you along. And as a result, even at the master's level, I could publish in journal. Master's level work was published, and co-author, Serum Director Kapre. So that first paper of mine, which was published, I still get so much happy to see that, and then, so believe in our own heritage. If I would not have believed that, no, Ayurveda has some potential at that time, I would not have been able to do that. So believe in your heritage, but don't get trapped into self-pride and past glory mode. Don't say that we know everything. It's a learning process. Second lesson is respect and explore. That was the next decade. In 1990, I went to Pune University. There we established School of Health Sciences, and Then 1997, the first US patent granted to Indian individual on formulation at that time. That was for the treatment of arthritis. And then that was because we respected, and so many, including Harvard Medical College or Massachusetts General Hospital, we collaborated, and we could really do a lot of work and published in mainstream journals. All that. The network and collaborate. Yeah, so CSR Nimitli was one such example wherein we created a national network of top institutions, including NCL, CDRI, NBRI, and several others, for this purpose. CDAC, we developed a software known as IUSoft with CDAC, which captured the logic from Ayurvedic text, for a decision support system. Fourth lesson is integrative approach is best. Allopathy has great power, immediate fix. If you are in great pain, you have painkiller, take it. But for chronic diseases, for many mental conditions, allopathy has limitations. So for that purpose, you may opt for whatever best in other systems of medicine. So integrate it. So integrative approach is best. And the last is adversity also offers opportunity. I was chairing National Task Force on COVID-19, on behalf of Ministry of Ayush. And we created a national network of almost 70 institutions all over, including top allopathic hospitals. And we could conduct a huge amount of research. You will see that out of that, just for prevention, there are 42 clinical studies, therapy, 50 studies, and preclinical studies done at top DBT institutes. We showed that many of the ingredients from Ayurvedic medicines could have antiviral activity, which was shown in the Syrian hamster model, which was at that time very widely used for COVID-19. So, in short, one target, one drug pill, that is now going into more targets and polypill. Polypill is not just mixing drug, it's not polypharmacy. It's a rational designing, and from drug discovery, we are saying that we should move into formulation discovery. And formulation discovery is not mixing up 2-3 things together. Formulation discovery, you need a very powerful tool, what we call it as network pharmacology, which we practice. At one time when I was studying biochemistry, this is a chart from Leninger, which was kind of a Bible for us. And even today it must be, I'm sure, but at that time was. And our biochemistry was limited to what you see on this screen. Literally, this was the knowledge of biochemistry at that time. But now when you see Google metabolic chart, this is what biochemistry or metabolism today is, wherein that chart which I showed you may be just a small portion of this whole thing. So if this complexity is now known, and if we still think that a disease like diabetes can be managed or treated by getting one molecule addressing or one target addressing by some one molecule, I don't think we are really being realistic. It is impossible to treat disease like diabetes by giving one drug. You have to have a very, very different and holistic approach in which lifestyle and diet also plays even more role than pharmacology. Therefore, physiology is more important. I'm going to skip all this now very quickly. So in short, we are saying that we should move from drug discovery to formulation discovery, and for that purpose we develop these networks, pharmacological networks, and these pharmacological networks help you to identify synergy between molecules. Which two molecules, if you combine, will give you better results. This kind of information you can get, and based on that actually you can make molecules. There we have done, I'm going to skip these slides just to show you that these are also very sophisticated tools to tell you how to design a formulation. And we have been using it. These are examples from our own work. Again, I'm not going to explain, but this work, some of this work also has been done in collaboration with Serum Many of my PhD students are currently working in serum, and we are actually trying to develop a new vaccine adjuvant, which is an immunoadjuvant based on Ayurvedic medicinal plants. I'll skip this technical part today, but this presentation will be available, and those students who find it interesting, they can contact me, and if they want to take similar kind of a work, we'll be happy to mentor that. Most of my work has been on ashwagandha or Vidania somnifera for their immunomodulatory activity, and today ashwagandha has become a global bestseller. And this is our group co-researchers network. Every dot you see here represents our co-researcher in one part of the other in the world. The next cluster is organizations. So many organizations we have collaborated with while doing all this work. It's not single Pune University alone, or not only my department. And the last one is all these countries, different countries, not only India, but all these countries which you see, every dot represents one country. So you need to do this kind of work. We have been able to publish only during COVID time, a huge amount of work. You will find that if you go to PubMed, for the first time, research based on Ayurveda has been published extensively in top cited journals. Ashwagandha has become now a global blockbuster, but the study on ashwagandha started in 1994 with first paper published by my first MPharm student, Anuradha, who did pharmacological comparison of ashwagandha with ginseng and showed that ashwagandha is better drug than ginseng in 1994. At that time, ginseng was on the top. Today, ashwagandha has gone top. But this doesn't happen automatically. From 1991, work on ashwagandha we started, and today also we continue to do that. All this work leads into the success. So it's not easy. More than 4 decades, 3 decades of the work, now you see visible ashwagandha. And not only our group, several other groups are also working. And Dr. Gaikavari is now here. He also has developed excellent facility for extracting actually medicinal plants, because how to give those medicinal plants in a scientific way is also a challenge. So all this finally resulted in World Health Organization recognizing Ayurveda and establishing their center for the first time outside European region. A WHO center has been established in India at Jamnagar. I was co-chairing that task force which led to establishment of this. And WHO Bulletin has given an open call now on traditional medicine and global health, to write. So it shows that how small work can lead to a large impact if you are really genuine and if you are able to really create a whole group. And Manor, I'm very happy that you have created this kind of a network here. I can see that there is a potential, there is a bright students here, and there are very, very committed mentors. So if this combination comes together, a lot of innovation can happen. And Vishal, I would suggest that you can also consider, like you have many other innovative ideas, you are starting school, or Tarun, you can also do so many things, this diploma or polytechnic, what you're talking about. Along with that, create a small area near your biology area, and let that area be an incubator. Let people come there, invest their time, let people invest their resources also. And ICER has done a very successful thing. Dr. Nathu and many others, they are willing to help you. So if you are able to really create a small kind of a research innovation park here, and with help of all those alumni who are willing to help you, this can become a knowledge center, very, very powerful idea center for future pharmaceutical and health research. So with this, I will not again go into details, but just to end my talk, I'll tell you that although the level of research is increasing, high, very big, there is more funding coming in, many and many people are working on research, At the same time, the ethics level in research is going down. We saw one largest pharmaceutical company in India crumble down just because of ethics compromise. Nowhere, their name also, new generation may not know their name also. They have but at one time, that company was dominating India, #1 company, Ranbaxy. You don't even know where it has gone. And it has gone just because of ethics compromise. And Saroj also has worked in Pune University, you know, when publishing in Pune University was going on wrong direction, you know. There was a committee to bring it back, you know, and we created guidelines to publish. So please stay away, students, from this kind of a unethical trend in scientific. Scientific integrity is extremely important. Don't compromise on that. Don't get lured by people who will tell you, come and publish in our journal by paying money. Don't do that. It has it will actually disrepute your reputation in future. So these are things which will attract you. Maybe for temporary, you will find that you will gain something, but in long run, it's of no use. So today, we are actually facing the existential threat of greed. And greed in pharmaceutical industry especially is becoming a major worry. Many top scientists and top industries and top journals have openly written about it, and they keep on writing about it. And so in my book, which is my last point, I have made this argument that science, by and large, has been used to satisfy our own greed, to pamper our own ego, to get our own promotions, to get more and more profit, and not that much for people or planet. So we are saying that science has to move, transcend into meta-science, what we call it as meta-science. And that's what I have tried to articulate in the book, Genome to Home. So students also, I would suggest that you should read that book. And Dr. Gaikar was telling me, I started this book. Dr. Nathu told me that he has started reading that book, and they are slowly moving further. But that book, when people ask me what is the genome to home, whether it is science or spirituality, what it is, what is the eligibility. So I tell them that the only eligibility to read this book is curiosity. If you have curiosity, you can easily read this book and move ahead with that, because we are providing the basic information for, and we know that the information which we are giving in this is a small drop in large ocean of knowledge, but we have tried to see that that small drop is as pure as possible. You know, so Jnana, if it is information, Vijnana is specialized Jnana, Vishesha Jnana, specialized Jnana, not enough. It has to move to Pradnyan. So Jnana, Vijnana to Pradnyan, that's what modern science to meta-science talks. Thank you. I really dedicate my achievements to Ahmednagar College. All my achievements, whatever, I won't call it as success, I will say achievement. No, success or not success, people have to judge. But to Ahmednagar College, and especially to John Barnabas Postgraduate School for Biological Sciences, to my inspiring teachers, such as John Barnabas, and to cherish friends like Dr. Vijay Khanna. Thank you very much.
Thank you, sir. We have gained profound insights into the evolving landscape of drug discovery and the transformative ideas that are reshaping the future of pharmaceutical researches. We are deeply honored with your presence with us today, sir. Thank you very much. As we draw the curtains on this inspiring inaugural ceremony of Ecredil's 2025, let us carry with us the fragrance of vision, wisdom, and innovation that has filled this morning. From the symbolic act of nurturing a plant to the unveiling of ideas through the abstract book, from the valuable words of our dignitaries to the informative keynote, all together have sown seeds of knowledge that we hope will grow into fruits of discovery and collaboration. Truly, this has been a morning of inspiration reflection, and new beginnings. On behalf of the BPHC Society's Ahmednagar College, it is now my privilege to extend a heartfelt gratitude to all who have made this inaugural session a memorable one. To start with, I express our deepest gratitude to our guiding force, the chairman of the BPHC Society and chief patron of this conference, Dr. R.J. Barnabas, for the vision and encouragement. I warmly thank our patron and secretary, Mr. Vishal Barnabas, for his leadership and constant support. A sincere word of appreciation to our principal in charge and convener, Dr. Noel Parge, for stirring this conference with dedication. We are grateful to our organizing secretary, Dr. Ivan Arhana, for his tireless efforts and thoughtful planning. A special thanks to Dr. Manohar Fatardo, advisor to the John Barnabas PG School of Life Sciences, for his direction and guidance. With immense pride, we thank our chief guest and distinguished alumnus of Ahmednagar College, Dr. Bhushan Patwardhan, for gracing us with his presence. We extend our heartfelt appreciation to our sponsors and proud alumni, Dr. R.P. Gaikwari, Dr. Vishnu Halnur, for their generous support. I would also like to acknowledge the sincere effort of abstract team headed by Professor Prasad Lamrood, the registration team led by Professor S.R. Bale, the transportation team under Dr. Avinash Vanzare, and the stage committee led by Dr. Pavanjit Chabda and Ms. Anuja Bhalerao. A note of gratitude to the Faculty of Life Sciences Department and our enthusiastic student volunteers whose dedication has made this event possible. We also thank our media partner, Mr. Sai Suram, for capturing the essence of this event. Moving on, I thank the registrar, Ms. Kalpalata Bengar Deve ma'am, for her constant support in administrative matters. Above all, I extend heartfelt gratitude to each and every participant, delegate, scholar, faculty member, student, and well-wisher who has joined us today. Your presence and active involvement have truly made this inaugural ceremony of Accredils 2025 a grand success. It is your enthusiasm and support that brings life and purpose to such gathering, and for that, we remain deeply grateful. We invite all our distinguished guest speakers and participants to join us for high tea, which will be served in the adjacent hall. As we may run short of time, may I kindly request all to proceed promptly. Thank you, and we look forward to a day filled with insightful presentations, discussions, and collaboration that advances the research in life sciences. Thank you all. a very good morning to one and all present here. I welcome you back to the International Conference on Recent Discoveries and Innovations in Life Science, ECRIDLS 2025, organized by the BPHE Society's Ahmednagar College, Ahmednagar. Before we proceed to the much-awaited sessions of ECRIDLS 2025, we would like to take a brief but significant pause for a small felicitation ceremony. This conference is a collective endeavor, and there is a stalwart among us whose presence and support are invaluable. It is a privilege to take a moment to honor them. I request Dr. Ivan Arana to kindly felicitate Miss Rita Katwati, Principal of Hutchings High School and Junior College, Pune, one of the esteemed trustees of the BPHE Society, Ahmednagar, a respected educationist and administrator. Her leadership continues to inspire the academic community. We are truly honored to have you with us, ma'am. We have with us Vishal Barnabas, sir, the Secretary of Ahmednagar College, who will be felicitating Ms. Rita Katwati, Principal of Hutchings School and Junior College, Pune. Thank you, ma'am. Thank you, sir. I once again request Vishal sir to please felicitate Dr. Noel Parge sir, Principal in charge of Ahmednagar College and the convener of this international conference. His able guidance, tireless efforts, and inspiring leadership have been instrumental in bringing ECRIDLS 2025 to life. Sir, we are honored to felicitate you. Moving on, I would request the Secretary, Mr. Vishal Barnabas, sir, to kindly felicitate Dr. M.B. Mehta, the Distinguished Director of the Institute of Management Studies, IMS. His commitment to academic excellence and professional education has been a pillar of strength to the BPHE Society. Sir, it is a privilege to honor you. Lastly, sir, I would request you to kindly felicitate Dr. Suresh Pathare, the respected Director of the Center of Studies in Rural Development, CSRD. His contribution in the field of social sciences and rural upliftment embody the true spirit of this institution. Sir, we are delighted to recognize your presence with us today. Thank you, sir. Thank you, sir. We extend our heartfelt appreciation to all of their presence and support. The guidance continues to enrich and strengthen the legacy of Ahmednagar College. As we are now about to begin the session, may I kindly once again request everyone to put their phones on silent mode and help us maintain the decorum of the conference. I repeat, as we are about to commence the session, we request you to please mute your mobile phones and contribute to the smooth conduct of the presentation. We now move forward to the invited talk scheduled for this morning. May I humbly invite our session chair, that is Dr. A.M. I'm sorry. I'm sorry for the glitch. May I humbly invite our session chair, Dr. A.M. Karunanidhi and Sadashiv S.O. Sir, to kindly take their seats on the sofa in the front row and chair this session. We are honored by your presence and grateful to have you as the chairs for this session. I'm once again extremely sorry for the glitch, sir. The session begins with a presentation that promises to inspire us with reflections on the very essence of scientific pursuit. It is our privilege to introduce our distinguished speaker for this session. The speaker for this talk is Dr. Jai Prakash Mulyal, whose vast experience and thought-provoking perspectives have guided many in the field of science and beyond. Dr. Mulyal will deliver a lecture titled Life in Science. Is it a pursuit of fame, fortune, or truth? A theme that invites us to introspect on the deeper motivations behind scientific endeavors. His wisdom and insights will certainly add richness to our deliberation today. To formally introduce the speaker, I now invite Dr. Manohar Furtado to please do the honors.
Thank you everyone for attending this session. It's my pleasure to invite Dr. Jai Prakash Mulyal to give the next talk. I mean, Bhushan kind of told you that most of industry is after fame and fortune. Maybe he'll tell us more about the truth. So we'll learn something from him. Let's see where we go with the scientific dialogue. So Dr. Mulyal finished his early degrees in Calicut, joined CMC Vellore, finished his MBBS and a degree over there, and later on his MD degree. He started a program on community health. One of his key achievements is to completely eradicate leprosy in that particular area. So he was the director for the leprosy program there for many years. Following that, he went to Johns Hopkins in Baltimore and got his degree on an MPH degree and further degrees in terms of doing epidemiological work. His work has been very constructive in helping the Indian government, ICMR, modulate treatments, vaccine introductions. He's a chair of the Scientific Advisory Committee to ICMR. He's also on WHO boards and an advisory capacity in terms of how and when to introduce new vaccines, characterizing efficacy, and has done a lot of clinical trials. Honestly, it doesn't need a lot of introduction. He's one of the few people I know who have their own Wikipedia page. So you can find him on that. He's also been on TV explaining the pandemic at a number of channels. So with that, I'll invite Dr. Mulyal to come and give his lecture.
Thank you, sir, for your gracious introduction. I now request Dr. Noel Parge, sir, to felicitate our speaker, Dr. Jai Prakash Mulyal. With this, we warmly invite Dr. Mulyal to deliver his talk.
Thank you very much, and Manohar for the kind words. But I was trained to be a doctor, and that is not surprising because when my mother was carrying me in her womb, there was a baby's calendar in our house. And my father wrote there, Dr. Jai Prakash Mulyal. And I happened. So I had no choice, I think. And many often our wishes, dreams are formulated, very early in life. So, I'm not taking credit for any of those. But what happened was, I was programmed to become a doctor, and I had no way of getting anywhere near. And at that time, luckily, I got into CMC. And I remember that day when CMC, my papers came, they looked, it was a very cheap by general standard, but we couldn't afford it. So we made a decision, my father and me, that I would rather go for MSc after my BSc and start earning quickly rather than go for a long course. But again, the dreamer, my father, decided, no, you go there. We'll see how we can manage. So I had to borrow money from CMC to study. At the end of the thing, I had to pay back in kind. I had to work for 2 years for CMC. But they gave me an option. Where do you want to work? The department you choose, and you can work there. Now, there are two. I said, this is the department which nobody wants to go. And that was a department called Public Health. So I said, I'll go there. In the department, I looked around and said, which area does nobody wants to work? And I said, and they said, leprosy. Nobody wants to work there. So I chose that. Now, the point is this. Very often we do it differently. Which is the best place to go? Where I can get the maximum? Which is the place where you, product, whatever it is, you gain something. But I thought I am not fit for that kind of a proposition. Whatever my limited resource, I'll be able to contribute more, and I'll have a little more satisfying life. I did. As a matter of fact, my rest of the life was shaped because of my decisions made. I became an epidemiologist subsequently. But a village work I did the first 2 years was quite transformed. People taught me so many things, and I realized there is a world that actually don't belong to the rest of the country. And I have my heart for them. And I've always had that. So now I'm talking about technology today, and you have to understand, I have certain biases, forgive me, and I will explain to you in a little while. Medicine today is fabulous. In 1930, a doctor was a descriptive scientist. He will look at cases, diagnose a syndrome, and do all the, clinical tests. And after that, nothing. There are no therapeutics. Okay? Even tuberculosis could not be treated. Leprosy could not be treated. And then the whole thing got transformed. Even in my case, when we were in CMC as intern, most cases of leukemia, we didn't know how to manage. And we were lost. But now, they go back, grow up, get married, have children. The world is transformed. So, absolutely, the whole thing has been very transformative in terms of ability to deal with very difficult problems, which in 1977, we didn't know what to do with. So that whole thing was a technology of various kinds that has came running in. But there are some side effects also, and the earlier speaker referring to them. George Bernard Shaw, you must have heard of a playwright. He wrote a play called uh, Doctor's Dilemma. Anybody read it? Likely. That came as a movie later on as My Fair Lady. And he wrote a book. Anyway, my Doctor's Dilemma, he describes a town where the judge and the hangman is the same guy. Judge and the hangman. But the guy was paid only according to the executions he did. So first he sits as a judge and he decides what will happen to the prisoner. Then he go to the other room and does his work and earn the money. Now, and George Bernard Shaw warned, medicine is becoming something like that. If somebody comes with an ingrowing toenail and you remove the toenail, you may get how much? 500 bucks. But if you do a below knee amputation, you will get 5,000. What would you do as a doctor? Choose below knee or nail removal? And this problem has become very magnified. What happens is that money complicates everything. And it is become, so you worship money and you work for money. Finally, you don't know why you worked all your life through getting these bills. And so I wanted to warn you youngsters that your life is so important, so valuable, and you could make a huge difference in many people's lives. Now, Mano told you that leprosy was one of my areas I was working in. And we had an endemic situation of leprosy. It's a huge number of patients. At any given time, I will have 5,000 leprosy patients that treated for. They come with claw hand, lag ophthalmos, all kinds of nerve damage, and many of them become beggars. And social isolation is usual routine. Now, there is no way we could eradicate leprosy by treating. There's no way. Why? Because leprosy was everywhere, bacteria. Even normal looking people, you examine the nose, you will find M. leprosity there. In other words, there are healthy carriers. So such a disease, if you treat all the patients, can you ever hope of getting rid of the disease? No way. But World Health Organization, in its wisdom, said, we can. So we changed the name from Leprosy Control Program and we said leprosy eradication. Now, one of the things that you change titles outside what it looked so that people be motivated. But I remember asking the question, how can you ever get rid of leprosy with treating known patients? So they said JP doesn't believe in eradication. So actually they threw me out of all the committees and went on. Now 2000 AD, the leprosy, 2000 December 30, India was supposed to eradicate leprosy. But they could not. There are too many cases coming, too many cases. But they decided somehow by 2005 they eradicated. So India was given an extension. And they did. They eradicated. You know how they did it? They stopped registering leprosy. Okay. Now that is the ability India has, can do anything. And finally, there was a dinner in Nirman Bhavan, in Delhi, where everybody is invited to celebrate eradication. We still diagnose more than 100,000 cases of leprosy in India today. Why do we perpetuate falsehood? What is in our culture? And I think what I feel very often is that purely medical area, we have a problem which is major. Most diagnosis done, diagnostic tests we carry out in India are unnecessary. They do it because the physician who does that, it's a cut. You send for a scan, get a cut. Now, most of the drugs written are wasteful. Again, there is a cut. And most surgeries done, that is the sad part, are wasteful. And one of the studies we did in Chennai was on private hospital. And we discovered there is one private hospital where the cesarean section rate was 100%. Normal delivery is gone. In fact, that is the level of, what do you call it, corruption that has gone into that. I think we have an alternative. We continue to. I grew up in CMC, and where the commitment to do only ethically correct care is very strong. So my talk is about, are you going to be a scientist for sake of fame, which is good, fortune, which is even better, or to identify some truth? And this particular pursuit is so fascinating. Many people who actually pursue good science. And to you, the answer is, yeah, all three. That is correct. But one thing is that whenever you go, whatever you, please remember that these things, when you do wrong, it will come back to you. Many things. For example, I now staying in Vellore. Why do I stay in Vellore? I am retired in Vellore. But CMC provides us with free health care. Okay, for the whole staff. I am scared of doctors. If I go back to Kerala, where I come from, how do I go and face a doctor when I am sick? I know they can do. Now, how do we have a profession that we have created that way? I am not saying all doctors are bad, but the problem is the system has created that way, that you are rewarded and rewarded for wrongdoing, and that becomes pain. Now, in your curriculum, we are going to be taught that number one, we innovate. All these things are great, but some way you lose your soul, and that is what you should prevent yourself from happening. And how do we do that? I remember many years ago, I was an intern at that time. A young man, his father and a wife came. He had tetanus. Now you may remember tetanus is a disease caused by a bacterium called Clostridium tetani. And this organism is there everywhere in the environment. You can't get rid of it. Now once it gets into you, and usually you get it through some kind of a perforating, and in that process, it grows in and it grows, and it produces a toxin. And the toxin produces spasms all over your body. And it's a very painful way of dying. Now, some scientists discovered something called tetanus toxoid. And it is a simple technology. Toxin by itself is too small a molecule to induce an antibody reaction. But he modified slightly and made it toxoid, a little larger molecule. Now body can recognize and produce anti-tetanus antibody. Brilliant. It prevented a whole lot of people from dying. But my problem was when this guy already came with tetanus, and tetanus has a known mortality of 30%. And I remember as they came, his wife was there and a 2-year-old son walked up to you. He walked into the ward and nurse said, no children allowed here. So that I sort of registered in my mind. I didn't interfere. We never interfere with nurses. And we said, okay, but this guy kept getting worse. And I remember as an intern, I had to start him on gentamicin, those days, modern drug. And I gave her a prescription. She came back running. What? They are asking for 100 rupees. So I called the consultant. What do I do? Now we are talking about CMC Vellore, okay? But there is a lot of charity going on. But my consultant said, no. She will pay. You know, you have to know how to ask properly. So I asked her, listen, you have watched me, how much I struggled with your husband to save. Can't you do at least this much? So she looked at me, walked off, came back with the drug. I said, not bad. And I admired my consultant for a moment. Smart fellow, he knew how to get the money out. Then she showed me the string around her neck. I've sold my thali, or you call Mangala Sutra. Okay, that's the only little gold I have. Please don't ask me. I felt so guilty about it. Now, when next time next day I came, she was sitting under the bed of the patient and crying. I said, listen, this medical college, the best medical college in the country, we will save your husband, don't worry. She said, I'm not crying about my husband. You remember my son walked only 2 years old. And you said you can't have my son inside the club. I sent him along with a neighbor. And nobody was watching. It so happened that he was running around playing. He fell into a well, died. And the next day, the husband died. Now to her, coming to a hospital was not a profitable endeavor. How do you transform healthcare? How do you transform hospital? And these are important questions we still ponder about at work. And I remember after that, every time I admitted somebody, I'll ask, do you have a young child at home alone? Yeah, neighbors will look after. I said, no neighbors. You bring the child along in a hospital, take care of. This is a small thing I'm talking about. But I'm talking about humanness. And when you lose that touch as a person and your greed overtakes you, you are not a helpful agent for country. You are actually a kind of a parasite. So what I want you to remember is that Your life is too precious to be wasted on unnecessary, wasteful. You have to make contribution. Please ask the question, where can I contribute? Where can I give? Rather than saying only one question, where do I get most? Which would be a losing proposition. Ladies and gentlemen, thank you for the invitation. Thank you for the patient listening. Have a nice day.
Thank you, sir, for such a deeply and engaging and reflective presentation. The way you explored the meaning of life in science, questioning whether it is driven by fame, fortune, or quest for truth, has given much to ponder. Your thoughts have enriched this session, leaving us with valuable insights into the spirit of research and discovery. On behalf of all present, we extend our heartfelt gratitude for sharing your reflections with us. The session continues with a presentation that takes us into the fascinating intersection of medical science and innovation. It is our privilege to introduce our distinguished speaker for this session. The speaker for this talk is Dr. Manohar R. Furtado, a visionary scientist whose pioneering work bridges research with real-world impact in the life sciences. Dr. Furtado will deliver a lecture titled, How Pigs Are Saving Humans, Xenoplantation. This talk promises to open new horizons on how groundbreaking biomedical research is addressing some of humanity's greatest challenges in organ transplantation. His expertise and forward-looking perspective will surely enrich our understanding. To formally introduce the speaker, I now invite Mr. Prashant Khatke.
Good afternoon to one and all. It gives me immense pleasure to introduce the great personality over here, Dr. Manohar Furtado. He is currently the president and founder of Biology for Global Goods and consultant for an investor in several biotechnology and pharmaceutical companies. His early studies were at St. Aloysius High School in Mangalore, then at Ahmednagar College, where he did his bachelor's and master's degree. He then joined PG school to complete his PhD with Dr. John Barnabas as his supervisor. Dr. Furtado joined Northwestern University as a researcher in 1986 and was on the faculty at the Cancer Center, Departments of Infectious Diseases and Pathology from 1989 to 2000. He was also director for CLIA Virology Lab, Northwestern Memorial Hospital, the Biotechnology Lab Director, and a member of AIDS Clinical Trials Group and the Multi-Center AIDS Cohort Studies. Following that, he joined Applied Biosystem in 2000 and was Vice President of R&D till 2013. Later, he worked for Biorad, Cepheid, Advanced Cell Diagnostics, Senior Consultant to Thermo Fisher, and SVP at Molecular Designs. He was CSO and CRO at Apton Biosystem to develop super resolution based NGS platform. Now it is Pacific Bioscience. Dr. Furtado has worked in life sciences over 30 years and has a PhD in biochemistry from the University of Pune in 1986 and a business certifications from the Sloan School of Management at MIT in 2009. He was also appointed to the National Biodefense Science Board from 2011 to 2015 by DHHS Secretary Sebelius. He advised Obama administration on strategies to develop countermeasures to combat biothreats and pandemics. So it is a very great honor to introduce Dr. Furtado, sir. So welcome, sir, on behalf of all BPHES, sir. Thank you, sir. Thank you, one and all.
Thank you, Mr. Prashant, for the thoughtful introduction. I now request Dr. Surendra Kaskadbi to felicitate our speaker, Dr. Manohar Furtado, sir.
This is on.
So please accept the token of our appreciation. We are grateful to have you with us. Can we have a round of applause?
Okay.
With this, we warmly invite Dr. Furtado to deliver his talk.
It's working, right? Yeah. Yeah, always glad to be back here in Ahmednagar. I spent about 14 years here, bachelor's, master's, PhD, teacher, lecturer, and after that, like you said, went abroad, did a lot of research work. So two speakers before me were largely academic background, and they had a lot of doubts and questions about science and making money, and I agree with part of it. Even the pharmaceutical industry in general in the US is profit driven. Okay, and there's a reason for it. They need people to invest money, angel investors or whoever, put in money. Okay, and those guys have to get money back. Otherwise, they don't invest. Okay, one of the things missing in India to some extent is this venture capital, ecosystem, where you start new companies. These new startups are the ones generally that come up with a lot of innovation. So if you want to take qPCR, there's a company called Cetus, small company, built up the instrumentation, built up the technology. Of course, the founder, Kerry Mullis, got the Nobel Prize, but ultimately it was brought into mainstream by a much bigger pharmaceutical called Roche. So they bought Cetus, got the IP, and licensed it out for research to Applied Biosystems. So together, these two large companies brought in a technology that is used across the world. It takes time, it takes money, and people make money out of it. So in a way, that's life. But I think there's a limit, there should be a limit to the amount of greed, the amount of money. I mean, you can make money, but after a time, it's not necessary. So today what I wanted to do is stress on some scientific innovations that have brought in a completely new form of capability which we didn't have. I mean, you all know about transplants, there's bone marrow transplants, and there's organ transplants, and it's been going on. So this is something that will take that to a new level. So what's been going on? Anyway, so I do have to mention, I'm a former student, came in here. Today's talk is going to be on how to take organs from a pig and you use it in humans as a replacement for, usually organ transplants occur with a human donor. Someone dies in an accident and he's donated his organs to medical use. It can go into another patient. And what you see on that side is a Chinese team doing a transplant for a lung transplant. And the organs coming from the pigs. So how do you get an organ in a pig to get into a human? You all know the human body has a very powerful immune system. It goes ahead and kills any virus, bacteria, anything it recognizes as foreign is attacked and destroyed. So how do you get to this point? So that's what I'm going to start off with. The first, is there a clinical need? And to some extent there is. There's a lot of people, even in the US, on the transplant waiting list. They don't get an organ, and a large number of them, die out of organ failure. Not even enough organs to go around. So one of the questions was, can we come up with an unlimited supply of transplantable organs that would obviate the need for this organ transplant waiting list? One of the solutions that was thought back in the 80s was xenotransplantations of organs from genetically modified, immunologically matched pathogen-free pigs, potentially a solution and a large amount of supply. So why choose pigs? There are several characteristics that render them most useful for xenotransplantation. First of all, you can easily breed the pigs. They have a short gestation period, 4 months, and they have relatively large number of offsprings. So you can, produce large numbers of pigs in a short amount of time. The other part of this is that organs from pigs have sizes that are similar to the human organ. So it's more easily amenable to surgical manipulations. Obviously, there's going to be some ethical concerns from animal rights activists, but we also know there's millions of pigs that are being slaughtered just for their meat. So that's the trade-off. And lastly, you can put them in pathogen-free facilities. So these pigs live in air-conditioned rooms. They get extremely clean water. They get food that's completely free of any contamination. If you want to go into the room, you have to gown up, wear a cap, wear boots, put a thing. They're like protected as if, because you don't want to transmit anything from the human to those pigs, because they have to be 100% healthy if you're going to harvest the organ and put it into some other sick patient. So they should say well taken care of in a way. So how do you do this? This is like a full course in immunology, so I'm not going to go into it in detail. It's a complete course in immunology in this slide, but there are couple of things to know. There's an immediate reaction called the hyperacute reaction on top, which happens within the first 2 to 3 days. And that the body responds in a very vigorous way, completely kills the organ. The next, you'll see some delayed responses. Is this slide clear enough? Can you see it? You can see it? Okay. So there's a delayed response that goes on for a few days, and there's a long-term rejection effect from the immune system. All of this is mediated to both T cells and B cells and NK cells attacking this incoming organ. So how do you change all this? By genetic engineering. So the 2 or 3 mechanisms. One of them is to knock out some genes. So if you have a gene on the pig's genome on that side, you can introduce some, that's a neomycin gene, put it in there and knock out alpha-1 3GT. So this will sort of eliminate that hyperacute reaction. There are 2 or 3 genes that you can knock out that will give you a pig where you don't have the first part of the immune response that I said. You can, this can be done in cell culture and then reintroduced into pigs by microinjection into the embryos, and you raise a set of pigs that have 1 knockout. Now, is that enough? Obviously not. The next thing you do is this CRISPR technology is something that came up more recently. So you can either introduce new genes, replace genes, or repair genes, or do a lot of modifications using the CRISPR-Cas9 technology. I'm sure you're all familiar with it, but basically it's got an endonuclease that will cleave the DNA, and you can either repair it to create indels or some deletions, that is the non-homologous end joining repair, or you can go through the homologous repair where you're actually replacing the gene with a corrected gene or a different gene. So these things were done iteratively on pigs over a large period of time by many universities and a large number of companies, because there is a lot of potential in this. So ultimately, a combination of effort over a period of, I think, 20 years, came up with something called the 10G pig. So 10 things were genetically engineered in this particular pig, and you can see them here. So there are 3 knockouts the my pointer is not that good. It's not. So you can see anything in yellow, the gal KO, KO means knockout. So those 4 targets in the pig genome were knocked out because a lot of studies, they know expression of these proteins on the surface of the organs triggers a robust immune response. The next thing they did is they H stands for human. So they put in human CD46, human CD45, and the TBM receptor, FCCR. So total of 6 insertions of human genes into pigs. And this is done by iterative, you do it one at a time, breed the pig, it's got progeny, put the next one. It took a long time. I mean, it's a lot of work, a lot of effort, but ultimately you came up with a pig with about 10 different, and it's shown, the chromosome locations are shown here where the different deletions and insertions occurred. And not that important to know right now, but in general, and obviously these human genes were put in front of pig promoters that would work inside the pig cells. So these are completely modified pigs made to be more human-like. So you're knocking out genes that cause a rapid immune response. You're putting in human genes, so when they're expressed on the surface of these tissues, it looks like human to the immune system, so there's a less robust response. I mean, you all know, even if you want to do a blood transfusion between 2 human beings, you need to match the ABO or a lot of kind of, the immune system is pretty powerful, so you have to be careful not to trigger the immune system. At the same time, you don't want to destroy the immune system, because if you don't have it, you'll die from infections from virus, bacteria, fungi. You know, it's like you end up with AIDS, autoimmune deficiency. So you need an immune system, but what they're trying to do here is try to evade it and trick the immune system into thinking that this organ is almost human. So this was one part of it, and 10 modifications were not enough. So some companies have gone ahead and done many more modifications. I don't need to go into this. So people have pigs that have 15 to 16 different genes altered, depending on which company you're talking. The work's going on mostly in the US, some extent Europe, and largely in China as well. So you have a genetically engineered pig developed in China that's been used fairly regularly. The next problem was pig genomes have a retrovirus. It's called the pig endogenous retrovirus. I mean, all humans have endogenous viruses called the human endogenous retrovirus in our genomes. These things express viral genomes, and one of the concerns was that if you put a pig organ into a human, you're going to get infection with the PERV, and there were studies to show that this actually can infect human cells. So what the companies again had to do is knock out the PERV genome, the genes. There are 62 copies of this genome of this target in the pig genome. So you had to do a big knockout using Cas9 CRISPR. Some of them also used interfering RNA like siRNA to block the expression of these sites. So there's been few approaches to try to get this done. So in 1994, we did some initial use of pig organs when I was at Northwestern to support patients with organ failure. So we could not do a full transplant, but we had a pig that had the hyperacute response, the first phase of it knocked out by knocking 2 genes. That's all they could do back there in '84. We didn't have the technology to modify more than that. So obviously a company did the knockout. They had the pigs, they were growing it. So what we were doing is using pig livers or kidney extracorporeally. So it was kept next to the patient in a perfusion chamber, and you shunt the patient's whatever goes into the kidney and comes out through the pig liver. We could keep people alive for a few days with this kind of a pig organ, and maybe you use 2 or 3 organs. They live for about 7 to 8 days. Now, what's the advantage of that is that within that time, you might find an organ match. You know, that was the hope, and there were about 20 people or so who found an organ match because of this extension of the life of the kidney using a pig kidney. One problem was that a scientist in the UK, retrovirologist named Robin Weiss, reported that there's an endogenous retrovirus. That's the first time they found out that we didn't know about it. Nobody knew about the virus. He discovered that. And then we did some experiments as well in Northwestern to look at his results. And indeed, if you take PC15 pig cells that make the virus and put it onto human 293 cells in culture, you could see an infection. Okay, so this infection was a concern because in 1994, you know, there was another retrovirus running around called HIV-1. There were a lot of people with HIV-1 going in, and the fear was that if you take an HIV patient and do this experiment, you could get a combination of two retroviruses that may come out with another deadly virus that could destroy a lot more humans. So the FDA, rightly so, stopped all the experimentation with the organs at that point in time. But I've been following this literature very closely. In 2021, they did successfully transplanted pig kidney into brain dead humans, and they could see for 54 hours it was fine. The person was brain dead, but the immune system was still active. So started with that. Next was to do the pig to human kidney transplant into donors, and then the first transplant to a living patient was in Mass General Hospital in 2024, and between 24 and 25, there have been short-term transplants of edited pigs into living patients in the US and in China. So this has come to a point where there are patients living for 6 months, 8 months with a transplanted organ. There's been a heart transplant also done with this, and I told you the Chinese did a lung transplant using modified pigs. So in general, you'll see this in the literature. There's a number of transplants that have worked. So what's happening now is there are clinical trials starting in the United States with the first patients, because they need to do bigger clinical trials to show whether this is beneficial or not. The previous studies, many of them were done with patients who are on a compassionate use basis. So there is an exception in the US FDA rules where if a patient is going to die, they can take an option and sign for a procedure that's not fully approved or demonstrated. So early clinical trials are starting off, and we're hoping at some point in time some of this will be approved. And lastly, a little bit about what's going on in India. So not much, mainly because we don't have a legal framework for this. There's one surgeon, I think it was in Haryana, someone did a transplant in Assam in 1997. Patient died and obviously put the surgeon in jail. There are no legal rules here to allow for this kind of a transplant, first of all. So hoping that in some point in time, I'm quoting All India Institute of Cardiac Surgeons saying that India is decades away from this kind of transplants. So there's a huge gap in the clinical. So I was glad to hear that from Dr. Shaligram yesterday that there's going to be an efforts to bring in like gene therapy for hemoglobin S or some other diseases into India using efforts from internal institutes and try to develop a solution working in bulk scale through serum. But this is, again, will take some time, but like anything else, things take time. So ethical issues obviously is using animals for human animals. Obviously the pig is something that both the Jews and the Muslims don't like, they don't eat it. Now what do you do when you need an organ transplant from a pig? So there's all those questions, and animal rights activists have questions. So there's a lot of articles generated. So someone did a review of a lot of articles, and that said generally the attitudes seem to be positive towards xenotransplantation. However, when you went and expressed the risks in a more definitive way, a lot of people switch from being positive. It's one thing to give it to a patient who's for compassionate use when you know that, okay, you don't use it, you're going to die. But if you want to use it with people who are, say, midway in their failure, and you have to convince them that it's a beneficial thing to do, and that takes some time. So there are attitudes that need to be changed within populations. I think that probably is my last slide. So in summary, there's organ shortage. We can do genetic modifications. How do you get it into clinical applications is one thing. And then there's also concerns about some chimeric reactions that might help. So in conclusion, genetic engineering of pigs and interspecies chimera offer a hope for addressing shortages. I mean, I should say there are also other efforts to grow entire organs in culture. Okay, in animal tissue culture, they're trying to go. I mean, they've grown some pig walls, heart walls, and all that have come up, but they want to try and grow the entire organ. So that's going on as well. So one option is to modify the animal itself and get the organ into the human being. The other option is to completely grow it from your own stem cells or your cells, create an organ that can be transplantable, which is much far behind this level of research. So I think with that, I'll stop. And it's just a picture to show you what's going on all over the world. I will take any questions.
Sir, your talk is very excellent. I have some doubts. Though the rejections, transplantation rejections is highly, it has been noticed even in allograft, isograft. Whereas in the xenograft, it is very difficult, probably than acceptance of the organs. The impact of immunosuppressants and inductions to the recipient. What could be the consequences leads?
I mean, it is a difficult proposition, and they do give them immunosuppressants for some period of time during the graft, like anything else. So even, like you said, rightly so, human allografts are also difficult because you have to have a good match. But this is in very early stage, it's clinical trials, but we hope over a period of time, this will become mainstream, because you can make, just like you make drugs in a factory, you can rear pigs in a farm, which is under control conditions. So they do test the pigs to make sure that they don't have, pigs have CMV and other viruses. There's a whole bunch of tests that have to be done. So like anything else in biology, in the beginning, it looks like it's 10 years ago, it would have not been possible. But with all the changes they are able to make, 10 years ago, we didn't have a cure for hemoglobin S. Today we do. We have a cure for some other genetic diseases, coming up with something for hemophilia. So things change over time, and risks are always there. It's always a balance between risk and reward.
Oh, see, once it has been begins, the immunosuppressants like methotrexate, cyclophosphamide, or ciprofloxacin, whatever it may be, it's all represents or mask the effect of the CD4 cells, T4 cells, and B4, B cells, and all. So that a recipient definitely it has got loss of his immunity, and he is prone for other kind of an infection. This is the other consequences could be the lead. So how do you?
Not denying that. Okay, it's always a risk versus reward. That's why they're working on this pig for so long to make it look almost like human. There is going to be some immune response. To some extent, you can suppress it. So the clinical trials will give us the final answer as to what is the benefit of doing a xenotransplant. I don't have the answer yet. It has to come.
What is the success rate for this xenograft transplantation?
So, like I said, it's been only used in compassionate, it's only been used in compassionate cases. Someone's about to die. Okay, they can sign a waiver and say, please do an organ transplant. So those are the people, some of them have died, Some have been walking around for 6 months, so it's partial success. So till they run a full clinical trial, you won't have the final answer. Drugs go on a clinical trial. Not everything gets released. I can point out to 10 or 20 drugs that fail clinical trials because of side effects. So any action has a side effect. Crossing the road is a risk because you may not see the truck come and hit you. So the same way, any procedure has its risks.
Thank you, sir.
Are you trying to say they should not be doing it, or are you trying to say it's just risky and we need to be more careful?
As in India, these ethical issues are very much more highly impossible to be transplantations for human beings.
No, India doesn't even have a law for forensic testing. Okay,
Thank you, sir.
every single country in the world has a law for putting criminals in jail by doing DNA testing. Our country does not. So we are 30 years back on that issue. Now this is even more complicated. So it has to go to the legislature. They have to pass laws. If you don't do it, you don't get the benefit of whatever is out there. Even gene therapy, they may need some legislation to allow it to be used. That's always there in any country. You know, we have to decide, do we want that, or okay, he got he's the bad liver, he dies, done. That's also a view, right? It's a viewpoint. You know, it's time for him to go to God, so he's gone. I mean, that is acceptance. That is acceptance. Yeah, so I see that in India with some of the older relatives of mine where doctors won't treat them aggressively if they're over like 70. It's like, okay, maybe it's time for you to go. It's an attitude. Okay, you had a comment?
Yeah, I had a comment in the context of the question of some personal experience. So technology has improved quite a lot about organ transplantation and also about immunosuppression. So I have donated a kidney to my wife, you have 11 years back, and we have different blood groups. So now ABO incompatible kidney transplant is also possible, and immunosuppressions are much better now, like methotrexate is no more used. You have tacrolimus, azoran, and they are very excellent. So this was not done usually ABO incompatible transplant, but we could do it in Bombay 11 years ago, and my wife is fine. She has to take a little bit of care because she is under immune suppression for life. But she has been having breakfast and dinner with us, so I think it's okay. So things are improving, and they're very promising.
Yeah, I mean, some of the newer drugs like tacrolimus are less harmful. Yeah. Any other questions or comments?
Thank you, sir. Thank you for an enriching and insightful presentation. Your reflection on the journey of drug discovery and development have reflections on the xenotransplantation and how scientific inventions is turning an extraordinary concept into life-saving reality have truly broadened our outlook. The insights you've shared have added immense value to today's session. On behalf innovation and its impact on human well-being. It is a privilege to introduce our distinguished speaker for this session. The speaker for this talk is Dr. Professor Arvind A. Natu, a renowned researcher whose contributions to the field of chemistry and pharmaceutical science have greatly advanced our understanding of modern drug discovery and development. Dr. Natu will deliver a lecture titled Drug Discovery Development. This talk is poised to shed light on challenges, breakthroughs, and future possibilities that shape the process of transforming ideas into life-saving medicines. To formally introduce the speaker, may I now invite Dr. Avinash Vanzare.
Good afternoon, everyone. Welcome to the international conference organized by our Ahmednagar College, Ahmednagar. I am Dr. Avinash Vanzare, and I am privileged to introduce our next speaker, Professor Dr. Arvind Nathu. Professor Nathu is a PhD from National Chemical Laboratory, which we commonly known as NCL, where he served for 40 years at various positions. He then acquired postdoctoral and allied research experience in institutes abroad, Germany, USSR, Sweden, Poland, to name a few. Still a teacher at heart, he teaches in universities, institutes in India and abroad. He is well versed in German language and has been awarded the Cross Order of Merit, which is highest civilian award for a foreigner by the President of Germany. He has received many awards and accolades and is a member, leader of many important academic and professional bodies. He is actively involved in upbringing of the underprivileged, tribals, females, and Northeastern students into mainstream of education and health. As he speaks and interacts with us, we will all understand his passion for research and teaching, and above all, his humility, despite such accolades. For us all, his important contribution is forming of ICER, Pune and Tirupati. I welcome Professor Nathu to deliver his talk entitled Drug Discovery Development. Welcome, sir. Thank you.
Thank you, Dr. Vanzare, for the thoughtful introduction. I now request Dr. Jaiprakash Mulyal to please felicitate our speaker, Dr. Arvind Nathu. Can we have a round of applause? With this, we warmly invite Dr. Nathu to deliver his talk.
PPT up. Please. करो. They are checking PPT till that time. I'd like to share some of the initial thoughts. One is I'm really thankful to Dr. Manohar, who has given me this opportunity to interact with you. I had two comments. One, I am the only man odd out perhaps, is a chemist, what a chemist is doing here in the wonderful academic atmosphere of biology. But you will see during my talk also, I had taken this one, that how biologists have helped the chemist and how chemists have helped the biologist in difficult times. So I'll talk about it. Second is, since texture of the audience is mainly consists of very young, enthusiastic postgraduate or graduate students, I have introduced this topic as if I'm teaching in the class. Don't worry about it. So, but it may be for some of the experts sitting on the sofas, it might be feeling, you may feel that is too mundane. But I thought it is better to start with one or two slides on the introduction and go ahead. My job has been done very easy by previous speaker, especially Bhutan Patrodhan, who is a master of Indian symbiosis of Indian traditional knowledge and the modern medicine. So I'm thankful to him. I'll go into some of the details. I may basically, is it ready? Once it is ready, you just tell me. Oh. Here you go. Hello. Only one thing, since still the PPT is getting ready. I was a pure organic chemistry bubbling with all enthusiasm coming from Germany after several years. And at that time, I was talking to a gentleman in flight. His name was Dr. Merchant. He was a famous, I think, pediatrician or in Mumbai. I was, with all effervescence, I told him I am doing this and this at the younger age. He said, my dear young boy, if you are not using your organic chemistry for medicine and biology, it's of no use. So I started taking textbook of Leninger and started reading biology, which I left when I was in 12th standard. So this is a completely different switch, and completion was over when I gave a full-time, half a course in the University of Bielefeld and the biology and chemistry of DNA and RNA. So this was a full circle, but still biologists may excuse me if I made some theoretical mistakes. Thank you very much. So although I titled it as Drug 25, it's not Drug 25 actually, because drug discovery and this is a continuous process. There is no stop in it. But I will touch upon some of the things which has taken a prominent stage in not only in Indian scenario, but also on global scenario, and then only I had taken it. So I'll give you a few examples also. So this is the place where I work. It's called Indian Institute of Science, Education and Research, ISER. It is about 15 years old institute, and among the 7, we are the one. In short, we are the IITs in basic sciences. Perception of chemistry right now is very bad. It is pungent, burning, hazardous, nauseating, and hence is the biggest pollutant. If you ask somebody, can you take chemistry? They say, no, I don't. I get much more salary in IT industry because who will spoil this? But if you go to chemistry, chemistry is number 1 everywhere. There is not a single place except one where there are no chemicals. Well, this is a good puzzle for the students. Tell me one place where there are no chemicals, okay? And chemistry means is a chemistry of love. If you go to the dictionary of those things, chemistry means understanding, affections. Nobody says if 2 boys and girls are meeting, their physics is matching or their mathematics is matching. It is ultimately said their chemistry matches. So why from this to that, how we can change? This is the only answer that can be done. It's a question of only sustainability. And if you want the captains of some industries, I see here the faces, they will tell you that now the scenario is completely changing. It is completely changing to so-called environment friendly or whatever you talk about, but design, manufacture, and use of benign chemical products. Can you use water as a solvent, for example? I'll give you a few examples on that. Prevent pollution instead of reducing it. Can you try to prevent? Can you avoid derivatization? Because one derivatization means one reaction, removal derivative is another reaction. So can you do without that? Can you do reactions in water? And so on and so forth. There are several other factors. Now I don't want to go through that because they are being taught each and everything. Innovation all across all sectors to design and discover new chemicals, products and processes. I don't want to again go through this because this is a very common thing. Energy requirements, avoid auxiliary substance, catalytic reagent. This is the most important thing now that is coming up. There are various types of catalysts, call it homogeneous, heterogeneous, phase transfer, and whatever it is. They are all compatible. Especially new drugs, as I said, this is very preliminary. Now you need to about 700,000 compounds to discover one drug. This figure can be reduced now, people say, by using AI and all other things, I don't know. But AI many times gives a very complex structures which cannot be synthesized by chemistry. So you have to be very careful. On the other hand, there are companies like Grunenthal in Germany which produces 3,000 to 5,000 compounds per day as per your order. So just see this thing. Then there is biological testing activities, human trials, and so on and so forth. Most important is time taken is about 14 years and expenses about 8,000 crores that became. These figures can differ from anything from 4,000 crores to 25,000 crores. But when we are talking of 5G and 4G of 1,76 crores, I don't think this is a very big amount to talk about. Anyhow, I don't want to go to this. Only the thing that you have to go to clinical studies, as he has mentioned, regulatory affairs. In the regulatory affairs, still one has to carry out all the bundles. He will tell you that with all physical signatures on all the analytical results. You may do it electronically, but you have to physically present. At least 6-7 years back, I was associated with Abbott and accompanied something to FDA that we realized that we had to take everything in physical. I don't want to go into details. But this scenario is really changing now, mainly because of the biotechnology which has produced, which will give you many targets, high throughput screening. Now you can screen about 10,000 compounds a day. You can use the combinatorial ways to synthesize. I gave the example of Grunenthal, which synthesizes 5 to 10,000 compounds per day. Result, the time period has been considerably reduced and new drugs are coming at much faster rate. Well, I reserve my comments at the end of my talk on this. I'll just touch on something which has, in drug chemistry especially, I have seen all its ups and downs and ups and downs. Today one technique takes up, it goes down as if it has vanished, but now it has come up. Enzyme reactions is one of them. Now you can carry out, mainly because of, thanks to the engineering, biochemical engineering or whatever it is. Now the enzymes are used, I don't want to go into details. I'd like to just point out 2 examples which are done in a modern this one. One is of the in the prostaglandin synthesis. If you have, I don't think, wait, okay. If you have a desymmetrical ORs and if you want to reduce one OR to H, it is impossible using any chemical base. It is impossible. People have tried their hard way, nothing works. It is exactly the enzyme desymmetrization which will give you this symmetrization and gives to the enzymatic reactions and ultimately to an important intermediates in chemistry. Similarly here, this is for the statin. Can you, this pointer is not working. Okay, okay, here is the way it works. For example, how the enzyme biologists I come to, this is all the recent few examples. This is a trisymmetrical acetate and I want to only to hydrolyze only one. No chemical will be able to. There's not a single reaction that is possible to reduce the hydroxyl. So they did it with the enzymatic reaction, then followed by the, don't worry about these complex structures. You may think that I'm using it because to impress the chemistry is very difficult. No way. Don't worry, I want you to understand only the principle behind it. And then you see this is protected and one of them is still added, and ultimately you get a product where one of the hydroxyl is protected, second is oxidized. Oxygen, this is all possible only because they are using the enzymes. Now enzymes can be used on large scale. Enzymes now can be used as a reagent bottle, and therefore all these things are possible. One of the advantage, of course, is now enzymes can be used in organic solvent because inherently they were supposed to be used in aqueous, but now they can be used in organic solvent because you take the enzyme, put it in a proper buffer, it forms a molecular layer around it, and then you can throw it in the organic solvent. It still works as a catalyst. Now there are about at least 7 different APIs are now coming to market in next 3 years, which are at least partially based on the enzyme catalysis. Now a new method has come up where subsequently 2 reactions you can do in the same flask, first using the chemical catalysis and second using the biocatalysis. Earlier, biology and chemistry, they thought that their catalysts are so different. No way. Now this can be also done very easily, and at least 2 new APIs will come based on this. I don't want to go into detail because so this is where the chemist lost and the biologist came to their help. In the whole process of drug discovery, there is only one very, very important point to be closed. And that is, where it should be soluble in water, so they must have more hydrophilic solvent, hydrophilic this one. And it has a cell entry, for cell entry, it has to be hydrophobic. So this balance of hydrophobic versus this thing will be possible only chemists and biologists. They come together in different. In pursuit of this, many modern medicines have lost their original properties also. This is where I was coming to this Ayurvedic drugs, where this is naturally balanced. The hydrophobicity as well as the hydrophobicity, if you ask for, there are several new drugs that have come up. You can see the long chain of hydrophobic acid, hydrophilic site for the solubility and the chains of hydrophobic for the cell entry. So all this is possible, but at the same time, giving this balance with the equations and all other things, many times their physiological property or for which they were used has been considerable. They have compromised on this. So this is one of the biggest drawbacks of the modern medical system, I must say. I don't want to. And to just give you one example of another vaccine, where the real sustainability or how the, all other organic materials have been completely chopped off. For example, if you want to convert this simple CHO to CH2CN, don't worry about the structure. The condition that were used were LDA, butyl lithium, anhydrous treatment, rhodium, alumina, and what are more things. Over and above, this reaction needs a temperature of minus 70 degrees. So to make it profitable, you have to go to Antarctica to do that. Instead of doing all these things, you believe me, strong bases, low temperature, and one simple reaction that was carried out instead of this was using water and sodium hydroxide. Can you imagine? This has saved the cost as well as the reduction. So this is the real sustainable chemistry. This can be done in one step. This is green chemistry, dream, catalyst, quantity, blah, blah, blah. Reaction can be performed by the simplest of the bases, such as sodium hydroxide. Process is very easy to perform on large scale, avoid the usage of hazardous and expensive. What I feel is the drastic cost reduction is the real benefit of all this. Venlafaxine is now widely used. Another approach in chemistry, the real earlier approach was, you take a compound, you take A, you attach a B, you attach a C, and send for biological testing ABC. And at the end, they say, all your compound is useless, it's of no use. So instead of this, if you can add diversity at each step, then the things will be much better. And this approach was introduced long back by the Schreiber. It's called diversity-oriented synthesis, where you start from single molecule, you convert that into 3, then with more 3, I'll give you, and then such that you can create more targets for the drug targets. I'll give you a simple example. Although I call it simple, this is a little bit complex chemistry here. See, this is a triacetate glycol trait. You convert that into one, you introduce one D1OH, that is hydroxyl here. Then again, you reduce it, you reduce this. There are several reactions that can be done. At each and every step, you use several materials. For example, glycols can be 3, D1 hydroxyl can be D8, 2, and so on. So within this simple cycle, using these reactions, you can produce number of compounds because they are diversity oriented. So that if one target is down, you test the other one. And now this has been really taking up a very big shape in the market also. Another chemistry, I must say, in the processing that is coming up is called flow chemistry. It's a very simple one. We have been doing reactions in this round problem, class plus A plus B gives you products plus X. Same thing you can do, either catalytic or this. Can we do this reaction in a simple tube or a simple cap? This is the question. And this was considered to be impossible earlier, but now it has come into the existence, and even now pilot plants or bigger plants are also used. Very simple thing. Take a simple column. This is not working. Hello. दूसरा है क्या तुम? This is anyhow. Now you can see, instead of doing a flask in the reaction, people are now doing the reactions in a capillary, where you add A plus B. I'll just go here, that is better. You add A plus B in a capillary, you add another column with the catalyst, another column with the second catalyst, and you get. So what you need is one just capillary and 2 pumps. You pump in all the components into this capillary where you have larger surface area, and you will be able to get it. I'll just give you 2 examples. Very simple phenol, when it gets nitrated or this thing, you get always a mixture. But if you do it using the flow chemistry, you will be able to do 75%. There are several. I'll give you a simple example of hydrogenation, which everybody will understand. In the catalyst hydrogenation, what we take a flask, we add the compound, you add the catalyst, stir it, and instead of keep the compound running in a capillary, keep the bed of the catalyst ready so that it will run over that and it will continuously flow. There are now several examples that are coming up. You can use this is in the compulsory consecutive use of various catalysts. This is the beta-lactam synthesis. Now you use the reagent column, catalyst columns, scavenger columns. But one thing is sure, if you just understand, try to remember that now the reactions can be carried out in a small capillary or a tubular reactors. For example, I'll give you, I have a dibromide, I want a lithiated solvent, introduce an electrophile to get all this compound. Simple is, you take this dibromide here, there is a capillary, there is a pump, the N-butyl lithium, all the reagents are pumped in, and ultimately they react in this small capillary to get this compound. More complicated example of artemisinin in methyl ether, which is now used, artemisinin dimethyl ether, which is now used for malaria, is now being manufactured using the flow technique. So you will see only pumps and capillaries or tubular reactors. There are several the cell गेला क्या? Then there are several roll-up-ram and many other things which can be multi-component, multi-catalyst systems can be used using the simple technique of using a capillary and a pump. Why it is advantage? Thermal control, mixing efficacy, small volumes, now dangerous gas and liquid, and diverse reagents such as singlet oxygen, diazomethane, and two. Now, here's a real interdisciplinary thing. Now you can do the biocatalysis also using two reactors. Therefore, now flow reactor is perhaps the remote. This is one picture I have given you. In the chemical plant, you have your plants like this, whereas you do the chemical capillaries, the pilot plant looks like this. It's a smaller solid. In a way, for a 1500 liter of the reactor size using the chemical catalysis, not more than 250 or 150 liters will do. So this is a new technique now that is coming up, and mainly in the areas of APIs, AI. Now no lecture can be completed without saying anything about the API. Medical diagnostics, AI can analyze now everything online. I don't have to tell you. In terms of drug discovery and development, there are only two ways of looking at it. Whatever you say, you have to think what can be complex. Now, see, this is a very serious problem. You try to take a new compound and try to see whether it is active against the known targets. If it is active, then you say chances of finding a new molecule is different, because it is known from the known database. So this is a chicken or egg story, and ultimately the human brain only will work. Where the drug discovery comes into the problem, comes into AI and all other things is, suppose now you have 10,000 skeletons. AI can tell you which compound need not be synthesized. Earlier it used to tell you what to be synthesized because it becomes too complex. It goes against the laws of organic chemistry, where the nitrogen is seen with 7 different valencies and so on. So now that's not possible. But it can tell you how to reduce them. So that is one thing that is now coming up. Rest of the things are digital consultations and algorithm for sleep disorders. But remember, AI can be a valuable asset in medicine, but it can't replace the human element. That is for 100% of sure. I'll give you for example. AI needs to be carefully validated, trained, and monitored to ensure its accuracy, safety, and effectiveness. So you have to use this as a tool. Many people feel that AI is science, but according to me, AI is a tool to be used. If it is in the right hand, perhaps you can do wonders. Medical technology, I don't want to go into the details, but now there are blood tests which can be used for cancer detection or many other, if it's just a drop of blood. So you don't have to now go and take for the cancerous tissue, you don't have to operate, take out and make blocks and all other things. Now there are many tests that are available for blood test, detect in minutes and most of the types of cancer. There are several things. I must mention of the CRISPR technology, which has been mentioned by the earlier speakers. Now CRISPR technology has become a really toy in the hands. And you know, when a toy is handled by an immature fellow, what happens? So that is, there is a likely to be danger. But CRISPR technology or 3D printing or the molecular imaging and all those things, microimaging things are coming up in medical technology. Biopharmaceutical and medicines, what he said is correct. The biology component is going up and up. So chemists are really worried about their jobs now, what to do. But let's talk of, instead of that, let us talk of biopharmaceuticals, biological medicines, and I'm worried more about the biosimilars medicines. It is a medicine which is similar to biological or biopharmaceutical. There is no difference. But many times the production of the biological products may not give the same reasons. So they just compare whether it is simple. And that comparison, I don't know really how to. Because of the complex nature of biologics, they are difficult to copy. In other words, it's almost impossible to make a medication that is exactly same, especially in bulk. Biosimilars are products with highly similar structure and function. They should also provide as a similar benefit. So according to this comment in mind, it is sort of generics or less expensive version of the real original medicine. Real problem is, I have given several examples, common biosimilar that are used in the market. Real problem right now is the bioanalytical facility. Even at the global level, bioanalytical facilities for the biosimilars are still not very well defined as for the small molecule. It's not expected. So now they are trying to come up with a midway between whether it can have the balance of the properties as well as structures and so on and so forth. In Mumbai or at some other two places, they try to do that, but still it's not in this one. Biopharmaceutical represent one of the fastest growing. By 2030, they are expected to represent 50% of the market, what you said. Patent of original product is expiring or expired. There is a very complex IPR associated with the biosimilars. Since they are not well characterized as small molecules, it is very difficult to establish the IPR also. Increase opportunity to healthcare services, decreases expenditure, but there are no bioanalytical facilities. Another area that is coming up, I don't have, perhaps Dr. Purushottam will be able to comment, is evidence on evidence-based medicines. I have seen earlier also, there are several Indian traditional practitioners, they have cured the patient, but may not be able to explain the mechanisms and so on. So can we really discard just based on that, when you are seeing that the patient is cured? Unfortunately, in India, there is no courses on evidence-based medicine. But now Oxford has started on masters and PhD, so perhaps when the foreigner starts it, perhaps we will be able to start it in India soon, just before. But this is very important. There is no definite knowledge, but how? But still the patient is getting cured. These are some of the top 10 blockbuster drugs, and if you see it, most of them are the biosimilars, and their percentage has gone, increase in percentage to the tune of 75%, 80%, and so on, whereas the small molecules percentage, use of percentage coming down, so you need to work on. Another area of the polymorphs, this is one of the areas that I would suggest as which can be carried out in actually college which doesn't. Take one example, you could take any example, as you take a case of atorvastatin. Atorvastatin has a definite crystal structure. But if you crystallize it from different solvents, it will have several polymorphs, which has the same biological property, there is no mark. But now, this is a different entity. This is more effective in terms of bioavailability and so on and so on. So now there are many compounds that are coming up which are in different polymorphs. What kind of polymorphs? What you are talking about is a tautomeric polymorphs, where you can see it very easily. This methyl ether is going up, and two compounds, they are the same compound, have the same properties, everything is same. Only they exist in different forms. It can be either a conformational polymorphism, or a structural polymorphism, or a synthon polymorphism, where the dipeptides, when they come together, they can be fused either in this way, or they can be in the company of. These are the same molecules with the same property, only their structure differs. There's nothing else than that. Another area that is coming up of repurposing of drugs. Of course, we know very well example of aspirin, which is now used as a anti-blood clotting agent, and there are now several things coming. Why these are coming? There are two reasons. One reason is the drug discovery is becoming so expensive. So they are now thinking that whether some of the skeletons can be used for different purposes. There are at least 6 new compounds that are coming up, which were the earlier used for asthma and those kind of things. Now they are trying to use it as antiviral compounds, and they are coming up. The corollary to this subject is, when you boil down from hundreds and thousands of compounds to 10, 20, and ultimately end up with, are these 19 compounds, they have come across all these steps. So now there are companies which are going through these 19 compounds. How the defects that were earlier detected, either chemically or biologically, can you remove that? And that at least 2 examples are there, which are very, some of them is a peptide painkiller, and now it is coming to the market with a slight modification. So now that these two or three things are coming up like anything, where repurposing, there are several examples. Complex generics is not a part of medicinal chemistry. It is basically pharmaceuticals or pharmaceutics, let me put it. See, peptide, polymeric compounds, whether you have complex active ingredients, peptides, polymeric compound, complex mixtures, complex formulation, complex routes of delivery, and so on. Traditional solid oral dosage forms the problem due to lower bioavailability, solubility, low permeability. So can we design some new methods in pharmaceutics to give them? That is the crux of the whole problem. And now, for example, all the BCS class 2, high permeability for low solubility, small molecules, oral availability can be usually substantially increased by reducing the particles. So, for large molecules, bioavailability concerns are often accompanied by stability and microbial contamination. As a result, these products must be injected and require sterile processing, which adds to the complexity of manufacturing. So this is now one of the biggest problems that is faced, and so people would like to turn from the oral to the injection or the patches. This is a question mainly in the areas of pharmaceutics. Now personalized healthcare, when my grandmother used to tell, you take this in milk, same medicine she'll prescribe you in this thing, she'll ask me to take in the evening, she'll ask them. That time, we used to make fun of them. Yeah, medicine is the same medicine. But now when people talk of personalized medicine abroad, then we think, oh, this is something very important. And this is mainly for the monogenic or the disease, which is about 30% of this total genes and environments. For example, very simple, crude version is, why different patients should have different response to the same medicine and for the same. They're all pharmacological conditions and everything is same. But why their response should be same? So there must be some factor which is stuck to the individual. And when they have gone through this stage, I'll just go through. For example, drug metabolism. If you take one drug and at a time, if it goes with the time, you can really see in terms of time their metabolites are they started affecting at various intervals. Why? And then we say, Nisib doesn't work for me, Brufen works for him, paracetamol he loves. So we have those classes. Why? Now there is a scientific reason for that. There are several genes which have different alleles. And those alleles, when they are different and you are treating them as a genetic molecule, you have to have the right complementarity. And for 70 or 2-3 things, you need to develop different personalized medicine, 2 or 2.5 minutes. So this is the kind of things that are now coming up. Extensive, ultra-rapid metabolism and variant alleles that result. I don't want to go into details. Last thing that I would like to touch on, I showed you one example where the biologist helped the chemist. Now I'll give you one last example where the chemist have played the major role in dividing it. One, I don't want to, lack of time, I don't. And these are called whether the nucleosides can be used as drugs. Nucleoside antis, whether they can be used as drugs. Very simple thing. You have double-stranded DNA, mRNA to proteins. If it is a DNA disease, you will be ultimately getting disease protein and go into this. Traditional drug try to attack this protein business, but it doesn't work because many times the mRNA doesn't get converted to this thing. This is one area where the HIV has taught us that there is a window period during which you can detect, you have the DNA of HIV, but it doesn't get expressed. Hence, they said no, negative. So one of the ways of doing it is very simple. You send an antisense strand here, RNA strand, which is complementary to the some of the one gene, and then you grow it and send this forms a double helix. It doesn't get translated further to protein. Very simple. Biologists were jumping. Now we got a class. The problem came to twofold. One is that there are two problems. Once you enter suppose inject DNA samples, the complementary DNA or RNA samples, it gets degraded because of the DNA's enzymes. And secondly, its entry, because most of the oligonucleotides, they have several charges in them. They are hydrophilic. So it's very difficult to get the cell entry. So you had to come. So completely it was stuck. They said, no, this is this is not possible. But now they have come up, or maybe 10 years back, and I'll show you one slide on that. Very simple case. Instead of phosphate, if you just introduce one sulfur and make it 5 phosphorothioates, now your phosphorothioates, DNA's enzyme will not be able to react because they can't identify it. So one problem is one. Cell entry was done when you simply introduce one more methyl group here, make it hydrophobic. So cell entry problem is solved, then your pathway problem is solved. That's why the chemists came to the help, and now a wonderful land of DNA molecules that can be used. Now this is a drug called Kynamara. There are about 25 now drugs which are oligonucleotide with modified either the backbone or this one. So now there are 25 molecules. I am happy to tell you, out of the 25, 9 molecules have been discovered and brought to the market by the Indian scientists. Maybe in US, but they have brought it to the market. You can see their names on the patents also all the time. I'm very happy to tell you. Last is the siRNA people are talking about in the wonderlands of siRNA and GalNAc. GalNAc was not earlier considered to be a useful molecule at all. But now that is the most important molecule to carry the siRNA particles, especially in the liver disorders, because GalNAc or the sugar molecules acts as a targeting ligand for ASGPR, which are abundant on the surface of liver cells. So liver cells will identify the GalNAc that is attached, and GalNAc brings in one more guest with it, that is a siRNA. So this is a very, very useful thing. I don't want a new drug introduced at all. I don't want this also. I would like to skip this. Only last slide I'll always show in present situation about 20, sorry, I'll take, this is the real last slide. There are about 2,300 drugs that are made in India. 40% drugs are exported. They are cheapest in the world. You see your US counterparts taking bags of Brufen and Crocin because they are the cheapest. But in terms of discovery, there is not a single drug has been discovered in India so far, globally accepted. There are some successes like Hemicin, Mala, etc., but they could not be really come to the world global scenario. Nowhere outside, unfortunately, our herbal drugs are accepted as drugs. I may stand to correction because I checked this with earlier. But really remember, in last 40 years, not a single drug has been launched for TB or malaria. Why? Because if it is developed, who will buy? Poor Indians, poor South Africans or Africans. So there is nobody to buy. So there is no research. So jokingly I say there are ownership diseases and we must find remedy for that. Then market is flooded with drug for diabetes, obesity, various types of cancer, but most dangerous is the antidepressants and psychosomatic disorders. Now even that has boiled down to the students, young generation taking antidepressant, and I don't want to go into details. But now most important thing, we are entering into a mall culture in drug consumption. You go to the mall to buy a simple ball pen of 10 rupees, but there are hundreds of boards hanging. This is free, that is cashback, State Bank gives you free. So these kind of attractions, and ultimately you buy, ending up buy in what he sells. Unfortunately, in India, now I don't know whom to blame, but if you go for a simple acidity you have and you need glycerol aluminum hydroxide which titrates, he gives you and says, sir, you are taking this to neutralize the acid. If I give you a tablet which doesn't produce that acid, naturally I am tempted, then I take some Prazol. Moment I am taking this Prazol, he says, you may have some vomiting sensation also. Generally we say yes, and then he adds domperidone, what we want in 50 paisa tablet, now we are buying for 6 rupees 50 paisa. This is a mall culture, we are buying the things which not I want, but which are the chemists and who are supposed to be responsible for this. Can we take this picture? And so on and so forth. Who are the beneficiaries? This common man? No. Scientist? No. There are about, how many? 225 winners in physiology. Then who are the real beneficiaries? Hospitals, big pharma companies. If I start talking about how they are responsible and all other things, that becomes a different chapter. Enjoying doctors. And last one is the people who are suffering from IPM and courts and laws and so on. Yeah, this is the ICER. I don't want to go into details. This is the ICER. Make ICER Pune is one of the best international institute of higher scientific caliber to meet the needs of the nation. This is our new gate, and I thank you for your patience. What I had tried is to just give the glimpses of what is happening or what is coming up in last 2 years, and it may go down in another 5 years, that is a different story. But this is what are the things that are on the crest I have shown. Thank you very much.
Thank you, sir. Thank
If
you
there
for
is any answer, I am ready to give.
Thank you, sir, for such a captivating and enlightening session. We now arrive at the final presentation of this session, which will be delivered by Dr. S.T. Lonkar. His talk will focus on the theme Environmental Pollution, Monitoring and Analysis, a subject of profound importance in today's rapidly changing world. To introduce our distinguished guest, I now request Dr. G.S. Pandey to please come forward.
Good morning, all esteemed guests and all the participants. It's my privilege to have got an opportunity to introduce today's esteemed guest, Dr. Sadashiv Lonkar. Sir, we, the entire BPHES family, are fortunate to have you among us today as an esteemed speaker for this session. Sir has a doctoral degree in environmental science. He has also a diploma in environmental safety. Lonkar sir has a vast experience of 42 years in various capacities related with environment, health and safety and hazardous waste management. Currently, he is Director of Inauguration Research Engineering Private Limited, Pune. Earlier in his career, he has also shouldered numerous organizational responsibilities. For example, he was Senior Environment Specialist in Maharashtra Enviro Power Limited, Pune. He also served as Environmental Specialist in Petro Rabigh, Saudi Arabia and Sumitomo Chemicals, Japan. He has also served as Environmental Specialist in Hindustan Organic Chemicals, Raigad. In addition to this, sir has numerous achievements, which I will not be possible to mention all his achievements because of shortage of the time, but I will mention some important achievements of him. He was actively involved in drafting an amendment of Hazardous Waste Management Rules 2008. He delivered numerous lectures on environmental safety and waste management at various symposia and conferences. He also introduced a novel technique of desorption coupled to gas chromatography. This is the first of its kind technique in India. He has also developed a new method called as analytical method for analysis of trace elements and pollutants in soil, water and air samples. In addition to this, sir has also served as an expert in various central and state government pollution boards, such as he was expert for Central Pollution Control Board. He was expert in Ministry of Environment and Forest. He was also expert in Maharashtra Pollution Control Board. He also served as expert for Bureau of Indian Standards for Safety. In addition, sir has numerous quality publications in journals of national and international repute. Sir has also delivered numerous guest lectures in various conferences and symposia. Sir, we once again welcome you here, and we all are waiting for your insights on environmental safety, management and analysis. Thank you once again, sir, for your valued presence here.
Thank you, Dr. Pandey, for the thoughtful introduction. I now request our chief guest, Dr. Bhushan Patwardhan, sir, to kindly felicitate Dr. Lonkar. May we have a round of applause, please? With this, we warmly welcome Dr. Lonkar to deliver his lecture.
Good afternoon. Thank you very much for the nice introduction. Without taking much of the time, I will start one by one slide. Actually, I am going to speak on the environmental pollution. What is the pollution, what are the side effects, and why it is important. Pollution refers to the presence of harmful substances, chemicals or any type of substance which can be harmful to the human beings and plant and other things. As per the WHO or this guideline, a pollution is a substance found in an improper place at improper time and in an improper amount in the atmosphere. This is a pollution, and this can be, a pollution can be of natural as well as anthropogenic origin. Main sources of air pollution, natural sources. Everybody knows what are from where pollution comes, what are the sources and other thing. And these are some of the natural sources and man-made sources. Man-made sources, pollution sources are very important, and to prevent or to minimize, we should have some different techniques how to analyze, how to find out what is the level of pollution and other things in the field. What are the activities, which are the activities important for the pollution? That is the industrial emission, vehicle exhaust, burning of fossil fuels, agriculture activities, construction, and sewage from different industries or municipalities. Now, if you see the example of industrial emission and burning of fossil fuels, you can take the example of Delhi, where in I think 1992 or something, there was a directives by the Supreme Court of India that Delhi atmosphere should be monitored for VOC. So in those days, the technique of monitoring of VOC was very limited. And since that time I was in the Hindustan Organic Chemicals, a government of India enterprise, I could get and got the technique of thermal desorption coupled with gas chromatography and mass spectrometry. And this technique was used by Mr. Dr. or Professor R.H. Brown, who was working with UK government. So I could get some brief and some guidance from him, and I requested HOC management that we should have this type of system in our laboratory. Management could get convinced, and we have installed that system. In that time, it was costing more than 50 lakhs in 92 or 95. And with that system, we could monitor Delhi atmosphere in association with CPCB, Central Pollution Control Board, Delhi and Maharashtra Pollution Control Board. And in those time, we have used sampling pumps from SKC USA. So these are some of the important, and this technique is not much explored in India. Okay. Then these are the major pollutant industries. Industry releases harmful chemicals, heavy metals in the atmosphere, and simultaneously those goes into the water, wastewater or spring water. Then fertilizer, pesticides and animal waste wash into rivers and add into the pollution. Similarly, oil spill, there are a lot of instances all over the world. Oil gets spilled in oceans, seas, and that come into the system. Dumping of solid waste, that is also very important. Solid waste and hazardous waste, which is generated from the industries. After actually Bhopal gas tragedy in 1984, after that only Indian government has made hazardous waste rule in 1989. And in those days, hazardous waste rule, after making this, all industries which are producing hazardous waste, they have been listed out throughout India, and hazardous waste has been categorized in the category which are coming from during process, during hazard waste or water treatment plants and other thing. Those hazardous waste have been identified, and Indian government has created more than 35 hazardous waste facilities throughout India. In Maharashtra, there are 2 facilities. One facility is working at Mumbai, and one facility is working at Pune. In that facilities, in 2007, I was working as one of the director, and that facility was established, and it is still working. So that takes care of all type of hazardous waste industries are producing, and that is safely landfill or incinerated, depending on the calorific value of individual hazardous waste. So like this, there are many pollutants coming in the atmosphere. Then what is the impact of pollutant at local level and global level? This is all available. I need not go into the detail. Local pollution can affect city atmosphere. You must be dust pollution, particulate matter, VOCs from vehicular pollutions, and burning of other things, smog formation, health problem. And globally it causes climate change. That is very important, ozone depletion and transboundary pollution. Why did not then prevention and control of pollution. So how to prevent or minimize, these are the some of the techniques. This is available in this one. Then major environment pollutants, these are the pollutants, particulate matter, PM 2.5, particulate matter 2 and 10. PM 2.5 is a particulate matter with very small area which directly goes into the lung and affect our system. And on that also the virus and other things will be there. The nitrogen oxide, sulfur dioxide, carbon monoxide, ground level ozone, polycyclic aromatic hydrocarbons or VOCs, all these are the pollutants, and these are very important, and it has got lot of effects. It is not okay, ground level ozone produced due to the chemical reaction between NOx and VOC in presence of the sunlight. Polycyclic aromatic hydrocarbons, these are the pollutants which can even this is identified as a carcinogenic and it can produce a cancer. Volatile organic compounds, these are also group of pollutants including benzene and other things. That has been identified and some of them are carcinogenic. So their identification and quantification is very important in the workplace air or in the atmosphere. Is not okay. Pesticide are toxic substances or mixture used to control or repel or eliminate pest. These are also, if it is more, then it acts as a pollutant. Heavy metals, some of the heavy metals, these are lead, cadmium, arsenic, this and all this. Noise is also one of the known pollutants and impair the hearing capacity and other thing. Sometimes it is not work. Yeah? Okay. Okay. Take it. Next. These are some of the other sources of pollutants. Biomedical waste, explosive waste, electronic waste, then municipal solid waste and other things. This can be identified and taken care. Next slide, please. Okay. Next slide. Now, what is important? We have seen the pollutant. Then, what is their characteristics and why they are important? Some of the pollutants are flammable, some are corrosive, reactive, and explosive. They can be ignitable. They are toxic to the human health and environment, and emits flammable gases when they are in contact with the water. Then, what are the effect acute effect and chronic effect. Acute effect means the effect like poison when pesticide. There are cases happening when pesticide is in excess. You must have been seen that the farmer has died because of inhalation of the pesticide. So the pollutants which act immediately on the body, this gives the acute effect. These are the symptoms of the acute effect. Some of the chemicals when inhale, they react with the hemoglobin and reduces the oxygen carrying capacity in the body. Then chronic effects are like carcinogenicity, mutagenicity, teratogenicity, toxic to the blood, kidneys, lungs and liver, functioning of cardiovascular system, skin disease, effects on bone, central nervous systems and other things. Now, after seeing the effect, we should know how to identify and quantify these pollutants and why monitoring and analysis of pollutants and chemicals. To protect, why it is important? To protect the public health, to generate the air quality data which can be used in the future by the government to take the proper control or preventive methods, identification of pollution hotspot so that it can be taken care, to ensure the compliance with the statutory rules and regulation, develop strategy for mitigation measures, protect ecosystem, and to find out the workplace pollutants to ensure the public health, employees' health. And what happens if we take all these care? There are some of the benefits. Then what are the instruments required? These are the instruments available. Student can take note of this, and when we do the projects in the college or during study, these type of instruments can be useful. All these instruments are available in various industries and in our lab also. See, this is the inductively coupled plasma spectrometer. Here, the beauty of these instruments that any type of all elements mentioned in the periodic table can be analyzed on this instrument at PPT level, PPT or PPB level from any type of source. Then some of the other instruments which are useful for monitoring and analysis of various pollutants from air, soil and water. Then monitoring and analysis, I will just show 3-4 slides on this which are the important. So you can do the method development in the lab, and the polluted air is a dynamic and most complicated to do the analysis. This is heterogeneous and it contains solid particles, liquid aerosols, gases and vapors of different chemicals. Concentration of pollutants is low at ppm or ppb level in the atmosphere. So why I am telling you why it is important and what is required to analyze the pollutants from the air or any source, air, soil or water. So like this, what you should have accurate, reliable and sensitive technique or instrumental method for the analysis. First we have to do the monitoring. So monitoring is also very important. Assess the workplace air pollutants, selection of location, how to select the location for the monitoring, and sampling technique, sampling pump, sampling material, and what is important, porous polymer. Selection of sampling material or porous polymer, it is very important because any type of porous polymer cannot be used for monitoring of any chemicals. There should be some permutation combination, and for that we have to study which porous polymer will be useful for monitoring of the particular chemical. So that is also very big study, and one can find out porous analyte combination. Effect of temperature, humidity and sampling flow. This is also one of the parameters need to be studied. What is the safe sampling volume? How much sample you can take? How much sample you can take, so that sampling can be done effectively, and you can, whatever you are going to analyze, it will give 100% correctly result. Effect of temperature. Then type of sampling, it can be spot sampling, graph sampling, or time weighted average. Why time weighted average is required? As per the WHO or NIOSH, they have established the threshold limit values, TLVs. So what is the TLV? TLV is a concentration of chemical when anybody can expose while working for 8 hours without any harmful effects on the body and on even after his retirement. There should not be any chronic effect. So that is the TLV, and TLV is always time weighted average. Means it should be monitored a minimum for 8 hours in a shift. Then sample storage, packing, and transportation, all these parameters which have been given are very much important to get the correct results. Then site should be now how to select the site for monitoring. These are some of the very basic things. Suppose now this is a room, and now because of there are so many, if somebody is open the bottle, some bottle of volatile chemicals, then how to find out how much is the concentration of near source? Definitely it will be more, and if you go away, there will be dilution. So all these things are important, and we have to find out. These are some of the tips where to do the sampling. Then this is very important, retention and safe sampling volume. When you want to monitor volatile organic chemicals, then there should be safe sampling volume. You must be, you are knowing the example. If you take the sponge and if you pour the water up to certain capacity, it will hold the water. But when more water is poured on this, then water starts flowing. That means it has lost the capacity to hold the water. So similarly, this retention time and safe sampling volume is very important, because normally during sampling we use the sampling tubes which is filled with some porous polymer. It has got certain capacity, it cannot hold when you start the sampling with the active sampling pump. So after sampling of 5 liter or 10 liter of air, after some time it will not hold the that particular chemicals, it will go out. That means it has lost the capacity. That is called retention volume. During sampling, half of this retention volume is taken as a safe sampling volume to compensate for other interfering parameters like temperature and other pollutants present. See, there are certain methods which can be used how to find out how much sample you can take and what is the permutation and combination of porous polymer with the chemical. These are some of the methods. I will not go into the detail. And how to determine, I will just tell you how to determine the safe retention volume. One can pack the GC column in the lab. GC columns are available in the market also. You can have your own GC column with suitable adsorbent packed in this, and you can run the chromatography by injecting small amount in microliter of a analyte which you expect that it is present in the atmosphere. Then after injecting that particular analyte, you have to run the chromatography at various higher temperature, because then you should know what is the retention time and how much flow gas is required. So retention time, as you increase the temperature, you will get less retention time. And so that you have to plot the graph. And this is a survey. Like this you are doing, record the retention volume of analyte at each oven temperature along with the column flow. Then record the retention volume at different temperature with minimum difference of 10 degree. convert the retention time and volume to specific retention volume by using this formula. Okay. See, these are the some of the column, because if you take the GC column from the market, those are very costly. So you can have this glass tubing, these empty glass columns, or this stainless steel tubing, and you can bend around the bottle of 1 liter. You will get this type of shape. And then you should have vacuum pump and all this system with porous polymer, which you have studied. And those porous polymer can be filled with this stainless steel column by tapping, so that you can have lab-made column. The column normally cost in dollars, hundreds and $500. This column can be made within few thousand rupees in the laboratory. And you can study different columns and all. So like this, we have made. This can be 1/8 inch or 1/4 inch. These are the capillary column. This cannot be made in the lab. These are the available in the market by big companies. So this is the gas chromatograph. With this, retention volume in grams, liter per gram for benzene, toluene, xylene, all important chemicals which are supposed to be carcinogenic, and they were present. These has been studied and done, and the safe retention volume have been calculated, and actual work was taken in the field. 50% of the retention volume can be considered safe sampling volume in the field. Safe sampling volume is defined as the volume of the air containing contaminants that may be sampled over a variety of circumstances without any breakthrough. That is more important, so that you can get desired result. See, like this, just to show how to do the find out retention time and retention volume. So like this, you have to fix the column and inject your analyte, run the chromatogram, and I will show you how to plot the graph and other. So now this is a log of specific retention volume that we have received at a different temperature, and this is the reciprocal of column absolute temperature. Now we have run the chromatograph at higher temperature, more than 150 degree or 200 degree. Then we are extrapolating this in reverse at atmospheric temperature, maybe 20, 25 or 30 degree, and then you will get the safe retention volume. So like this, you have to calculate the retention volume in the lab, and 50% of this retention volume you can use for sampling at the atmosphere. See, like this, and there is a lot of difference in retention volume if you increase or decrease the temperature. So that's why I have said whatever retention volume you get, 50% of that can be taken as a safe sampling volume for the monitoring of any type of chemical. Some of the studied chemicals in lab, it is given here. These are the retention volume in liters per gram at 20, 30 and 40 degrees Celsius. And apart from this, we have also done the studied, because after sampling, we have to close the tube, and whether this tube, when you are sampled somewhere in Delhi and you want to analyze in Pune, so what will be the effect of storage, transportation and delay in sampling? So like this, these are the pumps from SKC USA. Those were used during sampling for precise sampling. These are the Tenax tubes or porous polymer tubes. These are also available in the market or can be made in the lab. So like this, these are the come, and this calibration graph and other. So first you have to, when you develop the method, you should have all this done. Thank you. These are the again compound retention volume for different chemicals. Only few examples have been given where carcinogenicity is important. Like this. This is the calibration graph. Okay, thank you.
Thank you, sir. Thank you, Dr. Lonkar, for your valuable insights into pressing
So-
issues of environmental.
Okay, anybody have any questions? Fast, one or two questions I can take. Okay. Thank you.
Thank you. Thank you, sir, for your insights into pressing issues of environmental pollution. Now, it is my honor to invite Dr. A.M. Krupanidhi to deliver the concluding note on behalf of the chairpersons. So I would request you to please keep it short.
Good afternoon, in everyone. Today, the session is come over with conclusions. Dr. Jayaprakash sir is concluded what I said. The leprosy is highly eradicated because of low socio-economic status, and one more thing is sharp growing populations in India. That is a major. Of course, there are many drugs which are available, DDS and clofazepine and all. Still it is because no registrations is failures. So that is very highly difficult to eradications of some of the infective and non-infective diseases in India. And Dr. Manohar sir, we have discussed a lot of things regarding the xenograft transplantations. There are some more problems are there that outcome result is very poor, what the discussions in the and novel drug discovery, the sir was elaborated in the many of the things, the chemistry part. It is really, and sir was mentioned, the herbs are not to be considered as a drug. Now, I have a comment on this. The biomolecules and isolated molecules are to be considered and to be a synthesis as a lead component, then to be considered as a drug. Drug is not only a synthetic analog. Drug is also an isolated part of a plant-derived component and marine-derived component. Hence, drug can cure illness, suppress illness, or to diagnose the component. So this is to be called as a drug. So that herb has to be considered as drug once isolated and characterized by spectroscopy. And Dr. S.T. Lonkar, the environmental pollutions, there is a big task as in today in India, because the pollutants has got tragedies which leads and everyone is sufferings with either the natural or either the man-made source of the pollutants. These pollutants which monitoring is very difficult because India civilizations has to be understand, and there are n number of factors are affecting, and definitely these are all reflecting on the health, particularly carbon monoxides and all, and to reduce the automobiles can be reduced as the pollutants. So this is my conclusive part of as a chairperson. Thank you.
Thank you so much, sir, for this enlightening talk. We conclude the morning session for Credit 2025. There is a short announcement. After lunch, the e-poster and the oral presentation session will commence in hall number 1 and 2 respectively. The participants should kindly follow the time slot already shared to them, and they are expected to proceed directly to hall number 1 and 2. The judges for the same are also requested to proceed to hall number 1 and 2. We now break for lunch, and I warmly invite all the dignitaries, delegates, and participants to join us in the adjacent banquet hall.
to the continuation of the first day of the International Conference on Recent Discoveries and Innovations in Life Sciences, Acredils 2025. We now move forward to the invited talks scheduled for this afternoon.
The session begins with an invited talk that promises to engage us with new perspectives from the world of molecular and developmental biology. It is our privilege to introduce our distinguished speaker for this session.
The speaker for this talk is Dr. Surendra Ghaskadbi, whose scholarly contributions have been instrumental in expanding our understanding of developmental processes in simple organisms and their implications for life sciences.
Dr. Ghaskadbi will deliver a lecture titled Hydra, Genes, Signals and Stem Cells, an extraordinary research organism and a great teaching tool. His expertise and insights will certainly add depth to today's discussion.
To formally introduce the speaker, I now invite Dr. Rahul Gaikwad.
Hello. Good afternoon. Welcome to post-lunch session of Acredils 2025. I am privileged and honored to introduce Dr. Surendra Ghaskadbi. Dr. Ghaskadbi has been associated with Developmental Biology Group at MAX ARI, that is Agharkar Research Institute, Pune, an autonomous institute of Department of Science and Technology, Government of India, since 1985. He is also Professor of Practice at D.Y. Patil Biotechnology and Bioinformatics Institute, Pune. His main research interests are cell signaling during pattern formation, evolution of developmental mechanisms, and stem cell biology. He has used a variety of model systems such as chick and frog embryos, sponges, hydra, and human mesenchymal and embryonic stem cells in his work. Over the past 2.5 decades, he has reintroduced hydra as a model system for teaching and research in India. His research has been funded by DST, DBT, CSIR, DAE, BRNS, and Indo-Japan grants. Dr. Ghaskadbi has published his work in reputed peer-reviewed journals and has several national and international collaborations. He has delivered many talks in national and international meetings and student camps and contributes to postgraduate teachings in many institutes around India. Over the past few years, he has been active in science outreach in different parts of the country. Dr. Ghaskadbi has been associated with several scientific organizations in India. He is the treasurer of Maharashtra Association for the Cultivation of Science and is the past president of Indian Society of Developmental Biologists and Indian Society of Cell Biology. He is elected fellow of National Academy of Science, India and Maharashtra Academy of Science. Okay. I request Dr. Surendra Ghaskadbi to deliver his lectures. Thank you.
Thank you, Dr. Gaikwad, for the thoughtful introduction.
May I now request Dr. Syed Razak to felicitate our speaker, Dr. Surendra Ghaskadbi.
Thank you, Razak sir. With this, we warmly invite Dr. Ghaskadbi to deliver his talk.
Lights. Good afternoon. Thank you very much to the organizers and Manohar for giving me an opportunity come here and talk to you. I have been a student of Ahmednagar College way back in the 70s, from 1972 to 1978, when I did my MSc in zoology. So most of the things that I have learned, good things and a few bad things, are all from Ahmednagar College. Today I am going to talk to you about some work that we initiated relatively recently about a model organism or research organism called Hydra. Many of you must have heard about it, but now Hydra has become a very useful research organism simply because it has a tremendous capacity of regeneration. In the morning you have heard about organs, organ transplantation, the non-availability of sufficient organs. And by working with different taxa which have great regenerative capacity like the Hydra, the Planaria, or the amphibians and reptiles, one gains knowledge about the basic fundamental mechanisms of regeneration, and it is often useful to employ it to human stem cells in culture and perhaps go towards organ regeneration in vitro. Apart from the direct application of such work, there is also scientific curiosity. Hydra is an organism which is believed to have evolved about 600 million years ago. And as I will demonstrate in the next 25 minutes or so, that it has many mechanisms at the cellular and molecular levels which are not terribly different from what we see in human beings. So things have been conserved over millions of years, and by learning from some organisms, we can understand biological processes, more complex organisms. Can I have the presentation? Oh, of course. So this is the organism I am talking about. I am also going to touch upon the utility of Hydra as a teaching model, especially in view of the ethical problems in using more complex animals. Let me first, thank all my colleagues over the years. And you can see that before it became very popular to talk about human power, my lab was already powered by so many different wonderful women. You can see majority of them. You will also see some gentlemen. They are required to take things from top cupboards. They are also there. Okay? So over the years, I have worked at Agarkar Research Institute, and I still am very closely associated with that. So I'm talking about this organism Hydra, which is a cylindrical organism, and it's about a centimeter and half in length. If you cut a Hydra here at the top with a blade, slight cut, then it develops two heads. If you take two cuts, it develops four heads. So it kind of becomes multi-headed. And therefore, rather unfortunately, it picked up its name from a monster in Greek mythology called Hydra. And you can see Hydra being killed by King Hercules. Okay? So this is from Greek mythology, and this is near a palace in Vienna where you can see King Hercules trying to kill the Hydra. So Hydra is a monster in Greek mythology, but I can assure you that it's a very beautiful animal and has been providing me bread and butter for me. So just to put things in perspective, we are talking about an organism which evolved long back. So you have the evolution of the sponges here, and zoologists would know that this is the beginning of multicellularity in the true sense in animals. And after that, you will see the evolution of the phylum Cnidaria, to which jellyfish, corals, Hydra belong. What I would like you to notice is that the nerve cells make their appearance for the first time after sponges. Sponges feed by phagocytosis, food particles through the water that is flowing. But Hydra, since it has nerve cells now, it shows for the first time in animal evolution an organized nervous system. So nervous system came into existence in Hydra about 600 million years back. As a consequence of that, Hydra has a simple nerve net, and because of such a nerve net, and since it can sense the environment and act accordingly, it shows active feeding behavior. So sponges are passive feeders. Hydra shows active feeding, and that was a huge jump in evolution, considered to be one of the major jumps in evolution, where animals started active feeding, feeding actively. We have, of course, taken this active feeding to a great level where we cannot control how much we eat. but that's besides the point. So this is important. There are two aspects. First organism to have a nervous system. We don't, there is so much work on neurobiology. We want to know about complex nervous systems, cognition, and so on. But it all started here. So people are interested in looking at it. And secondly, as I mentioned earlier, it has a tremendous capacity of regeneration. So it was introduced, this organism was introduced to science sometime in 1744 by a person called Abraham Tremblay. Abraham Tremblay was a mathematician interested in studying infinity. But in his free time, he would go for looking for aquatic insects, insects in water. And on one such occasion, he found some strange floating tubes in water. He brought them to the laboratory and did many experiments with that. People earlier did not have different departments. So we have made different departments and probably have lost the capacity of observation. Anyway, this mathematician found this, and what he did was, on 25th November, this is from his own, notebook. On 25th November 1740, he cut the polyp into two pieces, like this. This is from his original drawings. All these are his original. And the two pieces regenerated in few days. So before this experiment, people had shown regeneration of legs in crayfish and so on. But this was the first time that an entire organism was shown to regenerate completely. And that sort of caught the imagination of people. There was an artist who came out with dancing hydra figure, like human figures and so on. So people actually traveled to Tremblay's lab to see what they called as Tremblay's polyps. So until that time, people used to bring terrestrial animals to the lab, but this was for the first time that you could bring an aquatic organism, maintain it, do experiments with it, and Tremblay even posted it through the European postal system to different labs in Europe. So this was kind of birth of marine zoology or aquatic zoology. These are how hydra look in the lab. So these are from my lab. We have a culture that is going on for the last 25 years. So I collected one hydra from the botany department of Pune University, and we have maintained that culture in spite of COVID. That time, one of the technical assistants took hydra home. She used to keep it in front of cooler, feed them. So she took good care of them, and we still have them. So this is one of the species that you find in India, which is known as Hydra vulgaris, brown hydra. You will many times come across the species vulgaris. Usually we are worried about the word vulgar, but originally the word vulgar has come from vulgus in the Latin language, and it had a neutral meaning. Now vulgar has also caught up a negative meaning. So whenever you see vulgaris, actually it means it is most commonly found, okay? Like octopus vulgaris or hydra vulgaris. We also get another species of hydra in India, which is green hydra. It looks green because it has chlorella as endosymbiont, okay? But we mainly work on brown hydra because while working on these hydra, there is always a contamination from the chlorella cells, like DNA, RNA comes from chlorella cells. Hydra is a diploblast. We are triploblast. We have ectoderm, mesoderm, and endoderm. Hydra does not have mesoderm. It has only the ectoderm on the outside, endoderm on the inside. The whole body has a definite plan, unlike sponges. So it has an oral end, aboral end. Here there is a conical structure called hypostome, and at the end of the hypostome there is a opening called mouth, through which the hydra feeds. And the food is digested here, and the undigested food is thrown out of the same opening. There are a few tentacles which have stinging cells, which are a characteristic of cnidarians, jellyfish, corals, and hydra, which paralyze the prey, and with the help of the tentacles, the food is pushed inside the body. It is made up of two epithelial cell layers, ectoderm and endoderm, and it is separated, these two layers are separated by a modified basement membrane called as basoglia, which is made up of collagen, laminin, and so on. These are all epithelial cells, but among them you will also notice neurons, gland cells which secrete the digestive enzymes. Food is digested here in the body column, okay? And then it has also these stinging cells that I mentioned, nematocytes. Here at the top you will see the spine through which it poisons the prey, and then once it paralyzes, puts it in the mouth. So it's a relatively simple organism, which about 20 to 25 different kinds of cells. If you look at our body, we have about 200 different kinds. Our body is made up of trillions of cells. Hydra is made up of about 100,000 cells. So that is the difference in complexity, and therefore a less complex organism is easier to study in the lab. If you look at the cellular dynamics of Hydra, it's very interesting in the sense that the cells here, the middle of the body column, continuously proliferate. Okay? So they undergo mitosis and their progeny tends to move towards the two extremities of the body. As the cells move towards the mouth and the foot, the cells also differentiate into neurons, into gland cells, into stinging nematocytes and so on. And in about 20 days, you may not be able to see this days here, but in about 20 days they reach the extremities and the cells undergo what is known as programmed cell death, apoptosis, and are thrown out of the body. Interestingly, whenever you take any cell from a body of a hydra that you find in the pond outside, no cell is more than 20 days old. Okay? As a consequence, the cells age and die, but hydra does not die. So it is a potentially immortal organism. Nowadays, people have taken interest, aging biology people have also taken interest in hydra because it escapes organismal aging. It is potentially immortal. And there have been some algorithms scientists have built to find out longevity of different species in the world, plants and animals. According to that algorithm, hydra can live at least up to 10,000 years. I'm sure none of us will be here to confirm that, but that is an algorithm that predicts it. Okay? And why does this happen? Because hydra has stem cells. All these years, last few years, we thought that we are very special. We have stem cells, complex organisms have stem cells. But even an organism which evolved 600 million years back also have stem cells. So the two types of stem cells that it has are known as the epithelial stem cells. So one gives rise to the ectodermal epithelial cells, the other gives rise to the endodermal epithelial cells. So these are sold in yellow. So the entire body almost of the hydra is made up of stem cells. Obviously it doesn't get old because stem cells can continuously proliferate and differentiate, as you know. Only the blue cells are so-called terminally differentiated cells. That means they cannot divide, but they die in 20 days and are sloughed off. So these blue cells cannot divide. As a consequence, the entire body is made up of stem cells, and therefore, if you cut hydra, it will regenerate, as you know, Tremblay saw in 1740. But this is about the epithelial cells. I also told you that it has neurons, nematocytes, gland cells, mucus cells, and so on. All these come from a third stem cell population, which is known as interstitial cells, or eye cells for short. These are very similar to multipotent stem cells that you find in higher organisms. So they can give rise to sensory neurons, ganglionic neurons, they can give rise to nematocytes, gland cells, and if need be, they can give rise even to the gametes. So hydra usually reproduces by budding, by asexual means. But if conditions become unfavorable, like lack of food, drastic changes in temperature, it goes for sexual reproduction, in which case it will produce gonads. In some hydra species, both ovary and testis is produced on the same polyp, in which case it becomes hermaphrodite. In other species, there are male polyps and female polyps. Fertilization is external, and then embryonic development takes place. But that is extremely rare. Hydra doesn't like sex because it involves a lot of energy. So in the lab, suppose we need, let's say, 2,000 hydra tomorrow for an experiment. We start feeding them so much over the last 10 days before that, so that it gives out more and more buds. So you can actually control the growth of hydra in the lab. And it is all possible because of the stem cells. I also told you that hydra can undergo regeneration. So this is an experiment wherein we cut hydra into 3 pieces. Okay? So the top piece regenerates the lost foot, the bottom piece regenerates the lost head, and the middle piece regenerates both head and foot. In fact, you can make 20 pieces of one hydra and you will get 20 entire small hydra in the lab. Okay, it has that kind of tremendous capacity, much more than planaria. Planaria, if you cut a planarian into 256 pieces, you get 256 planaria. Here, not only small pieces, even if you completely disaggregate the cells, make a pellet of cells, even that pellet regenerates into an entire hydra. And that is why people would like to know the secrets of hydra regeneration, how its stem cells behave, are they similar or different from our stem cells, and so on. And that is why it has caught the imagination of cell biologists, developmental biologists, and also a new branch of developmental biology, which is known as evolutionary developmental biology, or EVO-DEVO for short, which studies conservation of developmental mechanisms from simplest organisms, more complex organisms, including humans. So that is a new branch where hydra is a very important research organism. So about in year 2000, I had used hydra for my PhD sometime in 80s. But in the year 2000, we were wondering how to look at the nervous system. That was the interest in the lab. We were using frog and chick embryos. But there are certain experiments one could not do with more complex embryos like hydra and frog. So I thought of using a simple organism. And since I had worked with hydra years back, I thought of using hydra because I told you earlier that hydra is the first organism to have a nervous system. So it has the simplest nervous system, and we thought that if we look at it, probably we'll get some hint as to how nervous systems develop. We are not yet successful in that, but we got some lead. So we looked at genes in hydra which are homologous with vertebrate genes, which are similar with our genes, carry out similar functions. We also looked at the DNA repair in hydra. Because of the longevity of hydra, one would obviously expect that the DNA repair mechanism is very robust in hydra. Because DNA damage occurs all the time in our body and it needs to be repaired. If the DNA remains damaged, then mutations will occur and the cells will obviously die or go for cancer production. But in hydra, we have found that a very robust DNA repair mechanism happens. We have also looked at microbiome of hydra and so on, but I'm not going to all that. What I thought of that not only it will be useful for looking at nervous system in hydra, but after say the year 1975-76, nobody had used hydra, and I thought it will be also a good teaching tool, okay, because that time lot of problems with animal ethics came up in around year 2000. Hydra you can still use freely, okay, because it is not been proved that hydra has pain, okay, so that's why it has escaped. Like Drosophila, it has escaped the ethical clearances. So what I'm going to do today, I'll give you just one example from here, the gene noggin. Noggin in colloquial English means head. Like, you know, in old writings of Woodhouse and all, you will see he hit on his noggin. So noggin, this name is given because noggin is important in our head development, in our brain development, okay, the anterior side. So we wanted to find out whether such a gene is present in hydra, which evolved many years back. It was not known till then. So evolution and survival of multicellular organisms, as you know, depends on the communication between cells. Otherwise, there will be, the organism cannot survive. And there are certain signaling pathways, these 7 signaling pathways, which have been conserved in all animals. These are sufficient for any organism to develop and to sustain till its death. So these are common in many organisms, and we wanted to see whether some of them are indeed present in hydra. I told you that hydra evolved long back and has a first nervous system, and I also told you why we were interested in that, because we were interested in how nervous system starts developing in the early embryo. So let me explain with a cartoon of a frog embryo. You know, this is a frog embryo, wherein there is a pathway, signaling pathway. Signaling pathway means cells talk to each other through this pathway, right? It's a kind of language. So BMP, bone morphogenetic protein, you need not bother remembering the name. This pathway is active in all the cells in the early embryo. However, in certain part of the embryo, this part for example, this BMP pathway is inhibited, okay? So it cannot function in this part through inhibitors called chordin, noggin, follistatin, as a result of which this part of the embryo becomes dorsal. This is a dorsal ventral, this is anterior posterior. So when we develop from a single cell, our dorsal develops on just like the frog. Okay, that is the first axis that develops. So BMP inhibitors like noggin are important for formation of the nervous system. that is why we wanted to look for noggin in Hydra. It was not known till then. So noggin we looked at, started from there. And initially, in the first 2 years, we could find noggin-like proteins in the different parts of Hydra. So you can see staining for noggin messenger RNA here, the transcript. So it showed us that noggin is present in Hydra. We were quite excited. And this was published in a journal called Journal of Biosciences, published by National Academy of Sciences in Bangalore. As one would expect, since our lab was entirely new, this was the first Hydra paper from the lab. It was from India. It was in Journal of Biosciences. It was totally ignored. Okay? This is not new. Everybody knows. However, there was a scientist, unfortunately he passed away, Hans Meinhardt, who was a theoretical biologist working in Germany. He cited this paper in his review in Nature Reviews in Neurosciences in 2004. Okay? And then suddenly, people took notice. Not many people took notice. We didn't get any benefit out of it, but it gave us a lot of confidence that what we saw here, which were not really very clean experiments, because the kind of probes we used were from frog. So it was not a clean experiment. It was not Hydra. But one student who came from Nasik, Kalpana, now a faculty in Baramati, she agreed to work on Hydra. See, Hydra, no lab was working in India, so no student was ready to work there. It was a risky project. Okay, everyone wanted to do chicken frog because that was going on, day and night in the lab. By using simple bioinformatics means, Kalpana could actually show that Hydra indeed has a noggin-like gene. So this is the predicted amino acid sequence, and you can see that it's being compared with chick, frog, human, and zebrafish. And all the important cysteine residues that are required for noggin function are conserved in all these species, right from Hydra to humans. Okay? I will not go into details, but important residues have been conserved. When she looked at the three-dimensional structure of Hydra noggin, she saw that it's very similar to human, xenopus, and sea urchin. Okay? So that gave us a lot of confidence. It was real excitement in the lab that Hydra has noggin, and we are the first one to look at that. But this is only structural similarity. Amino acid sequence, nucleotide sequence, 3D structure, which is predicted, and so on. So what we wanted to do was to find out whether it is actually Hydra noggin, whether it is actually similar to noggin from vertebrates. So I collaborated with a frog embryologist, Professor Makoto Asashima, to find out whether we can do some experiment. This is on Assi Ghat in Varanasi. He had come for a conference. So what I mean by this experiment is when you want to find out whether that protein is conserved in function, what you do is you use the protein from Hydra and try to see whether it can function in a frog or embryo. Do you understand this? Very simple. So for that, what you do is you clone the noggin gene from Hydra and make the messenger RNA in the lab, and that messenger RNA is injected in the frog embryo. Okay? Frog embryo has its own noggin, but what you are doing is you are putting additional one from outside. So in this experiment, what you are doing is this noggin concentration you are increasing. Okay? So what you should go, if it is functional, what you should see is more dorsal structures. And if you do the same experiment with frog's own noggin, if you overexpress it or inject more, then what you see is you get two axes like this, two-headed embryos. Okay? So we injected frog noggin also in one set of embryos and Hydra noggin in another set of embryos. And like the frog embryos, in 30 out of 30 cases, we got duplication. You understand the experiment, I hope. So that means that Hydra noggin sequence, amino acid sequence, nucleotide sequence is not only homologous with the sequence, but actually that protein when put in embryo can function. Okay? So that means it is both structurally and functionally conserved. There is another experiment in Hydra in which if you irradiate frog embryos early with UV, ultraviolet rays, it doesn't form the dorsal structure. So it looks what is known as ventralized. you may not know the structures, but you can see that the pigmentation has gone down. Okay. On the other hand, if you overexpress this noggin, you get more dorsal structures, as you can see from more melanization. So what we thought of doing was, do this experiment. Take frog embryos, irradiate them with UV, and see whether this effect of UV is neutralized or rescued by hydra noggin. Okay? So when we did that, these are normal tadpoles. These are tadpoles irradiated with UV. You can see that there are no dorsal structures. But when you, along with UV, if you inject either hydra noggin or xenopus noggin, then you see some rescue. That means they are not as bad as this, but they can develop certain structures. So once again, it was further proof that hydra noggin is indeed structurally conjugate. I have taken the example of noggin, but there are several such genes which show a lot of structural and functional similarity between hydra genes proteins with human genes and proteins, which came as a surprise because these proteins and genes do not show similarity. Drosophila and Cynorhabd worm proteins, but they show similarity with vertebrate, including humans. So we have carried out a lot of work on such molecules in the BMP pathway. For example, we showed that noggin and gremlin, these are two inhibitors that we discovered. Chordin was discovered by somebody else, and overall this is the picture we got. I will not explain it because it's not relevant. What I'm trying to tell you is that there are signaling pathways in hydra which are very, very similar to signaling pathways in humans. That means they have evolved millions of years back and same have been conserved. So to make a human or a giraffe or a fly need essentially very similar signaling pathways. So these are all the different pathways that people have discovered in hydra. For example, Wnt pathway, BMP pathway, FGF signaling, VAGF signaling, and so on. All those 7 pathways that I showed you, almost all of them are present in hydra. And these are the 5 that those have been contributed from India by our lab. Okay. Then the other, I'll just give you a flavor of the other part, DNA repair, which I did in collaboration with Saroj Ghaskadbi, who was a DNA repair person. He worked in Pune University. We did a simple experiment. We cut hydra into 3 pieces, irradiated with UV, and what we found that when it regenerated, in 1/3 of the cut middle pieces, we got duplication of foot. Instead of 1 foot, 2 feet developed. We were very intrigued by this because we know that DNA damage proteins, DNA repair proteins also have a role in development. This is a kind of development and pattern formation. So we decided to follow it up by looking at DNA repair. The nucleotide DNA repair system in hydra involves many proteins. These are known as xeroderma pigmentosum proteins. Because if nucleotide DNA repair is defective in humans, because of the UV-induced damage is not repaired, we get a disease called xeroderma pigmentosum, which leads to skin cancers. And you know, fair people will have to apply sunscreen because of that. You know, you have to protect the skin. We are relatively protected well. But this is known as xeroderma pigmentosum. So there are 7 such genes from A through G, A, B, C, D, E, F, G. We wanted to look for such genes in hydra. And before that, we wanted to see whether UV actually induces DNA damage in hydra and whether it is repaired. So to cut a long story short, what we showed is, if this is the DNA damage, that DNA damage gets repaired over time. And you can study it by looking at what are known as TT dimers, thymidine dimers that are induced in the DNA because of UV exposure. So UV-induced DNA is indeed repaired in hydra. Then we looked for the DNA repair genes. And to cut a long story short, we have discovered all the XP genes. So A to G, all genes are present in hydra. Please remember, we are talking about a relatively simple organism. Okay? Not only that, it also has Cockayne syndrome A, Cockayne syndrome B. These are 2 more genes. It also has TTDA, it has non-homologous end joining, the DNA repair method that Manohar mentioned. All these methods are in place in Hydra. Okay. Once again, we wanted to find out whether XP genes in Hydra are homologous with human genes, human proteins, functional. So what we did was we collaborated with another Japanese scientist, and now what in many labs people have isolated XP deficient cells from patients. So XPA deficient, XPF deficient, these cells are cultured in the lab. Obviously these cells cannot repair UV-induced damage because they have defective protein. But if you provide that protein from outside, human protein, they start repairing the DNA. What we did was, instead of providing human protein, in that place we provided the Hydra protein. So just one example, XPA, we carried out this work. Once again, it was very similar in three-dimensional to human beings. Now we were getting used to it, and this was expected. If it had not come like this, we would have been disappointed. So what we did was, we transfected the cells, XPA deficient cells. So these cells have no XPA protein, and therefore they cannot repair UV-induced damage. Okay, and a result of that, they die. However, if you provide them with normal human protein, they can repair the DNA like the wild type cells. With Hydra, they can repair it partially. What it means is, although Hydra XPA is not as efficient as human XPA in human cells, it can still function. That again shows that these proteins which belong to DNA repair group, the genes group, also are conserved over at least 600 million years. So it gives you a principle that things do not have to be rediscovered again and again. The basic genetic toolkit that is required to make, let's say, a fly or a hydra or a giraffe or a human being has evolved long time back, and it has been used again and again with some tinkering, like where the gene is expressed, when the gene is expressed, how much it is expressed. You can make different animals, and that is how, by using similar mechanisms, can still generate so much biodiversity that we come across. So we believe that there is so much work to be done in DNA repair, but we believe that it has implications for abnormal development as well as the stem cell maintenance, which gives Hydra its capacity to escape organismal aging as well as tremendous capacity of repair. I started using Hydra, and then subsequently a few colleges took Hydra from me. Many universities in Maharashtra, as you know, have introduced this as a practical now, okay, for BSc. But I started getting calls the previous evening, sir, tomorrow morning Hydra chahiye, hamara practical hai. People started ordering me in the night. Then I came out with a kit, okay, and we charged. It is still available with Agarkar. 3,000 rupees we charge. But this is, if you have a nearby park, you will not bother. If 5 rupees are charged, we'll take care of the park, and then the importance is there. Likewise, we introduced this, and more than 50 labs, colleges, schools in India have used this species, used this kit. We provide the Hydra polyps, we provide the food, we provide medium, and you can maintain it. Rivers in Mumbai has a Hydra lab now. Aligarh Muslim University has. Many people have started a Hydra lab. You can give excellent short-term projects to that. It's a relatively inexpensive method. Only thing is you have to feed them twice a week. So if on summer vacation you go home, they will die. And that is what happened in many colleges, because people, these are like pets. You have to take care, like, your dogs and cats. Anyway, this has become very popular. What I told you is briefly summarized in these 3 articles. This is from Resonance, which is freely downloadable. This is written for college students and faculty. You can download it, about how to use Hydra for teaching and short-term projects. This is about the cell signaling molecules review, and this is DNA repair repertoire that we found in Hydra. I do a lot of outreach of Hydra, and this is from St. Michael's School, Ahmednagar, DHU Varanasi, Chipudun. So wherever we are invited, we go and actually demonstrate Hydra. We had a Aligarh Muslim University. We recently, in May, we had a workshop for college teachers in National Center for Biological Sciences, Bangalore. We have also done it. So there are no boundaries. Anybody who's interested, one of my colleagues from Agarkar and I will go there and we take a 3-day workshop. We don't charge anything by the except for our expenses. So this is one of the things that I'm very satisfied about, because doing experiments on computer, dissecting animals on computers, never tell you the real biological processes. That's where such organisms can help. I also take them to schools like here, and the students are so excited. I just cut them and leave them in the schools, and 2-3 days later I get messages from the teachers, oh, they have reaggregated, regenerated again. Students are very happy. So biological processes like budding, regeneration, how to maintain them, all can be very easily exposed. The students can be exposed. This is just to tell you that at one point in time I was young. So I was in the college, I was a debating secretary here. This was sometime in 76. And this is late Professor M.R. Bhide, who was dean, was the chief guest in Ahmednagar College. This is the crest was put on the blazer, no? I still have it. Next year I complete 50 years of this, okay? So I have a very close association. As Bhushan mentioned, my father joined this college on day 1, okay? And then he taught here for 32 years. He taught English. 79 he retired. So I leave you with a very precious photograph which was in the collection of my father's album. This is on the eve of the opening of the college, the previous day, okay? So this was June 20th, 1947. You will see that this is on the eve of the opening, and the college was affiliated to University of Bombay. Within a few months in the same year, it became University of Pune. Then we got affiliated with, University. So our people who drove that time, and we had excellent people here. The person who went on to become the first chairman of the Indian Space Research Organization, Sir U.R. Rao, taught here for 1 year. The head of the person who taught history here, Professor A.R. Kulkarni, went on to become head of history department in Pune and did a very comprehensive study on the administrative acumen and administrative features that Shivaji Maharaj followed. So, like in science, we say that we stand on the shoulder of giants. People in Ahmednagar, faculty and students, stand on the shoulder of giants, and I have hope that by your work, you will make all of them and us proud. Thank you very much. I can take questions.
Thank you, sir, for such an insightful presentation. The way you highlighted the role of Hydra as both a research organism and a teaching tool has given us a refreshing perspective on how simple systems can reveal profound biological principles.
Your reflections on genes, signaling pathways, and stem cells has certainly enriched today's discourse and have opened up new avenues for thought and exploration. On behalf of all present, we extend our sincere gratitude for sharing your expertise with us, sir. Thank you, sir.
Thank you. No questions? Yes. Not really, because this escape of aging is because of replacement of cells. In our case, that doesn't happen. In our case, the cells age, but they are still in the body. That's how we age. So there are slight differences, but the kind of signaling is same, and the stem cell maintenance is very similar. And therefore, people would still like to know the secret. So telomere length and telomerase activity in Hydra is studied, but it's not very useful because the cells die. But the organism per se doesn't die. If we start doing that, we shed our skin and all, but not the more. So it's not a really directly, you cannot apply Hydra for aging. Okay, thank you very much.
Thank you, sir. We now move ahead to our next invited talk in this afternoon session. The focus of this talk takes us into the fascinating yet complex world of toxin biology.
It is my privilege to introduce Dr. J.R. Kumar, whose work has provided valuable insights into the functional mechanisms of venom proteins and their biomedical significance.
Dr. Kumar will be speaking on unveiling the functional mechanisms of Russell's viper snake, venom phospholipase A2. This promises to be an engaging session where molecular science meets real-world biomedical challenges.
To formally introduce the speaker, I now invite Professor Prasad Lamru.
And all. This is Dr. Prasad Lamrud. I am here to formally introduce our next speaker, Dr. J.R. Kumar, who is working as an Associate Professor, Division of Biochemistry, JAS, AHER, Mysore. Dr. Kumar holds a PhD degree in biochemistry from the University of Mysore, and he completed 5 years of postdoctoral research in neuroimmunology and brain energy metabolism at the Wisconsin Medical College and UND Medical School, USA. His research interest lies in the study of snake venom, pharmacology, novel anti-venin strategies, snake bite diagnostics, and neuroimmune signaling in remyelination. He successfully guided 6 PhD students, received funding to the tune of over 1.5 crores from various institutes such as DST, SERB, DBT, UGC, ICMR, NIPER, Kolkata, etc. He has more than 30 research papers to his credit, authored 5 books, chapters, and holds 5 patents, as well as he has delivered numerous invited talks at various international conferences and serves on editorial boards of several scientific journals. Similarly, he is honored with the Best Scientist Award at the international conference, which was held in Banaras Hindu University. So with this brief introduction, I request Kumar sir to deliver his talk. Thank you.
Thank you, Professor Lamrut sir, for the introduction.
May I now request Dr. Pavanjit Chabra to felicitate our speaker, Dr. Kumar.
Thank you, ma'am. With this, we invite Dr. Kumar to deliver his lecture.
Thank you. I thank the organizing secretary and all the team, the organizers, Dr. Ivan Arana. He's my friend during my PhD, and he took the whole of my work during my PhD, and we started a new area again after my PhD, and also I got a few grants on that work. So. The most importantly, why we study this molecule, phospholipase A2. So this work we started with my mentor's lab in Mysore University Department of Biochemistry way back in 1970. And after that, I am actually the 20th student in that group. So this molecule worked for more than maybe 30 years or 40 years. So why we choose, again, the snake venom phospholipase A2 is an enzyme. It actually degrades the phospholipid and releasing fatty acid. Again, the byproduct, again the lysophospholipid, has biologically very active molecule and has a membrane damaging properties. Wherever it goes, it damages the membrane of particular cell. And again, apart from this, there is a lots of hypothesis that has a toxicity due to the enzymatic activity and toxicity to the non-enzymatic activity of these enzymes. So hydrolysis membrane and releases fatty acid, and again, this membrane disruption causes lots of the membrane lysis. Because of that, wherever it goes, it lyses, and again you will get lot of the membrane damaging. Say wherever it goes, so liver, kidney, again neurons, so on. There are many different cells will be affected. So again, why only phospholipase A2 is a toxic? We have other toxic molecules, say enzymes, toxins, again peptides and non-protein components. So mostly we engaging this today is the enzymatic part, where the phospholipase A2 play an important role in toxicity and morbidity and killing of humans also, wherever it bites. So again, non-enzymatic toxins, where the small peptides is about 60, 70 amino acids, whereas enzymes are more than 120 amino acids. Especially these proteases, phospholipase A2s are very, very important for killing the victims. And again, these peptides and non-proteins, peptides, of course, there are toxic peptides. Again, these composition of the venom, again, differ from different regions. Say Western India, Southern India, then Eastern India. Now we have a Northern region India. So I worked in my PhD at the Western region, especially the Mumbai region, India, Russell's viper venom. More of complex toxin, less of phospholipase A2, and more of trypsin inhibitors, right? Protease inhibitors. Whereas in southern India, we have a lot of phospholipase A2, where the composition is around 35% phospholipase A2, and the death because of that, the composition of phospholipase A2. Whereas in eastern India, we have proteases and toxic peptides. So these are like, biochemical properties, at that leads to actually giving some idea about how you can prepare these antivenins. So I start this talk in southern region Russell's viper venom, the phospholipase A2. So again, viper and the crate, cobra and the soft-scaled viper, again, you can see that Russell's viper venom has a mixture of these lipases and proteases. Is a master venom. Whereas these cobra is rich of these peptides and toxic peptides. Whereas the soft-scaled viper rich of, again, the neurotoxins. Again, crate has a very silent killer, but it is highly toxic compared to all these big four. Again, this lipase, I told you, it is a membrane damaging property because of lipase acting on the phospholipid, releasing lysophospholipid and fatty acid. So we started this work and we published in various different journals. Say neurotoxicity, say we publish these in good journals where how exactly these lipases are toxic peptides affecting on central nervous system. We shown that it is affecting on NMDA receptor and non-NMDA receptors, and also we shown in the frog that it is affecting on ACHE, acetylcholine receptor also. Again, lung hemorrhage, we shown long back, it is affects on the lungs in the southern region India. Especially we given a name, why we given a name I will tell you. We are a PL5, we are a PL8, Vipera razali venom, phospholipase A2, 8th isoform and the 5th isoform. So it affects in lungs, it affects in kidney, and we shown all these things before, like last 30 years when I'm doing my PhD in 2002. Then during my 2004 or so, me and Ivan Arana, we started working in his lab. So I am very weak in histopathology, and he started guiding me how to do. And also he is doing my tissues, and while dissecting, we taken male reproductive system and started working on it that. So finally he found there is a lot of changes in the male reproductive system, and we started working on some biochemistry part and also in his lab. we working on male reproductive system. We come up with a toxin. We call it as a reprotoxin because it is affecting male reproductive system. So because of his work, we name that as a reprotoxin because it's affecting reproductive system. But we didn't work on a female, but we got a many data. After that, I got my PhD, I gone for a postdoc. After coming back, one of my students, he started working on a male reproductive system, especially on southern region, phospholipase A2. Again, he got the same results. Say, why these toxicity will be appearing? Say, why you are working on other pharmacology? Say, when you give an antibody, the person will be alive, okay, but has secondary effect in it. That's what our interest is. Say, even giving anti-venin therapy, the person will have a secondary effect. Say, he lost his fertility. Sometimes he lost his kidney function also. After many therapy, after many months, the kidney function will comes back, and also he become fertile. So this problem we seen when we look into the histopathology of the male reproductive system, and we started working on that. He got an ICMR SRF and he got a degree. So it opens a new window for what you call, say, lot of secondary effects in snake bite, apart from the complete death. So this was we shown, and all the different histopathology he explained very well. Then we shown that many other organs also affected, skeletal muscle myotoxicity, cardiotoxicity. It also affect on kidney, pituitary gland dysfunction. All these are shown. So overall, it affects the most of the organs. But we studied certain protein they are affecting on the central nervous system, NMDA receptor, ACH system. So, but recently in our campus, one of my MSc students bitten by Rhizosspis venom. He treated in a hospital with a regular English medicine, but symptomatically is okay. He got everything recovered. But loss of that muscle is very difficult to heal by the English medicine. Finally, the doctor only suggested that we should go on, take Ayurvedic medicine, the traditional healers. He got to traditional healers, and he gave a lots of different kind of therapy. It took around 8 months, almost a year, to heal complete muscle formation on the foot. Then we closely watch all the treatment with all my students. They're also watching, take all the reports, and we published in a case report in Bentham Science. And we used again some photos I am showing. It's completely lost and completely healed. And in between, they use all the plant medicine. So after that, we use the same plant molecules, and we mimic the same work in the laboratory. We got the same result. So that's why our student, they started working on the traditional the plants, and in the laboratory, we purify also, we synergistic also we are working on. Finally, they are working on in the both aspect how muscle will be affected, undergo necroptosis pathways. Another one is they are working on the preparing a ointment and a bandage for snake bite treatment. So that's how like how you can allopathic treatment and Ayurvedic treatment complete recovery. So today my talk is why this phospholipase A2 is also present in pancreas, also present in snake venom. There is a lot of changes in the structure, especially in the amino acid composition. That's how explaining the whole of this enzyme based on the function, how we can study the function of individual amino acid. So actually, this in both are secretory PLA2s having conserved at histidine 48 and calcium binding loop. It's about the molecular size is about 120 to 140. But there is a key change, divergence in the histidine 48, that aspartate 49, whereas in venom we have a lysine 49. There is a small changes in that makes it toxic. Apart from that, there are structural changes also. But key is that lysine 49 play an important role. Whereas venom PLA2 have there is a changes in their hydrophobicity in their structure. The venom PLA2 has a hydrophobicity, and those hydrophobic amino acids are actually the basic surface patches. So whenever that enzyme is there, that will goes and binds to the different cell. Actually, the hydrophobic patch will goes and binds, and it induces toxicity. So it started their activity. So the increasing membrane binding, and it gives a lot of toxicity irrespective of the cells. But visibly you can see the myotoxicity, loss of muscle. So this pancreatic PLA2 has a lack of these aggressiveness, loss of these hydrophobicity on the surface of the protein. That's how it makes the snake venom, Russell's viper venom makes toxic, whereas bovine pancreatic PLA2 become non-toxic. It only helps in digestion of the lipids. So it's a traditional method of, conventional method of purification of this enzyme using venom, using say gel formation chromatography and CM Safedex C50, the Safedex G200, and followed by this the same conventional RPHPLC mass spectrometry, and also we use IVF to calculate the PI value. So just to show it is a pure protein, pure lipase. And also we sequence this complete of this lipase with a conventional method of Edmond degradation using a different protease digestion, trypsin, endoproteinase, glucine, and then formic acid digestion. Finally, we end up with the complete sequence of this phospholipase A2. So this is a regular method. So again, we align that, and finally we are come up with complete 121 amino acid, and we compare with the same one more enzyme we found in the same southern region India, Russell's viper venom, VRAPL8. Why we given VRAPL5 and VRAPL8 is the one we given the phospholipase A2 1, 2, 3 based on PI value of phospholipase A2 across India. Say Russell's viper from east and west and south. So we across the PI value, this is a 5th position and a 8th position. So we given Vipera russellii VRAPL5 and Vipera russellii PL8. These are the two enzymes in southern India, makes them to kill a victim. That's what we are targeting, these enzymes. And the most toxic portion in southern India is phospholipase A2 with having VRAPL5, and we compare these two enzymes, lot of similarity, and there is a lot of substitution also. I will show with the different images. So these peptides are obtained by the digestion with the different proteases and finally aligned to complete sequence. And also why we compare with the other known Viper PLA2 from the different countries, we align those sequences. There are a lot of sequences having similarity in residues. So again, I told you there is a hydrophobicity play an important role in the toxicity of these proteins, especially venom proteins. So hydrostructural analysis, actually molecular modeling and a hydropathic plot. So hydropathic plot an important role, say how much hydrophobicity these enzymes, how much hydrophobicity of these toxin. So we compare with known lipases from the different venom, VRAPL5 and VRAPL8. So again, charge distribution also, lot of charges. Again, hydrophobicity, again, it is calculated by the charge distribution on the surface of the protein. So using all these softwares, we came to know that our VRAPL5 has a similar kind of charge distribution and also the hydrophobicity in the, so we call it as myotoxic phospholipase A2 is more prone for myotoxicity. Actually, it will kill most of our muscles. So hydropathy and charge analysis show the VRAPL has a distinct hydrophobicity, positively charged on their enhance the membrane interaction and toxicity. So wherever there is a hydrophobicity will be there, will enhance the membrane interaction and it will give out the toxicity. So again, these some of the changes in the residues of those different enzymes will be explaining in the next class. So there are few replacement in there, two enzymes. One is leucine, lysine, then glutamine into lysine. So there are few changes, but there is the overlap residues also between these VRAPL5. So there is the aspartate 67 and proline lysine at 70th position, and which is actually substituted by again with the arginine 67, proline, lysine, and proline. So PRPL5 has actually we developed using Cybele software. We don't have a 3D structure, crystal structure, because of these proteins undergo dimers, trimers, and tetramers. So when these kind of properties, we cannot do more of crystallographic data, but we have a data for VREPL8 by the TP Singh Ames Biophysics department, but difficult to do with VREPL5 what we sequence because of their dimer, trimer, tetramer formation. But still, dimer has a lot of toxicity compared to the monomer. I don't know, we are studying that part. So we are producing, we want to make some of the point mutation, make them to clone and make more clones so that we can have a mutants of those lipases to study the structure function. So these are like some of the substitutes, some of the enzymes are different, but overall, if from our southern region India, these lipases have their structural similarity, but there is a lot of changes in their function. So to explain these, I told you there is a dimer formation. There is a lot of substitution in the amino acid dimer structure of VREPL8. There is one more enzyme, VREPL8. So VREPL5 in red and it is in the green. Most of the substitution on the surface, two are seen in the dimer surface. So most of them are like, looks like similar, but there is a changes in the substitution of these residues. But we have predicted some of the the residues on the surface of those proteins will induce important for neurotoxicity. Still, there are a lot of work has to be done to show that the neurotoxicity due to those residues. But definitely there is a evidence that tryptophan lysine play an important role in most of our neurotoxicity. So that's what hydrophobic residues play an important role most of our toxicity. So pharmacologically, these actually what you call use visible toxicity. One is say it lethal at 1 mg per kg body weight, LD50, and it induces indirect hemolysis, and also it has anticoagulant, has myotoxicity, it induces, gives edema at the foot pad, platelet aggregation, and these are like all different toxicity. You can measurable. Some of them are say LD50 gives how say 50% of the animal should die at particular dose. So these are like some of the toxicity we studied. And also platelet aggregation, everybody knows, platelet aggregation inhibitor, platelet aggregation initiator. Platelet aggregation initiator again has toxicity. So if it is aggregate very fast, person also dies. And if it's not aggregated, definitely the person will die. So the venom has, this viper venom has platelet aggregation inhibitor. So that definitely the person will die of loss of blood. So again, to know the function of these lipases of say different residues, because we know the sequence, to know the function of individual amino acid, we modify this histidine 48 using para-bromosyl bromide, and actually the loss of the PLA to phospholipase activity about 85%. So that's essential for catalysis we shown using the modification. Again, we modified lysine using carbamylation reaction, and again we loss of 78% with compared to native. Again, we modified tryptophan oxidation using N-bromosuccinimide. Again, we loss of these lipase activity about 70%. So once these modification, definitely the change in their anchoring property of those. The loss of hydrophobicity of those proteins, definitely the loss of toxicity. That's what we want to observe. See how exactly these modification leading to the loss of toxicity. So this one, again, chemical modification of N-terminal. We remove N-terminal and also we modify N-terminal. Again, we are showing these loss of these enzymatic activity. So that's what to save the function, we need to maintain those function. Again, we modify those and see the function in terms of toxicity and enzymatic activity. Again, we have a different modification of platelet aggregation inhibitor activity, VREPL5. Say when you modify histidine, when you modify tryptophan, N-terminal removal, N-terminal modification, lysine modification, loss of platelet aggregation. Loss of platelet aggregation, you've seen in almost nil with the histidine modification. It means actually you need enzymatic activity to enhance the platelet aggregation. The toxicity actually lies in the structure. The structure gives complete implication with the pharmacology. So this actually with the platelet aggregation, again, edema-inducing activity, again, with a compared to the native protein, histidine modified, tryptophan modified, N-terminal removal, N-terminal modification, lysine modification, has a lot of implication in the structure. Definitely, histidine plays an important role where the complete loss of edema in the foot. So that's what we shown everything in the mouse model and also in vitro models. So most likely we use all the mouse models. Again, we shown that we recently got with the case studies, we using in silico model where we derived a particular myotoxic site in the protein has a lysine, and we modify lysine and we try to see the myotoxicity in the muscle. We shown that definitely there is a modified pyeloid-treated tissue showing a partial alteration in their muscle architecture. That's what we shown that lysine is very targeted where having in the mouse model. So the bridges makes them highly stable molecule in any of these environment. So when you put this in a more hydrophilic in the ethanol, we see in the CD spectroscopy, we shown that ethanol induces partial unfolding and loss of secondary structure in terms of actually alpha helical content reduction in 35% and 20% of the beta sheet random coil. That's what the to function a particular protein in a snake venom, actually it needs a lot of structural importance with respect to the amino acid, with respect to the whole of alpha helix and beta sheet in their phospholipase A2. So this actually lead us into another project we are working on. Actually, it's the more stable because of the 6 disulfide bridges and very strong in their structural integrity with those different residues. Actually, we are looking to develop a diagnostic kit to differentiate these viper and cobra in a southern region because of this stable structure. And also we are developing a a particular drug for ointment for these symptomatic treatment on the surface of the myotoxic bitten peoples. And the another one we are working on how exactly these myotoxicity will having a kind of a mechanism where these cells undergo necroptosis, having apoptosis and necrosis together, having a different pathway. We are started to working on with a different bunch of our PhD students. This is actually leading us different grants. And again, these structural functional insights, unique residue substitution affect dimerization. Once it is the dimer formation of those toxin will be highly toxic compared to the monomeric toxin. Hydrophobic and amphiphilic feature of underpin the membrane interaction with pharmacological effect. That's what hydrophobicity of these lysine, tryptophan, all these play an important role in toxicity and killing a person. A charge distribution correlates with myotoxic and anticoagulant activity. That's what charges again implies the type of amino acid present in the surface of those protein. Chemical modification actually, it will give tremendous evidences that these play an important role in inducing the snake bite toxicity in terms of toxicity of those phospholipase A2. So these are my mentor and also Dr. Satish. He sequenced the complete sequence, but I did all functional assays after his thesis. So our collaborator, Dr. Manjunath Akini, Department of Biological Science, and Satish is in Roche Diagnostic, New Jersey. He is in the team of where the COVID-19, that kit developed, first kit developed. So he is in that team in New Jersey. And I thank Dr. T.P. Singh, Department of Biophysics, AIMS Delhi, and also I thank Savitri, Department of Biochemistry, IASC, and also I thank all my funding agency, DST SERP, now is ARG, ANRF, and now I also thank DST, ICMR, uh, DBT BIRAC, and also JSS Academy of Higher Education Research for generous funding for the initial grants, and also I thank all my PhD students, UGC also, and also the wonderful PhD group we have with a diverse interest. And also I thank Ivan Arana for inviting me for this wonderful arranged conference in Ahmednagar College. I remember we worked together in the zoology department, and I learned many things and also explaining many things no one words also. Thank you very much for all the patience.
Thank you, Dr. Kumar, for this enlightening talk. Your detailed explanation of the biochemical and functional aspects of Russell's viper venom has truly highlighted the importance of such research for medical science.
And today's presentation has given us much to reflect upon. We are grateful to you for sharing your expertise with us, sir. Thank you. We now move to the next invited talk of this. Yes, sir. Yes, sir. Please go ahead.
Hello? Yes, tried it. No, sir. We didn't check. Yeah, there are enzymes in the same, like aspartate 49 also in the that. Yeah, in the strat. Instead modification of aspartate, I modified histidine. Yeah, actually we want to try that. Actually modify not only in 48, modify of the aspartate. But it's a yeah, it is in the same trad. It's close vicinity in that. Yeah. Thank you.
Thank you for the question, sir. Now, we move to the next invited talk of this afternoon session, which takes us into the fascinating interface between biology and industry.
Our speaker is Dr. Raghuvendra Gaikwari, whose expertise lies in industrial biotechnology and the applications of biocatalysis for sustainable production processes.
Dr. Gaikwari will share his insights on the theme biocatalysis and industrial perspective. This talk will provide valuable insight into how catalytic processes derived from biological systems are reshaping modern industry.
To formally introduce the speaker, I now invite Dr. P. Lamrud.
Thank you very much, organizers, for giving me opportunity to introduce our next speaker, who is from the industry sector. Our next speaker is Dr. R.P. Gaikwari, who is a founder, chairman, and managing director of High-Tech Bioscience India Private Limited. He did his PhD from the NCL, his MTech from the IIT Kharagpur. He is a prominent alumni of Ahmednagar College, where he pursued his master's degree in biochemistry. I will read only selected awards and honors because the list is very exhaustive. He received late Dr. Aruna Jogdekar Award for standing first in MSc. He was a rank holder in IIT Kharagpur. He is a member of Scientific Advisory Committee of Department of Biotechnology, Ministry of Science and Technology, Chairman of Indo-American Chamber of Commerce, Honorary Fellow of BRSI, Member of Advisory Committee for Enzymes for DBT, Government of India, Member of Advisory Committee of Biotechnology to Department of Science and Technology, DST, Government of India, Member of Advisory Committee for Enzymes for DST as well as DBT. Of course, the list is very exhaustive, so I have read only few awards and honors. He has 12 publications to his credit, which were published in peer-reviewed reputed journals, and 7 patents in biotechnology, biocatalyst, herbal formulation, etc. So with this brief introduction, I request Gaikwari sir to deliver his talk. Thank you.
Thank you, Dr. Lamrud, for the introduction.
May I now request Dr. M. Furtado to felicitate our speaker, Dr. Gaikwari.
Thank you, sir. With this, we invite Dr. Gaikwari to deliver his lecture.
Can you hear me? So there is a lot of scientific discussion so far. First and foremost, that I would like to really thank you organizers for inviting and giving an opportunity to share some of the thoughts about biocatalysis. Now, biocatalysis is the area which people really don't like actually. The reason behind is that you have to have immense interfacial knowledge, and you should not have any in-depth knowledge about particular subject. Then only you can really work in the field of biocatalysis. Very important thing is that I am really thankful for a reason that I'm the past student over here. I taught here for 2 years, but I think students were not liking my teaching. So I decided to really go to IIT to do my MTech. After completing my MTech, I started my business in the field of process engineering and process development. And after that, I did my PhD in microemulsion, which is more related with the chemical engineering. And then this complete work was continued. And in 2012, actually, I started working in the field of biocatalysis, because practically speaking, biocatalysis per se has not been really looked by or not been paid attention to for a simple reason, because industry cannot really see that it is having any significance as per the profitability is concerned, because the investment into R&D is so high that the industry doesn't really want to do anything out of it. So, but I was having that flair for enzymology, and I thought that I can do some justice to that one. And then I started working in the field of biocatalysis. So we developed various technologies based around biocatalysis. I'm not going to put forth any case over here. One case I will just discuss in briefly so as to talk about the complexity of the biocatalysis. But I want to really present biocatalysis from a different perspective. And this perspective might be quite interest to you, because I really looked at the biocatalysis as if it is an, what you can say, a living system under the stress, and it is evolving. So that is what my theme of a talk. So can I have my presentation? This is not mine. No, no, sir. This variable region is something which is very risky to talk about. I just still remember one case. There was one professor in Garwari College. So he just came in the class and he stood like this. He just came in the class and stood like this, and he asked, "What is this?" So everybody was fumbled, and then he said, this is an antibody. So I just stood up and I said, sir, one mistake. What is that? I said, you should do like this because this is a variable region. Huh? Yeah, thank you. Can you slide? This one? Point. So, in coming back to our topic, basically, there are basic aspect of biocatalysis. One, we call it that as a biotransformation, and second is a biocatalysis. So, when we really talk about biotransformation, it's a chemical modification made by organism on the chemical compound, and usually it is referred to the wholesale biocatalysis. And when we are talking about an biocatalysis, it's a basically enzymatic catalysis to produce chiral, achiral molecules, which can be used as building blocks in synthesis of many specialty molecules or API intermediates, such as drug intermediates, agrochemicals, flavored compounds, and many other compounds like that. So the basis of business model, it's a thought process around a business model. Biocatalysis being a multidisciplinary activity, big group starts exploring with the possibilities. Like for example, DSM, BASF, you take any big company, they will just think whether can I explore this, because of which I can have some advantage in the green chemistry, or can I have some advantage as per the price is concerned, or whether I can really explore something like that one. That is how actually the biocatalysis is being looked by the big companies, but small enterprises venture only through the assurance. So there are many small companies around biocatalysis in Europe, in America, in China, and all these small companies, if they are having a clear proof of concept, then only they will venture into a biocatalysis. They cannot have that much deep pockets to really explore biocatalysis to just check it out whether this reaction is possible or not. And as per India is concerned, our Indian pharma industry or a specialty chemical industry is not risk-taking industry, and that's why we never really venture into a biocatalysis till date. The hypothesis is that in evolution, species should withstand time-specific selection pressure to establish and sustain. And here is the species is biocatalysis. So suppose if I consider a biocatalysis per se, and I want biocatalysis to survive in commercially viable world, it has to thrown into that world, and selection pressure has to be applied. And if that selection pressure, if the biocatalysis can survive through, they will able to really make a business sense out of it. Otherwise, it will not survive, it will not sustain, it will get vanished. So that is the hypothesis which I put it over here. So roadmap was not set, evolution started. So what happened like in 1995, earlier there was no alternative. There were certain reactions, for example, hydroxylation of a steroid. There was no alternative, but you have to just throw your steroid into a fermentation broth by mycelia to ask to really have some sort of a conversion, make a 7-hydroxysteroid or 11-hydroxycandirenone so as to make a iplerenone. So those type of reactions were mandatory because you don't have any option. It was inevitable demon that you have to deal with. 15 days of a fermentation, 10 days of a fermentation with fungal fermentation, that was chaotic. And that is how actually the evolution started, because there is no alternative but I had to follow enzymatic route. I cannot really do a simple hydroxylation by using any classical organic chemistry. I have to rely upon the biocatalytic route. But selection pressure was defined. During that period, if I want to really make any process workable, what is the selection process? The thing is that proof of concept should be there within 4 weeks time. You cannot really wait for a 1 year, because the specialty chemical and API intermediate, if you find out a molecule that I want to really work on that one, and if I spend 2 years, by that time the all economics really vanishes. So first and foremost, that within 2 to 4 weeks time you have to have proof of concept. Selection and modification of enzyme in today's world should not exceed more than 5 to 10 weeks. After that, cloning and expression. Once I have been really designing something like that one, I have to have the better expression of a protein. It should be between the 10 to 12 weeks. Process optimization, 12 to 18 weeks. 18 to 26 weeks means that something like around 6 to 8 months time, if I can really make a molecule by using enzymatic catalysis, that makes sense in a very competitive world. Otherwise, you are not really going to be in the world. Now, second thing is that you can think of having your primary cost of conversion $10, $100 kg dollars per kilogram of end product. That is acceptable, because at a proof of concept level, okay, I just want to really check it out. Down the line, if my conversion cost is something like around $10 or $15, and if I'm dealing with a molecule which is just 2,000 rupees a kilo or 3,000 rupees a kilo, I cannot really have this cost variable. So I have to really reduce my enzyme cost to around $2 per kilogram. So either my turnover number of the enzyme should be very good, so that my enzyme, only my input are low, I can have a better convertibility and I can have a lower cost of my enzyme. So these are the major selection pressure if I want to consider any biocatalysis process is workable or it is not going to be workable. So for example, if you can just think about an asymmetric reduction of carbon-carbon double bond. It is an current Lee-Chatterley's principle if you really look into. That for example, if I just want to have some sort of a reduction, carbon-carbon double bond formation and this double bond has to be reduced, there was only alternative by some sort of an in reductases by using NADH2 or NADPH2. The cost of NADH2, NADPH2 is so high, you cannot really afford to have that cost into a place. So there was another system which was evolved eventually, that I am having an keto reductase or in reductase. Along with that one, I am having an recyclable system like a formate dehydrogenase or a glucose dehydrogenase or phosphate dehydrogenase, which is releasing either CO2 or gluconic acid, phosphoric acid, or great regeneration isopropanol to acetone. So what happens, like inside the cell, the NADH2 is converting a particular molecule and it is reducing the in compound, but the NAD which is getting formed, it is really losing the homeostasis of the cell. It has to be recycled back into the NADH2. So this another enzyme or class of enzyme has to be introduced inside, and now your complete engineering or process engineering has to be evolved around that one. Suppose CO2 is getting generated into the system, I have to adjust the pH because my enzyme is very specific with reference to a pH, or otherwise if there is a gluconic acid, again I have to adjust the pH. So it should be a continuously a pH maintained system has to be created. So the biocatalysis apparently looks like very simple. At a proof of level, it's very simple. 5 millimolar, 10 millimolar, people really talk about that one. But when it comes to 500 millimolar, 1 molar reaction, people are really faltering at that moment. So this is the very important aspect for biocatalysis, and this is the pressure for that matter. Now, what was the selection pressure? That how many times I am really going to use the NADH2 or NADPH2. So people have really come out with something like a Zen A or OA like a compound, which is NADPH2 independent compound. So these compounds are having the same redox potential like NaDH2, so they are able to really reduce my chemical of interest, and there was no need of an recyclability. I had to do some sort of an simple enzymatic oxidative remover or scavenging through the resins. I can really remove the impurity in the downstream processing. So again, coming back to the biocatalysis, here is a selection pressure of using of NADPH2 into the system. Again, that pressure can be withstood by a replacement of the NADPH2 by finding another molecule having the same redox potential like a NADH2. So this evolution phase has been there 1995 to 2005, which was the early evolution phase. 2005 to 2015 is a mid-evolution phase, and 2015 to 2025 is where I can say it's a late evolution phase, where biocatalysis has come into the market and people have started really exploring it. But still, in India, the situation is very bad. So as I had told about the pre-evolution phase, there was no alternative, that chemical synthesis was not possible, only those areas we are using the biocatalysis. Early evolution phase, it was started surviving by employing business models and selection criteria set with reference to cost, timeline and productivity. So there was some sort of an, okay, if it is a high value item, I can think of using an enzyme catalysis, but for low value, high volume items, I am now still considering the biocatalysis per se. In 2005 to 2015, companies started showing adaptability towards a selection. So now what has happened, like, there were many companies started evolving around biocatalysis. Not a single company was very expert in doing biocatalysis. There is some pharma company, they are taking enzyme from somebody, doing some sort of a transformation, selling the product. There were certain companies which are doing this protein engineering per se by using the directed evolution. I think during this period only, the directed evolution concept actually came into a picture. People started playing around with the enzyme structure and something like that one, and then people started using that service as a company, and then people started supplying the enzyme modification as a service, and the company started evolving. What is important in the business, that unless and until there is an ecosystem, the complete business cannot really evolve. In case of India, we are having a fantastic ecosystem for the pharma, because there are intermediate manufacturer, API manufacturer, formulators are there, regulatory agencies are there are capsulating companies are there, formulation companies are there, we are exporting it. In case of biocatalysis, we don't have that type of infrastructure or ecosystem, and that is the biggest problem. And here in 2005 to 15, Germany and China, as well as in Europe, all the big companies have really created this fantastic ecosystem, and that's why we are lagging behind as per the biocatalysis is concerned, and all other 3 continents are accelerating, and they are supplying all the very high value product to us, and we are just simply buying it. That is a scenario that most of the people are knowing it. And now late evolution phase, that it's a rigid selection pressure, that the selection pressure which I mentioned about, that $2 a kilogram, that is what my cost of enzyme conversion, then only it is going to be economically feasible. Otherwise, it is not going to be economically feasible. So that is very important aspect now which has been emerged out. So these points actually I just explained to you. So there are many companies which really come out. I will just skip these slides. So in mid, these are the things which I talked about, and if you really look into the products and technology which have been really come out of this one, these are the keto reductases which people are really talked about, and these are the all specific molecules which has been really getting produced. For example, hydrolases, if you really look into pregabalin silica, all other very important molecules which has been at least one step is been done by the biocatalysis, and at present in India, nobody manufacturing these are the key steps. All these key steps have been really imported from outside, and we are solely dependent either on China or in Europe so as to get this material from that matter. For example, sitagliptin is the very novel technology which was developed. Making keto to amine is very difficult for the organic chemist for a simple reason, because it requires nearly about 3 steps to really make keto to amine. Transaminase can really do within one step, that this is a transamination. So amine has been really getting transferred over there. So sitagliptin has become a big blockbuster molecule, and Merck has developed this directed evolution for that matter, and they have developed these molecules. So these are the very important molecules which are really having a nearly about 30% of our API business as of now. At least one step or two steps are getting synthesized by biocatalysis, and in India we are not making any one of that. So that is the problem. Why the problem is? Because if you really look into this complexity of this biocatalysis, that if I want to really use spores or wholesales or purified enzyme or immobilized enzyme for the biocatalysis, I have to have the fantastic strain improvement capacity. For example, I'll just give an example of biocatalysis of phytosterol to pregnenolone. I was in two minds whether should I really present that case which I developed in our laboratory of phytosterol to pregnenolone, or to discuss this generalized idea. So ultimately I thought that it would have been very scientific, so I skipped that idea and I switched out to this presentation. So what happens usually in phytosterol, there is a side chain, and then there is a generation of keto group at the C21 position. Now that is possible by chemical route, but it takes nearly about 5 to 6 steps. If you take any other bacterial system so as to really convert that one, the problem happens that the long chain has been seen, long chain acid has been seen as a probable component for beta oxidation. And the moment you start a beta oxidation, you end up with the AD and ADD, which is the starting material, and from there you have to go for again pregnenolone. So that is again a risky material. So what we did actually, we tried to find it out like how cholesterol has been getting converted into pregnenolone in the human system. So then we identified an enzyme which is converting cholesterol to a pregnenolone, and based on that one we identified which are the similar sequences present in bacterial system, and one of the system which we got it, we cloned into E. coli. When we cloned into E. coli, problem was that the molecule which we are supposed to convert into that one, that is such a huge molecule that it cannot go inside the cell. And suppose if it cannot really go inside the cell, the biggest problem is that the membrane integrity of the E. coli. So we got a modification into E. coli membrane proteins, because of which the phytosterol was able to enter inside the cell, and there was a conversion, and then pregnenolone was coming out of that one. So this was very complex system, and the worst part of that one, actually the cytochrome P450 requires something which is known as FDR, FDX, pyridoxine reductase, and then one hydride from NADH2 is getting transferred to a cysteine of cytochrome P450, which been transferred to Fe2 and then Fe3, and presence of oxygen transiently you can see or postulate that Fe in the IV state, which is theoretically impossible, but unless until you postulate that ion is in the 4 state, you cannot think of that reaction mechanism, and then hydroxylation of that specific site happens. And when the hydroxylation of a C22 position happens, at that time, because of the bulky nature of two hydroxyl group together, there is a automatic lysis or degradation of that side chain, and you get a pregnenolone. Now, if you want to really do all these things, you have to have the strain improvement capacity, you have to have protein bioinformatics capacity, you have to have something like a biocatalysis of chemical synthesis knowledge also. So if you really bring it out and evolve a host which can do a transformation, after doing so much of an extensive work for 2 years, ultimately we realize that the transformation is only for 5 gram per liter, and economics was fitting for a 20 gram per liter. So we ultimately did a mycobacterium engineering, what you can say metabolic engineering, and cleaved some pathways, and that mycobacterium was able to really do a 20 gram per liter conversion to pregnenolone. So basically all those efforts, irrespective of taken over there, the complete experiments or those things were wasted. So this is how actually the biocatalysis is so expensive, and true companies who are only into a profit making, they will not pay much attention to biocatalysis because they want to survive, and the fools like us who spend our time and money into developing biocatalysis, because at least we will be contributing something to India. That's why actually we are working in the biocatalysis, and recently we developed around 5 technologies based on biocatalysis, and we are putting up a big plant for that matter. But this is how actually this all microenvironment is mandatory if you want to really evolve that type of technologies over here. So effect of selection pressure is not only this, but right now the selection pressure and why India should really look into, because the China and Europe underwent excess selection pressure of biocatalysis, and now they are literally supplying all the molecules which has been produced by using enzyme catalysis. With this current knowledge, India can catch up with leading countries almost instantly, provided if we are having a very good networking program together, then only it is possible. Otherwise, that is practically impossible. If we really start working in silos, the success is look to be a very remote one. China, Europe are leading countries in biomanufacturing. The primary reason is that they have ecosystem which supports biocatalysis, which is not in India. Chinese leaders include Hansgao Chemicals, Bota Sciences, Sinochem, Syngenta, and many more. So there are many companies, they are making these API intermediates, and they are leading at this moment. 47% of the key intermediates have been imported in India, though we are the leading pharma business, so-called leading pharma business, because there is no R&D in pharma. That is the tragic part of it. So bottlenecks, the challenge of biocatalysis, generalizing enzyme a specific purpose when they are needed. End user expects catalyst as shelf, but keeping the libraries for only one step is not economical. So companies cannot really survive, small companies cannot really survive. Approach in concentrating only one class of enzyme, that increases risk of keeping all eggs in one basket. But again, having an insight for 3-4 class of enzyme, that is also very difficult, because somebody is working in nitrylase and start working on CRADE. The mentality is altogether different. One is making a tetramer in case of nitrylase, and second is a only single polypeptide. The protein chemistry is altogether different, and then you have to have a really innate knowledge of the protein understanding for that matter. Then acceptability in generics is very less, because there are some issues about DMF and those type of things. So people are not very open for that matter. India is importing specialty chemicals from its threats and not political allies. That is the biggest problem. We are importing most of the thing from China, and we are really sitting on a bomb, because we cannot really rely upon China. That is very important aspect we have to look into. So every business also follows and obeys the rule of evolution. Selection pressures and adaptability makes the business stable and sustainable. New selection pressure is export deficit. We are having an export deficit. Everybody is now bullying us. Now it's very important. At least we will become self-sufficient. And now here, all the departments are nearby in Nagar College. I think one small step, even if you can start working with some lipases, bought out lipases and making some sort of an chemicals and some sort of an processes, that is really going to give some small company to start in the same area. And for that matter, any help is needed, I will be always there. But this is something which is very important. We have to take this very seriously. The onus is only on us, on nobody else. So this is what 40% of specialty molecules will be synthesized by using enzyme. That is the fact. As of now, there is acrylamide, 500 metric tons in China is been getting produced by nitrile hydratase. So this is something we have to consider, and it's a simple single step reaction. Very important aspect when you are looking at an enzyme. This is an insight I got it after contemplating on enzyme for many years. Particular enzyme in particular cell is not most optimized, for a simple reason, because the enzyme or the overall cell has to really think about an homeostasis. If particular enzyme is highly evolved, it might take glucose very efficiently. So glucose is not available for PPP pathway. It will be only available for the glycolysis. It is not accepted. So basically every enzyme has got a potential to get evolved into something else. That is part number one. Second thing is that all enzymes have been really created in the cytoplasm. They have not been created so as to really work in the organic phase. So very important aspect while working on an enzyme catalysis, you have to think about a microemulsion. So that is something which is very important, that you create some sort of an water environment around the enzyme, even if you are using in the solvent phase, in the continuous solvent phase, and then only your enzyme will be active so as to convert molecule A into B. So these are the very important small aspect of enzymology one should not really ignore while doing an enzyme catalysis. So this is what the situation, 35,249 crore rupees of the API is getting imported. 1,18,700 crore rupees specialty chemical is being getting imported. This is what the scenario is. So market is reasonably okay, but there is a lot of risk of doing a lot of R&D before really making single molecule out of it. And there is a good scenario for the biocatalysis as per Europe and China is concerned. We are nowhere, unfortunately. So I'll just skip. These are some of the points because the time is very less. Area where we are lagging is do not have ecosystem, skilled workforce unavailability, because it's a multidisciplinary act. It is not something that only one biochemistry guy can really do a biocatalysis. He has to have a good understanding of organic chemistry. So a group of different people should work together. No infrastructure as well as skill set for evolution of enzyme. Hardly any scientist in India is working on directed evolution. That is the very important thing, and that is the fastest way so as to make your enzyme work for your substrate. And then alignment of the bioinformatics and enzyme engineering. Now this is something which is very important. AlphaFold 3 has really come into a picture. The predictability for what you can say alkali metals for that protein structure is comparatively good. For divalent metals, the enzyme predictability is not good, but you can really work around that one and can understand the protein structure very properly. Indigenous efficient host and expression system, we have to still pay good amount of royalty if we are using BL21DE3, BL21DE3 star. People are blindly using BL21DE3 star for expressing protein, but the moment your size increases, Thermo Fisher will come after you and they will say that you have to pay me $10,000 because you are using my expression system. So see to it how you can circumvent that BL21DE3, how you can really generate your own efficient host system. That is also very important. And regulatory framework is very sluggish, as everybody knows. So everybody has to really work around that one. And if you really look into this one, all these leading molecules, one step is from biocatalysis. So this is how actually one important thing, the link is always academia. Now this is something what we are missing. There is one very great philosopher, management philosopher, Peter Drucker, used to say that the future lies in universities. And now we have to really make our universities much more stronger. Rather than asking university professors to start their startup companies, it's better that the scientists should really do their job of doing a good science and make it available for the people who are professional. A commercial guy cannot really do a good science, and good science guy cannot really do a good business. A rare case can be there, but otherwise he can spoil both the things. That is the problem, and that everybody has to really understand that. So this is something which is very important. And you look at this, all these important molecules, University for Research is Cato, NEU, Verid, Michigan, CITUS, sir has mentioned about that one, Wisconsin Medicine. So these are all novel technologies which has really come out. It has come out from the universities. It has never come from the industry. So this one very important aspect we have to look into. So way forward is increase R&D spending, scaling up outbound merger and acquisition. Government pushes mandatory, focus on sustainability. That is also very important. So small volume molecules can be really looked into. We have to really think of around $1 per kg of the conversion cost. Then that really makes sense. Small fermentation units coupled with higher cell density fermentation, that is also very important. And basic criteria, it will match for you. Around 100 gram, 100 milligram per liter of the protein, around 3,000, 4,000 unit of the activity. And if you are getting 100 gram of a biomass, I think you can come out with reasonably okay size of catalyst which can be used for a biocatalysis. So potential is future lies with the university in the innovation. Market needs are known to be the industry. So industry academia collaboration is mandatory if you want to really accelerate in this field. So path ahead is like this. So nutshell, it is on the evolutionary growth curve. We have to catch up that growth curve. Single technology domain knowledge with application can end up in starting a company. For example, if somebody is very expert in immobilization, or one laboratory can evolve immobilization per se, I think they can do really wonders, because making an enzyme immobilization itself can be a very good business model. There is one company started by one professor that was a CLIA, that model, aggregate of the enzyme together for the biocatalysis, and that company survived, and their job was just you bring your enzyme, I will immobilize and give it back to you. So this type of companies can be really evolved, rather than just thinking that I will do end to end. It is not possible for any small and medium sized enterprise. Better concentrate only the area where you are expert in and build a company around that one. So that is very important. Opportunity for universities to create incubation centers and developing end-to-end technology for a single product, that is also quite possible. So these are the gist. High risk method development in protein engineering are welcome. Rate of academicians turning into technopreneur is high and going to be very high. So this aspect is also very important. So even if somebody can think of making one technology or some great knowledge base, and a student or his PhD student can start a company, that is a regular model in Europe. I think that model can be really worked out in India. So in our college also, if needed, we can really develop some sort of a small model around that one, and we can experiment. So ultimately we have to do experiment. We are all scientists, so there is no alternative but to do an experiment. We cannot really go on generative AI to really give some sort of a result for us, that is for sure. So high opportunity for creating posts for postdocs by undertaking product or method specific project. This will create a manpower for next decade of biocatalysis from 25 to 35. At present, we don't have a manpower. That is the biggest problem. When a student join me or a fresh MSc or a 2-year experience MSc, I have to teach him all the basics which is required for my business. He can be very good in his own subject, that is fine. But for biocatalysis, I am not getting any ready-made manpower. But suppose if we can start now by developing postdocs around this area, by 2035, what is important? India has to survive. Whether my company or Vishnu's company or anybody's company goes to 100 crore, 200 crore, 1000 crore rupees, that is fine. But ultimately, we are making our own product in our own country. That is a need of an hour, and we have to really pay attention to that one. There is no alternative. Or we will miss the we'll miss this by paying great price. There is no alternative, but if we just be dependent on China, we are lost, I think. Thank you very much. If you have got any question,
We have one question.
Thank you for very much interesting insights about the biocatalysis per se. Just to have some comments before I ask my question. We have been using biocatalysis in industry at tonnage scale in India. So, lot of
there are
slides said-
certain lipase-like reactions.
No.
I am talking about a specialty chemicals.
We are talking about molecules that are having 4 stages, and 3 stages are made by enzymes, and we have 10 or more than that molecules that we make it by biocatalysis. We had a collaboration with Codexis.
Yeah, so Codexis. That is what I want
Yeah.
to say. My point is that we
Now
are
we are-
buying enzyme from outside and we are making molecules here. That is not a problem. My problem is that we are not independently generating, creating our own enzyme bank. That is the biggest problem. And tomorrow Codexis says that, okay, or it has been taken over by any other company. Codexis says that, okay, we don't want to supply it. We are at standstill. My point is altogether different. Codexis is supplying. You go to the Codexis, there are many companies in Britain. They are supplying the enzyme for that matter, and we are just using enzyme and converting. My point is somewhat different. We are not independent as per our own enzymes are concerned.
Yeah, that
We
is
don't
there.
have our own host system. We don't have our own expression system available with us. That is the problem.
Exactly, yeah. I just wanted to ask you further questions about the enzymes. So you gave a lot of examples of different. Do you have any enzymes for hydroxylation on saturated carbon?
Hydroxylation, yes, there are 2 types of enzymes. What is the price at what you are really looking at? So what is the conversion price? That problem statement has to be written. If you are using cytochrome P450s for hydroxylation, it might not be that economical. But suppose if you are really looking at comparatively lower prices, then there are certain unspecified peroxygenases on which you can really think of converting direct hydroxylation by using H2O2. You don't require NADH2 or NADPH2 for that matter. So important thing is that how specific you are about hydroxylation. That is what we would like to really know, and if it is the problem statement can be given, we can really resolve that point. That is part number one. Second thing, with unspecified peroxygenases, they are having a tendency to really hydroxylate at 2-3 position, and that's why it is not specific. But if the product is very high value, for example, pregnenolone, that is what we developed it. It was a very site-specific hydroxylation at C22 position, and then there was a cleavage, and then we are able to generate the pregnenolone from that matter. So that product is around $280 a kilo. So there you can think of using cytochrome P450. But if you are talking about $20 a kilo molecule, cytochrome P450 cannot be used.
Cytochrome P450 would be hydrolyzing mostly the aromatics or
no,
from the aliphatic.
hydroxylating. You want an hydroxylating molecule.
Yeah, but P450 is known for hydroxylating.
No, that is a mechanism is something different. In liver what happens, you take any molecule, hydroxylation happens because of cytochrome P450. Breaking carbon-carbon bond is very difficult. But once you hydroxylate that, then breaking that carbon-carbon bond, opening of the closed ring is comparatively much easier. And that's why our body has evolved cytochrome P450s so as to hydroxylate those very tough molecules. And after hydroxylation, and then ring opening is comparatively easier.
Yeah, I am asking about if that is also hydroxylating the aliphatic chain.
Yeah, that is only for the aliphatic. Cytochrome P450s are very good in hydroxylating the aliphatic.
And there are enzymes for CC bonding,
Huh?
CC bond creation.
There are certain examples, but people are not very successful in CC bonding.
I know about the aldolases, but
aldolases people have talked about. Lacases people have used as a promiscuous reaction for CC bond formation, but there are not many cases for the CC bond formation. Anybody comes out with CC bond formation is going on $1 million or $1 billion business, practically speaking.
Thank you, sir.
Thank you for the question, sir.
Thank you, sir, for your insightful lecture.
The industrial applications of biocatalysis you highlighted demonstrate the powerful ways in which life science research translates into innovation and practical solutions.
Your talk has indeed offered valuable insights and stimulated important discussions for all of us present here. On behalf of everyone here, we extend our sincere thanks for your contribution, sir. We now proceed to the next presentation of this session, which brings us into the specialized domain of protein purification and recombinant therapeutics.
Our speaker is Dr. Rahul Bhambure, Senior Scientist at the National Chemical Laboratory, Pune. His research focuses on downstream processing and protein refolding strategies with particular emphasis on therapeutic proteins.
Dr. Bhambure will be speaking on the theme Chromatography Assisted In Vitro Refolding and Purification of Recombinant Peptide Bodies, Recombinant Romiplastin, a case study.
To formally introduce the speaker, I now invite Dr. Rahul Gaikwad.
Thank you. It gives me immense pleasure to introduce Dr. Rahul Bhambure. Dr. Rahul Bhambure is a senior chemical principal scientist, chemical engineering and process development division at CSIR NCL Pune. He earned his postgraduate degree from the Institute of Chemical Technique, Mumbai, and PhD in chemical engineering from Indian Institute of Technology, Delhi, and his postdoctoral research in the United States of America at the University of Delaware in biochemical engineering techniques. He is renowned for expertise in chromatography, protein purification, process development, process optimization, nanomaterial synthesis. His active research is in vitro refolding of recombinant protein, mechanistic modeling of chromatography, and division of biosimilars and related biotheoretics. With this brief introduction, I request Dr. Rahul Bhambure to deliver his lecture. Thank you.
Thank you, Dr. Gaikwad, for this introduction.
May I now request Honorable Principal in Charge, Dr. Noel Parke, to felicitate our speaker, Dr. Bhambure.
Thank you, sir. With this, we invite Dr. Bhambure to deliver his lecture.
So very good evening to all of you. Thank you for the kind invite to speak at this particular conference. I'm very thankful to various people, Dr. Manohar, Dr. Matthew, who suggested me to come for this conference, and obviously Dr. Ivan for this kind invite, as well as the principal of the college. So I'm Dr. Rahul. I work as a principal scientist at National Chemical Laboratory, majorly focused on process development for various kind of recombinant protein therapeutic. So today I'll be majorly talking about one of this therapeutic protein, which falls under the category of an antibody and a peptide, which is called as an peptibody. And I'll be talking about one of the investigation. What we have done is like a chromatography assisted in vitro refolding of this peptibody when they are expressed in inclusion bodies. I'm very thankful to Dr. Gayakevari for setting up the stage for like why inclusion bodies are not active form of the protein. And in order to get that into an active form, a unit operation which is conventionally used is a refolding. And majorly all of the industries, in order to increase the process throughput, they are in the process of trying to convert this batch to continuous manufacturing. And that's where this particular case originated from a commercial need of like converting this low throughput batch refolding processes into an continuous manufacturing processes for the refolding. So what we do at NCL, so I'll just give you a brief introduction like what we do at NCL in Biochemical Engineering Department. So we majorly do joint process development projects with the industries to provide them with the de-risk intellectual property based processes. As my earlier speaker also told about like why we don't have a non-infringing processes, and whether this sort of a non-infringing processes especially can help industries to overcome any kind of patent issues, especially in terms of host cells, clones, promoter systems, or even in case of processing conditions like an upstream and downstream. So that's where our role as an academician or as an interface between academia and industry comes in, and we try to develop this PD processes with a sort of an IP over various components. So we majorly provide FTO-based solution, freedom to operate-based solutions, majorly for the clone upstream as well as the downstream process development for various categories of recombinant proteins. Majorly that involves biosimilars, but that also involves various type of recombinant enzymes, and nowadays some sort of food recombinant proteins which are originating from a need of like a short supply of these food proteins from various plant sources. We do a lot of collaborative projects for structural and functional characterization of a complex recombinant protein, and as an academician I do some sort of applied skill developments for postgraduates as well as for the industrial resources. So majorly three categories of the clients approaches NCLs, which are like biosimilar and recombinant peptide manufacturing, where the current scale of manufacturing in India is not more than 6 scale of an bioreactor. Most of them are currently in a disposable fashion versus old generation SS technology for making of these reactors. The second ones are the biocatalysts for the API synthesis, which mainly scale of manufacturing is up to 10 kL for most of this recombinant enzyme. Especially they come for the initial selective conversions of some of this recombinant or some of these API intermediates. And the last category is the fermentation origin APIs as well as the small molecules which originates from fermentation like nutraceuticals, where the scale of manufacturing is always more than 10 kL, and there are some sort of IP issues as well as the Chinese threat. So why industry approaches NCL is majorly because of an innovator IP challenges, existing innovator, and then de-risk this processes in terms of an IP, scale of manufacturing issues, as our scale of manufacturing are very small as compared to, or intermediate level as compared to other competitors like a Chinese or the European counterparts. Then reducing the cost of goods manufacturing when we are making this sort of recombinant proteins, and improving the profit margin. That's the reason why most of the industry approaches at CSR NCL. So we work in collaboration with multiples of the industries which are engaged into recombinant protein manufacturing. Now an application of an recombinant protein majorly, as I told, is in a biosimilar domain, but there are multiples of the companies which approach CSR NCL for making of these recombinant enzymes, especially when it goes to API manufacturing. So we try to balance both fundamental and applied research. Applied is always focused on some sort of a technology development, either for of these recombinant proteins, but then on fundamental side, we try to solve this at a key fundamental problems, especially in case of, let's say, refolding, like conversion of a batch to continuous processes, development of this novel clones, even the host cell, that's what is currently under plan. And we have some of our IP protected plasmid systems with a variable sort of and promoter systems in place to offer the IP free plasmid systems for this recombinant protein expression. So in order to do that, we need a state-of-art facility. So we have a fermenter up to the 10-liter scale capacity, including a micro-scale fermentation systems where we can do 96 fermentations at a time. Then downstream processings, all chromatography and membrane-based systems, and then analytical characterization for primary to quaternary characterization of the protein structure, and finally the formulation stages. So some of our case studies, like one of this is like a ranibizumab, which is given in the treatment of an Lucentis, now for which we have 4 granted US patents currently in the stage of an preclinical investigation. And then the second, so these are all fundamental investigation parts of this, which are which are published in biochemical engineering journals. So how to do the fast track refolding of this antibody fragment molecule. So another case study, classical conversion of a batch to continuous manufacturing process, especially for biosimilar monoclonal antibody, which was given in a treatment of an bone cancer. So this was in collaboration with Lupin, where we were able to increase the productivity from 7.3 grams per liter per hour to somewhere around 24 grams per liter per hour. And with current 1 US patent under the final examination for this particular process platform in collaboration with Lupin. The third one is like a sort of societal kind of an activity. So we have designed this process for manufacturing of anti-venoms, anti-snake, as well as anti-scorpion venoms. And this current process, which was developed at NCL at a scale of 10 liter of an blood, is currently at a pilot scale at Hafkin Institute. We are processing there at a pilot scale close to around 100 liter of a blood per day to make this anti-scorpion as well as anti-snake venoms. Other products include like anti-diphtheria, anti-tetanus, anti-gas gangrene, sort of a seras. So now our vision majorly for 27 is focused on like making of biosimilar MABs and ADCs, enzymes for APIs. So our efforts are currently focused on setting up a pilot scale facility of a 50 liter scale, where at the end of which we can able to provide the basic engineering package to the various industries, and they can understand what is the cost component for making of this per gram of the material of this recombinant proteins or any sort of an API which is getting manufactured through the developed process. So we are always interested in collaborating. And now moving on to a sort of a topic for today. So I'll be talking majorly on chromatography assisted in vitro refolding and purification of this peptibody called as an romiplastim. So this is given in the treatment of, so there are indications now for like a platelet reductions, especially in case of an dengue, where we are evaluating this particular molecule. Original indication is thrombocytic purpura, but now we are evaluating it for like increasing the platelets in case of an dengue. That's what is the indication what we are targeting this particular molecule towards. Now what is peptibody and what are the fusion proteins are? So all of you might be aware of an antibody structure. So now you have an FAB portion and FC portion. Now in case of an peptibody kind of an therapeutics, which are currently 6 numbers currently available by, approved by the global regulatory authorities, where this Fab portion of an antibody is totally replaced with an peptide portion. This peptide portion has an selectivity. You can tune up the peptide portion as an what you need based on to the antigens of an interest, and then you can attach those peptide and replace this Fab portion. So this converts this molecule from an antibody into a peptibody. Now you have an FC portion, which gives you a higher molecular mass. If you have peptides, the limiting factor for the peptides is majorly a very limited T-half or the circulation half-life. That's the reason why you have a higher dosages, and this can, all disadvantages can be overcome by attaching this FC portion to that of an targeted peptide. So this romiplastim was selected as a model protein for development of this continuous refolding platform in collaboration with one of this industry. So as I said it, like why recombinant peptibody and why not antibody? So antibodies are really larger in the nature. So antibodies molecular mass are close to around 1,50,000 Daltons, whereas these peptibodies are close to around 59 kDa. So we have only Fc portion, and now that is attached to that of an Fc portion is attached to that of an peptide, offering us a more flexibility and number of the advantages by which we can make this peptibody. The classic advantage is like we can use a host cell system as an E. coli instead of using a CHO or HEK293 cell line, where your life cycle for this kind of cell lines is close to around 15 days. In this case, E. coli is close to around not even exceeding more than 24 hours. And we can express this in really large quantities, in a gram quantities, like somewhere around 15 to 18 grams a liter of this inclusion bodies of this particular peptibody, and that's one of the biggest advantage of like instead of an antibody, why a sort of an peptibody. Now, so as I said it, like I have taken this romiplastim or a biosimilar romiplastim as a case study for developing this continuous manufacturing or continuous refolding platform. So this is used in the treatment of this thrombocytopenia, but now there is an indication whether we can be using it for increasing this platelet count in case of an heavily affected dengue patient. So the key problem is there are total 6 disulfide bonds. There are 2 intra-disulfide bonds in the chain, and then there are also the interchain disulfides. So it is very tough to form these interchain disulfides, especially in case of an antibody fragment or in case of this peptibody fragment molecule. Now the classic method by which we do this a sort of the refolding is by just diluting these IBs after solubilization into a refolding buffer, but that does not offer us more than a 40% of a functional protein, and at the same time this is close to around 52 hours to 60 hours of a process. That's the reason why we need an efficient continuous manufacturing process for making of this molecule. So original injection is from N-plate for this particular molecule. So we are making a biosimilar version, so close to around $1,000 for per injection. And so now the patent is off for this particular molecule, and one company in India is making this as an INTAS. So on technology side, what we have is a clone upstream as well as DSP process for making of this biosimilar romiplastim, high throughput refolding process, which is offering us more than 60% of this particular molecule which is refolded. Novel process, continuous manufacturing using refolding, and at the same time offering a purification, and then overcomes the requirement of an affinity chromatography followed by the cation exchangers. So that where the process advantage, what we are offering with our novel process. Now, as earlier introduced in the session as well, so we start with a sort of an codon optimization, and then we do the vector construction, and then it was majorly for the gene which is carrying romiplastim, then transformation into E. coli BL21DE3s, then high cell density fermentation. Another variant which is available of patent is a K12 sort of a variant where we can have this IB as well into the K12, then leading to formation of an inclusion bodies of an romiplastim, then solubilization and refolded romiplastim. The left-hand side shows a sort of an 30 kDa monomer, which is getting expressed while I make this in a fermentation of an E. coli. And below a graph shows post-refolding. So this monomers, 29 kilodaltons, they combine together, and that leads to formation of an 58 kilodalton molecule. So that is what is currently happening under the refolding process. So that leads to formation of an 6 interchain disulfides, 6 disulfides, 2 interchain and rest of them intrachain disulfides. And then we have this purification protocols, which majorly involves ultrafiltration and DF, then protein chromatography, then cation exchangers, again UFDF, leading to formation of an purified romiplastim, which is matching to that of an original N-plate molecules. So that's what we have shown it through multiples of different methods, like using intact mass analysis, close to around 59 kDa daltons, and then Malditov spectra, then other C3 test, which analytical or the regulatory agencies of an India or abroad, they request for the comparison to the innovator molecules. This was a peptide fingerprinting data, which was generated using HR-HDMS, which shows 100% sequence match, including an MS2 and MS3 confirmations of various categories of the peptides which are formed for this molecule post-expression. Now, this was the investigation where we tried to convert this batch to continuous mode refolding process, which was published in International Journal of Biological Macromolecules, as well as one patent currently under examination. So why to convert this into continuous refolding? As you know, dilution leads to real increase into the process volumes. For example, in case if you want to refold the molecule, you need to at least dilute them 10-fold when we are doing the dilution assisted refolding. where we reduce the cavotrop concentration to the certain level where the protein can able to form an functional, flexible structure. But then unfortunately, because of this higher buffer volumes, it is very difficult to process them in an actual manufacturing setup. So now this is required to convert this low throughput batch manufacturing refolding process into continuous manufacturing process. That's the reason why we have designed this chromatography assisted complete continuous in vitro refolding process. So how this functions? So we have like two of the streams. One is like a solubilized IB on this first side, where we are getting this IBs. Once we lyse this E. coli, we get this IBs, inclusion bodies, then wash these IBs, solubilize them using a cavotropic reagent. Then we have a refolding buffer solution, which is into another tank. And then we have a plug flow reactor where we are doing an inline dilutions into this PFR, which is close to around 1:10 to 1:20. And we adjust the residence time at variable times, like including somewhere around 10 hours as a maximum, in order to check like how does the protein is getting refolded at the end of this particular PFR. Sometimes we also purge oxygen inside this in order to assess this oxidative refolding of this disulfide bond formation. Then this input was loaded onto a protein chromatography. As I have shown you the structure of this peptibody that contains an FC fraction, which is connected, FC portion, which is connected to that of an peptide. So protein A has this affinity towards this FC portion of an antibody. So I can directly capture my refolded protein onto this protein A column at an higher pH, and then we are eluting out it using a lower pH buffer, somewhere around pH 4 to 5, where I can get my purified more than 95% of an refolded romiplastim into my final elution output. So this was the overall process platform what we developed at NCL. Now this is an actual chromatogram, or when we are doing this continuous refolding. So our refolding buffer also contains some of this ingredients to inhibit the aggregation, such as an arginine, and the oxidative refolding was assisted with the help of an cysteine. The elution was performed in like 100 millimolar of an glycine SCL buffer, where we collect the completely pure fractions of this romiplastim, obviously purity more than 93%, and then we need a cation extended chromatography in a second step, which takes it from 93 to somewhere around 99.7% of an pure molecule. The chromatogram's blue last curve, it shows the eluted romiplastim into this particular case study. So we use conventionally all the empirical optimization methods, such as fold dilutions. We study the effect of various process parameters, such as fold dilution, temperature, cysteine concentration, DTT concentration for the solubilization, then residence time, and then calculate the refolding yield. So we were able to optimize this to close to around 57% of this protein getting refolded into a functional form, which generally never happens because your batch refolding processes, general efficiencies are between 40 to 60%. So we were able to get simultaneous refolding as well as the purification within a single step at a temperature of fold dilution of 25, and then somewhere around temperature of 15 degrees Celsius without presence of any aggregates. So moving on to conclusions, so we designed this continuous refolding and simultaneous capture purification step, majorly debottlenecking all the refolding process unit operations for making of this peptibody therapeutic. Continuous refolding can be easily scaled up to an actual manufacturing scale for the large production demands for this molecule. And refolding at higher protein concentration also eliminates the need of this concentration and DF step, which is conventionally required in an actual manufacturing of this protein therapeutics. So if you look at this time saving, we are doing this refolding in somewhere around less than 15 hours, and a unit operation is only a single step unit operation. And we were able to recover more than 52% of an protein in a functional form. The rest of an unfolded protein can be again recirculated back and can be further converted into a functional molecule based on to the need as the process desires. So that's all for this particular investigation. Thank you. And I appreciate your patience because my talk was the last one. And thank you for being here. Thanks. Thank you.
Thank you, Dr. Bambure, for this comprehensive and engaging presentation. Your discussion on the use of chromatography in protein refolding and purification has provided us with an excellent overview of applied research in therapeutic biotechnology.
Your lecture has truly enriched our perspectives and offered meaningful reflections for both scholars and practitioners alike. We sincerely thank you for sharing your expertise with us.
Sure. Thank you.
Thank you.
Sure.
antibody which has been getting generated, you are having an inclusion bodies of that one, and then you are using it.
Yes, correct.
So you are doing a lysis of the E. coli, and then you
Yes.
are getting it out.
Correct.
So is there any chance of getting contaminated with the endotoxins
Yes.
because of use of E. coli?
Yes, correct. So there are always chances of an endotoxin contamination. So when we design the process, so there are orthogonal chromatographic purification steps. So this would be followed by a single step anion exchanger or a filter for removal of an endotoxin in the final DS. So these are quaternary ammonium charged filters which comes so that you can just integrate in a process which can get rid of an
So you are
endotoxin.
integrated over here.
So last step of the process, while we make the DS, that would be filtered through quaternary ammonium
quaternary.
filters. Yes. Sure.
Thank you for the question, sir.
We now begin the industrial session of Acridil's 2025. This part of the program has been designed to bring together perspectives from academia and industry, highlighting how research and innovation connect with real-world applications.
In this session, each speaker will have 20 minutes to share their insights.
Our first distinguished speaker is Dr. C.K. John, who will be delivering a talk on biotechnological innovation for sustainable saffron production through high-density greenhouse cultivation.
May I now invite Mr. Prashant Katke to kindly introduce the speaker.
Hello everyone. It is my privilege to introduce Dr. C.K. Johnson, as accomplished scientist in the field of plant biotechnology. Dr. John obtained his PhD in botany from Savitribai Phule Pune University with a specialization in cytogenetics and plant tissue culture. He later served as a principal scientist at NCL Pune, where he conducted extensive research on the application of biotechnology for crop improvement and conservation. His notable contributions include the in vitro production of saffron, development and micropropagation and mycorrhizome techniques in turmeric, and biotechnological interventions for banana, bamboo, teak, and other medicinal plants. His work has provided valuable insights into both fundamental aspects of plant biotechnology and its practical applications in agriculture. Dr. John has published extensively in peer-reviewed journal, authored a book titled Tissue Culture of Economic Plants. He holds a European patent for saffron production technology. His research stands as an important contribution to advancing sustainable agriculture through plant biotechnology. So please join me in welcoming Dr. C.K. John, sir. Please. Yeah. Thank you.
Thank you, sir. May I now request Dr. M. Furtado to felicitate our esteemed speaker.
Thank you, sir. With this, we invite Dr. C.K. John to deliver his lecture.
So I would like to thank the organizers, Principal Pagi and Aranha and other organizers for inviting me to talk about my research on sustainable agriculture production, sustainable saffron production through high density greenhouse cultivation. So this is something which I have technology which I have developed while I was working in NCL for the saffron. The next slide. Yeah. So the saffron caucus is a saffron of commerce is The saffron commerce is the dry stigmas of a plant. The Quercus sativus, and this is one of the most costly spice in the world. And in wholesale, it is about 2.5 to 5 lakhs per kg in the wholesale, and about 300 to 750 grams per gram in retail. And it has three main uses. The most important use is a spice, and it is also used as a medicine. And now recently there is an increasing demand for medicinal use, and also it is used as a coloring agent for fabric. And the high price is because of three reasons. Saffron is grown only in a small area, geographical area. In India, it is Jammu and Kashmir, Pambur in Kashmir, and Kishtwar in Jammu region. And also the produce is got only once in a year, only during a about a 2-week window. And also because of the labor-intensive manual harvesting of the produce. But and the plant, the saffron plant is a autumn flowering plant, which is triploid. It is produced through, it is reproduced, multiplied through the comb multiplication, and it is restricted in its growth, and it has a very unique growth. This shows the distribution of saffron only in a narrow geographical belt between the tropical and temperate regions, and this is a unique growth. It has a very unique growth pattern. The plant is sprouts in September, and immediately after it goes for flowering, and then the plant continues to grow. Plant continues to grow. It continues to grow in the winter, irrigated with ice cold water, and it grows up to the end of May, April, May, and then the plant dies and it produces many replacement combs, and the plant dies. So all the work has to be done keeping this unique, very peculiar growth pattern of the plant. So we, along with some other technology for in vitro production of saffron we are developing, we have also worked on high density greenhouse cultivation of saffron, and this was for growing saffron outside the crop's native range. Usually it is believed that saffron is very difficult. It is impossible to grow saffron outside its native range, but we wanted to try it whether it is possible. So for this, actually, this both soil and climate are important. Climate is more complex and more important than soil factors. So what we have done is that we got the soil from Kashmir field, and we have analyzed in detail physical and then chemical and also the biological. So the soil microbiome was studied, and all these three factors, and then we tried to develop a planting medium which is suitable for the plant, which is equally good or better than the soil in the saffron field in Kashmir. So this shows the mycorrhizal associates of saffron plant. So for which we have developed a custom designed low cost greenhouse, and where we can get you maximum take advantage of the natural cooling and in winter, and without resorting to much of equipment. So our idea was to use make it as low cost as possible. Okay. Next slide. Next slide. Next. So we have custom designed the greenhouse, and it also required during the growth phase irrigation with ice cold water. So for this also we have developed a very simple method to give ice cold water directly to the root during the winter, during the plant's growth phase. Next. So then actually we have grown this saffron and standardized many parameters for its cultivation, as comb lifting and time of planting, the planting medium, fertigation, irrigation, and different seasons, the irrigation with the normal water, ice cold water, and in between cold water and ice cold water was required. And we have got flowering as in Kashmir, and we harvested the saffron, and also after drying we have produced saffron, and we have found that this saffron is produced in our greenhouse at NCL is similar to in quality with that produced in saffron field in Kashmir. Next slide. So this is a fresh saffron harvested from the greenhouse, and this is the commercial, means that dried saffron, and which was analyzed, and we have found that these are similar in their properties. Next slide. So after that, I have told you that we have developed a very simple, low-cost irrigation method for giving ice-cold water, like to mimic how the plant is irrigated with snowfall during winter in Kashmir. So we have developed a type of very simple method and irrigated the plants with ice, with ice, and grown the plant till about end of March, and we could produce about the combs, replacement combs of about 8 grams size. Actually, we need about 8 to 10 to 20 gram size combs to continuously produce the saffron, cultivate the saffron in anywhere. So we have found that outside Kashmir or where in this tropical peninsular regions, it is very difficult to produce that. Next slide. So we have found that for growing saffron in a greenhouse, that both soil and climate are important, and soil is, we need a loamy soil without less water holding capacity, with good manure, and then the climate factor is very complex, and early and heavy rain is not suitable, and in such location it cannot be grown, and an autumn-like climate is required for flowering, and further growth should happen, and it requires cold below 4 degrees centigrade, and it needs irrigation with ice cold water. Next slide. So, and here we have this shows some regions, that what is shown in blue. These are the areas where saffron can be cultivated, and we have tried in some locations in the peninsular India, where Mount Abu and Saputara and Panchgani and Munnar. In some places we have tried small trials, and we found that there the winter is not that severe or long as required by the plant, and possibly with our technology it can be extended to some locations in Himachal, in Uttarakhand, and in some part of Uttar Pradesh, and in Northeast, in Sikkim, as well as in Arunachal Pradesh. Next slide. The major challenge is to produce the big size replacement combs, so that perennially it can be cultivated, and this is the greatest bottleneck we have found. Next slide, please. So we have identified some locations, and actually I was trying to introduce this with the farmers, and so that it can be given to this technology can be given to farmers for the production, so that the production can be increased, and so we have identified some locations, and each and every place we may need a special design for the greenhouse as per the climate of that location, and it has to be made with local material, and it has to be extremely low cost, and also developing an automated underground drip irrigation with ice cold water is required, and all that ice cold cooling has to come from natural sources, then only it can be economically viable. And if the production cost goes higher than the field cultivation, then the technology will not be successful, which will not be viable, it cannot be used by the farmers. Next slide. Now recently, that from where I have stopped, now recently there are many reports, and a lot of people approach me also that they want to grow saffron in indoor by aeroponics. So some, there are very huge interest in growing saffron, because it is a very high value agriculture produce, and there are people who are giving training on this, and but they claim that by indoor vertical farming by aeroponics, the people can earn lakhs and crores of rupees. And many people are also falling victim to this type of claims and trying this and making in growth chambers and trying to grow in that. And when they fail, usually many times they call me and ask also that whether what to do. So, next slide. The critical questions are whether this the amateur people who have developed, who are giving training, have they developed end-to-end technology for the perennial cultivation of saffron in greenhouse. Secondly, that can they demonstrate the production of large, bigger size columns which can produce flowers in the succeeding years. And thirdly, it should increase that the first year if we are producing 1 kilo, the second year maybe about 2, and third year about 3 kilos, like that. It increases up for first 2-3 years, and then it comes to a equilibrium and continues for another 3-4 years, and then it starts declining. And the plant is usually grown in a perennial cycle of about 7-8 years. Next slide. So now the reality is that the traditional field cultivation has certain advantages, and indoor saffron, vertical farming of saffron through aeroponics has got many disadvantages. Next slide. So the advantage of traditional farming is that all the cooling comes naturally, the soil, suitable soil is available, and the multiplication of the plant happens, and natural increase in the production of the plant, the saffron yield happens in the first 2-3 years, and it comes to an optimum about 2-3 kilos per acre, and it continues for 3-4 years, and then it declines. So this way it is quite profitable for the farmers for field cultivation. Whereas in indoor farming, the first year the saffron is produced. Next slide. And the replacement combs are not produced. So the economics of that, the aeroponic cultivation is given here, because the cost, how much is the cost, that it comes to about 100 to 200 square feet of indoor cultivation. The cost is given, whereas the yield is about 45,000 to about 4 lakhs. And the following years also, when the starting material, the combs are to be brought from Kashmir, and also the recurring cost of taking care of the plant during the 5-6 months of growth period, and also the electricity charges and all put together, this is not at all profitable. So next. The return on investment is very less, and because of the high value of the crop, the produce, a lot of people are getting attracted to this, and they are getting, they are getting treated by this some amateurs who are giving the training for this type of aeroponic cultivation. And next slide. So actually this is creating a threat to the Kashmiri variety of saffron, because the combs, the starting material is brought from Kashmir, but it is not reproduced, it is not multiplied, and because of that gradually there is an erosion, and there are so many other factors also which are contributing to the decline in saffron production in India. So though initially the idea was to increase the production and give a high value crop to the farmers so that their income can be doubled, but now it is found that this is resulting in the gradual erosion of genetic material. Next slide. So there is an urgent need to protect this Kashmir variety of saffron and develop an appropriate technology which is cost effective, which can be given to the farmers, where economically that cost effectively the crop can be produced and it can be marketed. Next slide. From our research, we have identified many locations where saffron can be introduced. It is the extended area of Jammu and Kashmir, and some locations, as I told you earlier, then in Himachal Pradesh, in Uttarakhand, and in Northeast. Most importantly, in Arunachal Pradesh. Next slide. So the expanding the saffron cultivation through high density greenhouse cultivation, the technology which we have developed, the most important benefit is for the farmers for increasing their income, and secondly, it can boost the economic activity in that those regions where it is newly introduced, where there can also be agro-tourism and generate significant employment for farm laborers, and also meeting the growing need, the domestic as well as the demand for export, and also provide farmers with a very high value, very low volume, and non-perishable agriculture produce having long shelf life. Next slide. So this is the this work was done specifically to have the technology transferred to the field. So to have a lab to field connection so that this can benefit the society. So any questions?
Do we have questions? Oh, thank you, Dr. John, for your insightful talk.
Thank you.
Your perspectives on sustainable saffron production truly highlight the potential of innovation in addressing global challenges.
Thank you, sir. We now move to the next speaker, Dr. Vishnu Halnor, who will speak on the theme, What the Pharma Industry Expects from Institutions and Their Students.
To introduce the speaker, I invite Mr. Sagar Bauke.
Ladies and gentlemen, it is my distinct privilege to introduce our distinguished keynote speaker, Dr. Vishnu B. Halnor. Dr. Halnor, spirit of India's pharmaceutical industry, having transformed from humble beginning as the son of farmer to becoming one of the nation's most respected pharmaceutical leaders. With over 35 years of pioneering contribution to process R&D, technology transfer, and manufacturing excellence, he currently serves as Managing Director of Vishwa Laboratories Private Limited. Dr. Halnor's remarkable career journey includes senior leadership positions at industry giants such as Sai Life Sciences, Glenmark Pharmaceuticals, and Lupin India, where he consistently delivered breakthrough innovations and scaled operation from rupees 10 crore to 350 crores. Having PhD in Organic Chemistry from Savitribai Phule, Pune University, Pune, Dr. Halnor brings invaluable insights into pharmaceutical innovation, cost-effective manufacturing, and India's journey towards self-reliance in pharma raw material. Please join me in extending a warm welcome to Dr. Vishnu Halnor. Welcome, sir. Thank you.
Thank you, Bauke sir. I now request Professor Lamrud sir to felicitate Dr. Halnor.
now invite Dr. Halnur to deliver her lecture.
Thank you. Thank you very much. It is my great pleasure here. And people must have surprised with my talk subject. So let me tell you the background behind that. Last month I got introduced with Dr. Manohar by my friend Dr. Donkar. And in my first introduction with Dr. Manohar, he has shown interest to see my factory and infrastructure. Then I had thought that Dr. Manohar is willing to see my factory. What is the reason behind that? But today I came to know that his vision and his foresee that what he exactly looking from the industry, so that we can realize today. So our this conference on discoveries and innovation, I think we should discover on the how to gather the more audience for this kind of conference. So thank you very much. And Dr. Manohar has told me that I can focus and give a talk on the infrastructure, whatever I have created, my factory and my background. So that's what I have chosen this subject. So now I am not going to present any chemical reactions or biochemistry here. So as Dr. Nathu said that perhaps he is one of the organic chemist here, but I am a second, perhaps I am second person organic chemist here from Ahmednagar College. I am from the batch 1987 to 89. So I am very happy today to present my company's details, as well as I want to explain on the gaps. What are the gaps industries seeing that? So why our research, Indian research is so behind 3 decade or 4 decade behind as compared to the China and US. So that Dr. Manohar has explained in his presentation also, we are behind the 3 decade as compared to the China and US. Dr. Raghavendra also expressed that why our R&D, we are not getting the good people. So what is the reason behind that? So today I will just focus on that. Due respect to the Dr. Manohar's thought, I have prepared this means I have focused on this subject. So first, let me tell you that I came from such a background. When we were in Ahmednagar College at 1987, so that time it was a very tough time. And I think that time almost 95% people are students from the rural area, not from the urban area. Our whole batch, I think, except few people, Dr. Raghavendra and some few people, our batchmates, they may be from the cities, or otherwise 95% people were from the rural and local areas, nearby villages. So that time, whatever we learned from Ahmednagar College, that in my whole life I have tried to put into my work, as well as the that experience I tried to put into my existing business. I will be very happy to tell you that our professor Dr. Ladwa, when we got passed out from here, he told me that you join industry and that to be in a R&D department. So that was the motivation. When I joined to the Lupin Laboratories, before that I got opportunity from the Boots India Limited, which was existing in the this Ahmednagar area only. I got selected in the Boots India Limited. I think they used to give the direct call to the people who got the first class in the MSc. So from Ahmednagar College, myself and one of my classmate, Dr. Bhausep Karale, both of us, we got the interview call from Boots India Limited. We both got selected, and they used to offer 2200 salary in 1989. But I was having back of my end, Dr. Ladva sir's word, you join R&D, don't join any other department. So I thought that, and then I left that job and I joined at 1200 rupees at Lupin, Mandidip, Bhopal. So, and that time, actually I was belongs to the so poor family, my financial condition was not good. But I sacrificed 1000 rupees, just my mentor has told me that you have to join such a department, there you can add the value to your life. So these kind of things, sometimes it influence our life. So today, I will show you my company's details. So I started this my company, but before that I served for the industry for 24 years. Now I completed 35 years in the industry. Total my experience is almost 3.5 decades. So during this course, what I identified, what are the lackings between the students and industry, what exactly is industry is looking for. So I learned that thing, but during this course in 24 years, whatever I learned from industry, I tried to put into my business. I started my company in 2014 after leaving my job as a vice president from Sai Life Sciences. So actually in the industry, what is the important things? Quality management is important. So these are the factors which driven the industry. Okay, I will show you only the pictorials. My actual, the talk agenda is different. So I will just show you my company's presentation. This is my company. Okay, it is named as Vishwa Laboratories. His name is against my both son. Okay, so only these pictures, it is not only the picture, it is having a thought behind that. And that thought, we need this thought, academia, institute, educational institute should create in the students. So people should understand what is the industry. So when Dr. Manohar has visited, he immediately told me that, so your infrastructure is quite good. We can have the collaborative kind of things which can help to the students of the rural area or this means all Pune University people and all these things. I said, okay, no problem. So presently I am having manufacturing facility. I am manufacturing the bulk drug, that is the APIs, and recently in the last year I have inaugurated my R&D center, research center. I am having 20 hoods with me and all supportive equipments like HPLCs, GCs, IR, UV, and recently I purchased LCMS also. So these things are adding the value to my company, and if I can contribute, I can help the people, student, who can take the advantage of this kind of infrastructure in the internship and all these things, that will be great, and people will certainly develop the scientific mentality in that. So these are the reactors. I think when I joined from industry, that time I was not knowing anything about the industry. What exactly exactly the industry is working. So when I joined Lupin Laboratory, that time I came to know that. Till that, whatever available in the our chemistry laboratories in the colleges, we learned that. Apart from that, we were not knowing anything. As Dr. Raghavendra correctly said that, we are spending lot of time to train the people. Whoever is coming from the academic this thing, and they take a longer time to learn, and it is quite expensive for the industry. We are spending 1 year, 2 years to train them, and after training, people leave the company. So that is another problem. So this is my whole infrastructure, just I wanted to show you. Okay. So that's what I was told, that because in this forum, I wanted to have the more students and faculties of the Ahmednagar College. But I think unfortunately, people are distributed some other this thing also. So this is my, this is the actually clean room area where uh, we can manufacture our bulk drug which can be going for the human consumption and direct use for the human. Okay. So I will skip. This is my R&D center, and here I am having these kind of woods, and certainly I am looking for the scientific mentality candidates for my company. But since last 2 years, whatever I found that the people are not having the appropriate knowledge in the whatever whoever is coming from the industry. And nowadays it is a very common that everybody is telling that because of the corona we were not attending the colleges and we are lack of knowledge. So sometimes I surprise that people doesn't know anything about the chemistry. I am the organic chemist, all of you are the biochemist, and but when we are combining both biochemistry as well as the organic chemistry, so that time we need some people, microbiology people we require, biochemistry people we require, organic chemistry people we require. But recent past, whatever interviews I conducted, I'm sorry to say, but academic institutes are not at all taking care of the students. Either they are getting the knowledge or no, and that is what we are spoiling the either students career or the colleges, whatever colleges or institutes are running. So it is surprising, but I'm really want to express that when we were in the Nagar College and we used to attend the interviews, so everybody used to be happy when they conduct interviews. My first interview was Boots India, I got selected. Second interview was Lupin, I was selected. So let me tell you that Nagar College was maintaining that quality and that standard. So hopefully today also it must be continuing. Okay, so here I will just skip these slides and I will go ahead. Sorry. Okay. So if you see that the presently whatever academic knowledge students are having and what industry is expecting, it is totally mismatching. Whatever it may be the reason. And second thing is that our government also is not encouraging for the research kind of activities in our country. That is another problem. So theoretical knowledge and capabilities and insufficient practical knowledge, that is really creating a problem for the industry. So we need to have the synchronization between the academia and industry, how we can improve the quality of the people, how we can create a scientific mentality in the present this generation. We need to have that kind of a thing. That's what I was very happy when Dr. Manohar was told me that you can give your company's background and find out the gap and explain the gaps to the students. Okay, so there is a limited industrial exposure to the student. Of course, I understand that large industries will not give the opportunity to the institutes to enter the student into the factories. But the companies of our size, we can certainly give the opportunities to the colleges, institutes, or universities to have the internship of our industry. And this knowledge is not only required to the student, mentors also should have this kind of a knowledge. When some student initially, if they get the exposure to the industry, certainly few students will join the educational field, so they will be having some knowledge of the industry. So they can pass on that knowledge to the student. So whatever generation we are creating, that will be having a scientific mentality and people will be interested for the industry. So there is a very limited creativity. Whatever I found that, I also came from the student level. I know that time, whatever teaching, of course, I was unable to talk in English till our MSc. Because we came from the rural area, we were not having anything, no resources, nothing was there. So in that case, sometimes whatever teacher is teaching, we never understand that what they are teaching. But we were having a curiosities. We used to study, we used to discuss. Whenever we go back to the hostel, we used to discuss with each other, and then we used to solve the problems. But nowadays, I'm seeing that this kind of attitude is lacking into the students. So why that we need to answer that question and address that issue. Why the present generation is not more keen towards the research, not more keen to the working hard. People want easy money. So that is what the things are. And transnational research should be promoted by the educational institutes. Because as Dr. Raghavendra again, he told that universities should promote the research and they should generate some PhDs which can be helpful to the industry. And I think that is the main one reason that our country, we are lagging behind for the research activity. And government is also not promoting our activity. So importance of the industrial exposure. Industrial visit during the graduation years will help to understand all unit operations. In fact, I will recommend from the graduation level, institutes should think to plan the industrial visit. Now that all educational institutes should think of 6 months MSc project internship in the industries, similar like IITs and ICERs and NITs. That certainly will give value, or it will add a value to the student's life, and it will help to promote our research, our country's research. Hand-on learning to prepare student for real world challenges. That will certainly, it will develop the attitude, or it will develop the capability to the student. They can handle any kind of activity. Will certainly help to the develop the scientific mentality. So this kind of mentality, how it will develop? See, when we are molding our children's, after certain age, you cannot mold them. When the students are there, when mentors are there, mentor will teach some good things, students will understand, and they will adopt that kind of a thing. That is important. So, role of teacher. What is the mentor's role in the student's life? So, mentor should develop the interest of students toward the basic research as well as the applied research. Only basic research is also not, academic research is also not useful to the society or country's growth. If we really contribute to our country's growth, we need to go for the applied research along with your basic research. Basic research, there is no alternative for the basic research. You have to train the people for the basic research, and along with that, we should give the applied research knowledge also. Then mentors should develop willpower in the students. Recent past, I saw that people are lacking willpower. People don't want to work. Few hours they work, and almost everybody requires the supervision. I think in olden days, we were having a fear of our jobs. We never required any supervision or any bosses to complete our work. But recently, whatever I am seeing in my own factory, people are not working. They don't have self-motivation. Why? So that these kind of questions, we need to really, educational institute, really to address these kind of questions. And in fact, they can introduce kind of a courses or mentorship in the institute. Then mentor should develop the curiosity in the student. Nowadays, nobody is having a curiosity. Everybody open the internet and immediately they will go. Let me tell you that in the development of organic chemistry, in my laboratory also I am seeing that. If anything I tell to the people, immediately they will search the Google and they will try. And after 2 days they will come and tell me that, no sir, that reaction is not going. Why? Then what is use of your basic knowledge? What you learn? So that kind of a thing is required. So that's what I told you, that my subject is different. Okay, so since morning you are seeing the chemical reactions or biochemistry or catalyst or enzymes or something. So I am also interested for the biotransformation. In my organic chemistry, along with organic chemistry, I am also interested, and I am interacting with Dr. Raghavendra, Dr. Rahul. Okay, and that is a really good field, and it is having interest in going towards green chemistry. So anyway, that is another part, but mentor should develop the curiosity in the students, which is not happening. Either mentors are not having a sufficient time, or students are not interested. So these kind of things are there. Mentor should develop the dedication in the student. This is the very, very important part. People don't have dedication. Then another thing is scientific attitude. Development of scientific attitude is really required. Then only we can promote a research in a good manner. Role of mentor is very crucial in the developing of the student. So this is what then core skill required. Strong fundamental in the respected subject is required. In our case, it is organic chemistry, biochemistry and biotechnology. Fundamental knowledge of the subject is required. Okay, so then only we can add the value. Observations and implementations are very useful skill required in the industry. When people will work, then only observations will come. Then only they can transfer into the thoughts. They can transfer into the practicality. But people are very casual. They are not at all working. And they are not having the observations. And research requires a lot of observation and implementation of that observations in the practicality. They should develop the skill for the characterization techniques like spectral analysis, spectral data, NMR. Nowadays, if any postgraduate student passed out from the, I'm not talking about Ahmednagar College or Pune University. People don't understand spectral analysis. What is NMR, what is IR, they can't read the analysis. They can't read the spectra. This is the situation of the educational institutes. So I think we should start with somewhere else, and we can promote that kind of things. We can motivate the people. We can have some kind of sessions which can motivate the rural people, and they can get benefited out of that. Then analytical techniques. So presently I am having all these kind of equipments with me, and this kind of equipment, this learning should be there for the people. But when it will come, all institutes, they don't have this kind of equipment, or they cannot afford to carry. I know that we were having IR at Ahmednagar College. I think 24 students were there, and our professor, they used to tell us, and we stand almost 1 meter away from that instrument. So now we can take advantage of the people like small industries like us. We can give the platform to the students, and we can certainly means give the internship kind of things to the student of the Ahmednagar College. Okay, then another important thing is that while teaching the importance of the chemicals, I think Dr. Nathu has told that the safety of the several compounds, hazardousness of the compounds. Okay, yes, there are several hazardous compounds like butyl lithium or this and that. So for that, this biocatalysis is really helpful and useful. It can transform that minus 80 minus 100-degree reactions. It can be run at room temperature without hazards. So this kind of a training or this kind of a mentorship should be given into the educational institute. So this is what okay, this is my closing thought. Develop skill, talent to reduce the import dependency in the pharma sector. See, we are talking about the pharma sector because we know about that only. We don't know about other sector. So when we can develop the talent, certainly that will add to the growth of the country, and our dependency, our other countries, whatever import we are doing it, certainly it will get reduced. Then strengthen the domestic pharma with global competitive practices by developing young talent. So for this, young talent is required, and for develop the young talent, our professors, teachers are having a important role, crucial role in their life. Build a future of India through innovation-driven growth. Students are the future innovators of the pharma industry. Right exposure and skill can transform India into a global leader in the pharma sector. So if you see that in the pharma sector, today also we are exporting lot of pharma products. But somebody talk in his speech that, but what is the value we are getting? We are getting very less value. Okay, so value addition is required. Like suppose if we go for the biotransformation, difficult reactions we cannot do it. Hazardous reaction we cannot take that risk at this level. So in that case, if we train our people and generate a scientist, so certainly these kind of themes we can overcome. Thank you very much. This is what the subject, and I give this credit to the Dr. Manohar, and I certainly dedicate my all work to the Ahmednagar College, and I'm really proud to be a student of Ahmednagar College.
Thank you, Dr. Halnur, sharing the expectations of
all paper on the notice board. So out of 19, I was having 17 and a half marks, and I think you were having some 18 or something, and Dr. Karale was having 19. Other were 0, -1, -5, -7. and let me tell you that Dr. Khanna loves me lot, Vijay Khanna and Ladwa sir. They give lot of love to us and supported me. I have not given my whole background. If you can see that, so I can share it because it is 6 o'clock, right? And my journey in one word, let me tell you that from daily wages person to entrepreneur. Okay, So till MSc, I used to work on the Miss Rozgar Hami and all these things. And I think Sanjay Berad is also my one family friend. He's here. So he's also witness because he knows that our childhood, how we went. So thank you very much. Thank you, doctor. And thank you all students. Wish all the best. And have a good time with Nagar College.
Thank you, sir, for sharing your inspiring story. The next presentation is by Dr. Anita Tiknaik, who will speak on environmental DNA for the bioinformatics era.
To introduce the speaker, I invite Dr. Pavanjit Chabra.
Good evening, everyone. It is my pleasure to introduce Dr. Anita Tiknaik, an accomplished researcher and science communicator with a PhD in zoology and over a decade of experience in genetics, molecular biology, and biodiversity research. Dr. Tiknaik currently serves as the institutional technical head at Green Array Genomic Research and Solutions, a leading genomic and molecular diagnostics lab based in Pune, Maharashtra. Her expertise spans a wide range of advanced genomic technologies, including next-generation sequencing, DNA barcoding, and population genetics. She has contributed to several impactful projects, from livestock conservation to mitochondrial genome sequencing and food authentication, and has authored over 20 research papers in reputed journals. Dr. Tiknaik is also a passionate educator and has delivered numerous invited talks at national and international forums on topics such as bioinformatics and DNA barcoding. Please join me in welcoming Dr. Anita Tiknaik.
Thank you, Dr. Chabra. May I now request Dr. Saroj Ghaskadbi to felicitate Dr. Tiknaik.
Thank you. With this, we invite Dr. Tiknaik to deliver her lecture.
Good evening. So myself is Dr. Anita Tiknaik. So today, this is I think last lecture, and I'm not representing any research or any case studies. I'm just tell you what platforms which you help in your academic research, your scientific research, and some basic concepts are there. So I'll explain one by one. So topic was like environmental DNA in bioinformatics era. So before going my topic, like Green Array is a lab in where we we are like in healthcare sector, but now we started like giving a services to institution like research institution, academician. So and like Green Array is a packed all the package of like for training, diagnostic services and institutional services. So this is our management board. Dr. Sanjay Gupte sir, Dr. Sarjan Shah and Mr. Nitin Gupte, who founded the Green Array. So before going environmental DNA, we should know what exactly DNA barcoding. Okay, what is species identification? What is species identification with the help of DNA? So before going environmental DNA, I'll just let you know what is DNA barcoding. DNA barcoding is nothing but the small fragment where we can identify the species. With the help of that DNA fragment, we identify the species. Why we use the DNA fragment? Because of like traditional techniques are there, like morphological identification. It takes too much of time, and in like Earth, around it is predicted that 9 millions of species are there, and we could identify only 2 millions of species. And for that, we need a speed. And for speed, we need something like DNA. So on the basis of DNA, we could identify the DNA barcoding. DNA barcoding having multiple applications. It is like in biodiversity, we can biodiversity we have application in taxonomy, in dietary assessment, forensic. All these application under the DNA barcoding. So I will show you what is exactly the environmental DNA. This is the genetic material which is shared by the organism in the form of skin, in the form of hair, or either like biological material like in the form of urine, stool, or anything. That is environmental DNA. The DNA is found in the environment. It is environmental DNA. And what is eDNA metabarcoding? This is an extension. Like with the help of multiple markers, we could identify a single sample with a multiple species. It is a DNA metabarcoding. Means single sample means like you can take a soil sample, and in that soil sample you will have a multiple organism, and in a one go you can identify the multiple species in a single sample. That is environmental DNA metabarcoding. So what is the process for environmental DNA metabarcoding? Like suppose we have an aquatic ecosystem. We want to see what is the species, what are the species in the aquatic ecosystem. Just take a sample, like just take a water, filter it, and make one small volume. Then extract the DNA. After extraction, there is a PCR, there is a library preparation, and then sequence that sample. After sequencing, you have a data analysis, and after data analysis, you will have a multiple species in a single sample. Means like one lake in a, suppose you take a lake, and from one lake, that is one sample, and that one sample having a multiple species. That is the beauty of this eDNA. So where we can use the eDNA metabarcoding, that is conservation biology, for the monitoring of rare and endangered species. So why I am telling like endangered species? So for morphological identification, we could not touch the endangered species, right? So for that, we need something like alternate. So we can take a stool sample, or you can take a feather sample, or you can take a hair sample, and from that you identify the species, and without touching that endangered species. And other thing like biodiversity assessment, from that single pool of sample you can assess the entire biodiversity with the help of metabarcoding. Then even we can assess the health of that specific ecosystem with the help of metabarcoding. So even this biosecurity also having one of the application of eDNA. So specifically in agriculture there are like, if you having a like soil, how like there is a every region having their fertility. So fertility depends upon their like soil microbiota. So how we will predict that soil microbiota? Just take a soil sample, extract the DNA from the soil sample, and identify the number of species, whatever organisms are there, like bacteria, fungus. These species we can identify with the help of DNA, eDNA metabarcoding. Even same example will go with the water and ecosystem. If you want to study the water ecosystem, just take a random sample from water bodies, like even marine sample you can take, even you can take a freshwater sample, you can take a river sample, and just take the sample, filter out, extract the DNA, and sequence that DNA with the help of next generation sequencing and analyze the data. You will get the multiple species or millions, even thousands of species in a single sample. You can monitor the aquatic ecosystem with the help of this eDNA. So just I will share this salamander story, which is like in news in the National Geography. So after 140 plus years, the scientists rediscover Rio Grande Sirene near Eagle Pass, Texas, without catching it. So without catching it, we could identify the species before 140 plus years of that species we could identify with the help of DNA. So how she did, that biologist did, like she took a muddy sample, and that from muddy sample she extract the DNA and that sequence the DNA, and she identify that species is available in a specific area which was discovered in 140 plus years back. Second example would be like DNA on flower. You basically you saw the flowers, but flower also having a number of species on that. So one scientist just go to the garden. He went the garden and take the flower and just what he did, he take us like a whole flower he took, and then he extract the DNA from that flower, and he did the metabarcoding, and after that he could found 25 plus species in that single flower. So that might be insect, that might be fungus, that might be like bacteria. So number of species we could found on a like single flower, it was like a 25. And then afterwards he did like take a 56 flower, and from 56 flower he could identify 135 species from a 56 flowers. So I'll just compare what is DNA barcoding and what is meta barcoding. DNA barcoding is a technique where we could identify a single species, and where meta barcoding is a technique where we could identify from a single sample we can identify a multiple species. This is the beauty of meta barcoding. So what is the key aspect for this eDNA? This is like now we have a next generation sequencing. From next generation sequencing, we could have a terabytes of data. That is, we can say high throughput data we can have from that next generation sequencing. This is like we can say this is the key aspect for the environmental DNA. And then the bioinformatics tool. In this era, there are like we are modifying the tools, softwares. We have a speed in that bioinformatics tools. Then even with the help of metabarcoding, we could identify the non-invasive, means like monitoring the non-invasiveness. Like if there is any introduction of other species, like introduction of introduction of other species, like I will give the example like Clarius gyripinus. It was introduced from the Thailand. So this is like exotic species can introduce in our native environment. We could identify this introduction And this is having, obviously, it has a key aspect like multi-ecosystem, monitoring, multi-ecosystem identification we could do with the meta barcoding. So this is one case study. So where Mayer et al. Did a fecal eDNA from 12S, soil eDNA from 12S mitochondrial DNA. He find out, just he take a sample from fecal and soil, and he did some camera trap also. So most of the species cover in a fecal and soil. But whatever beauty is there with the meta barcoding, some limitations also with the meta barcoding. For that, like database incompleteness. So we don't have a complete database till now for the species identification. So I told you, like 9 millions means more than 9 millions of species on Earth, and we could identify 2 to 2.5 millions. It means we have a gap for database, and that database we don't have. That is the incomplete data incompleteness in the database for the identification, primer, bias, and assay design. Sometimes we don't have the universal primer for the all taxa, all species. That is the limit of the eDNA. And means like even for animal and plant also, the plant, in animal there is a like, we could do with the CO1 marker, 16S marker, but in plant still the gap is there, that primer is not specific for the plant group. Even the sampling and filtration issues in the meta barcoding. There is a it may have a contamination in your sample that differ your results. So I'll give you some like I will show you some what are we have in a green array. We have a departments like molecular biology, cytogenetics, and microbiology. So in our green array, we have a provision for diagnostic services related to genetic testing, institutional services, and training. So training for all, like for students also we have a training for faculty also we have a training, even we have an internship on-job training. So these instruments we have, this high-end instrument in a Pune, like in a private lab, no one is having this much of instrument. These all are advanced instrument from like PCR, Sanger sequencing, microarray, and NGS. We have 2 NGS in our green array. Even microscopy, like fluorescent microscopy, inverted microscopy. And these are the services we provide, so specifically extraction service, Sanger sequencing services, transcriptome services, and 16S rRNA services, DNA barcoding services. These services we provide. Recently we launched one kit for the nutrigenomics. That is nutrigenomics, like we can have a genetic makeup, all individuals having their own genetic makeup. Like you heard about precision medicine, like this only, the precision diet also there. So every genetics having their own food diet. So like anyone can go with the diet plan, but all they were not like losing their weight or gaining their weight because of their genetic makeup. So for that we have a nutrigenomics panel. We designed this panel and we developed this kit in our green array. So there are like diet panel, fitness panel. Even for genetic testing, it is like microbiome testing. So just give a fecal sample or gut sample, we do the microbiome testing. So whatever your microbiome, we give the results. So for research and development, so we have a recognition for DSIR. We already we have an institutional biosafety committee, ethical committee. So these are the specifically we targeted this research domain. These are the key publication and whatever trainings are going on. 1-day workshop, 2-day workshop, 3 days workshop, even 1 month internship, 6 month on-job training. These trainings and internship and on-job training we regularly conducted. This is our green array portfolio. It's thank you. If you are having any question, just ask. So there is no questions. Thank you.
Thank you, Dr. Tiknaik, for your engaging presentation. Environmental DNA is shaping
Present here, I am Professor Sagar Bauke, standing here to introduce Dr. Saurav Muzumdar sir, today's distinguished guest of honor. Dr. Saurav Muzumdar is currently serving as Associate Technical Director at Agile Bioscience Private Limited, Ahmedabad, Gujarat. He is distinguished research and development expert with over 17 years of experience in biosimilars, vaccine and protein sciences. He holds a PhD in molecular biology and biotechnology from Tezpur Central University and MSc in biochemistry from the University of Pune. Throughout his career, Dr. Muzumdar has played a vital role in analytical method of development, biophysical and bioanalytical characterization technology transfer, and regulatory submissions. He has worked with leading organizations such as Serum Institute of India, Intas Biopharma, USV Biotech, where he contributed to the development of vaccine, monoclonal antibodies, insulin analogs, and protein-based therapeutics. On the international front, Dr. Muzumdar has collaborated with Novavax in the USA on recombinant protein vaccine project and with Quantum Biologics in Belgium. His expertise has contributed to the advancement of cutting-edge healthcare solution and strengthened global partnership in biotechnology. He has successfully completed regulatory submissions for both preclinical and clinical trials, ensuring compliances with global standards such as US FDA, TGA, MHRA, and Health Canada. His work has had lasting impact on biologics and vaccine development, including contribution to Covovax and several biosimilar programs. Dr. Muzumdar has authored several research publications in reputed journals on protein sciences, fibrinolytic enzymes, anticoagulant activity, and SARS-CoV spike protein. His scholarly contributions are well recognized in the scientific community. In recognition of his outstanding contribution, he has been honored with multiple awards, including Best Educationist Award, the Bharat Shiksha Gaurav Puraskar, and the earlier academic distinction such as Ratan Tata Scholarship and National Scholarship for Academic Merit. With these brief introductions, may I now request Dr. Saurav Muzumdar sir to kindly deliver his talk. Welcome, sir.
Thank you, Mr. Bauke. May I now request Principal Rita Katawati to felicitate Dr. Muzumdar. Thank you. We invite Dr. Muzumdar to deliver his lecture.
Thank you very much for providing me an opportunity on this platform. And I'm very much thankful to especially Dr. Manohar, who is the senior in our department. I was the ex-student of Ahmednagar Christian College Biochemistry Jones School of Biochemistry Department in the year of 2002 to 2004. So with this brief, because most of the things already I've told, so I will directly point out the presentation because it's the last session of this or particular day. So I welcome you on my presentation for importance and structural and physiochemical characterization of biophysical bioprocess development for the manufacturing of recombinant protein therapeutics. Now, it is very, very important thing then when an industry is working on vaccine development or it is a recombinant protein. So in that case, the downstream processing, upstream processing, final producing the DS, formulating in the form of DP. So this entire process when it is going on, they are trying to compare with the innovator samples. And why these biosimilars? Biosimilars because it is low cost and wide affordable cost to the general people. So that's why to cost down that. But we cannot launch any molecule without doing any characterization or comparability with the reference standard or the standard or the innovator sample. For example, Novartis has launched some molecule like insulin, and Okhad also prepared the insulin. But Okhad, when it is prepared, that is the part that they are making it is biosimilar. Novartis and there's Eli Lilly, they are the producers. So they have their own molecule like insulin like that. But you cannot compare the same thing without attesting the biophysical characterization characters of that particular molecule. Even these characterization process is so important for regulatory submissions when it is going to be upstream, downstream, as well as DS and DP in the flow out this part, this characterization is involved. So I'll come directly one by one. Could you please change the slide? Copy. Now this, why we need characterization? Assessment of physiochemical characterization of recombinant biotherapeutic proteins is essential for the bioprocess development since the biological system in which such a protein is produced and can have a significant effect on the structure and function of the product itself. Yes, it is a protein. It is not a synthetic molecule. They have E. coli system. They have monoclonal antibody for that, CHO cell systems. When a protein is evolving from the process, you cannot assure the same protein you are making in your laboratory, although the external conditions which you have already mimicked to produce it. So in order to confirm the similarity of your innovator molecule and structure and functional relationship activity, it is very important to understand the characterizations process. In recent market scenario, manufacturer and regulatory agencies both are facing challenges for evolution of the procedure, productive bioprocess. At the end of the day, you have produced 1 kilo insulin. That purity of the molecule is 70%. You cannot take it for the formulation work. When you match with the in vivo conditions, with the activity of this molecule along with your reference standard, the activity is not matching. It is very poor. So in that case, in order to produce the safety, efficacy and purity of that particular molecule, for that to attest it that your bioprocess is exactly correct, whatever Dr. Rahul has already told. So I am just extending that part, that this bioprocess is exactly correct and similar to your innovator sample. So that has been already confirmed through the characterization. That's why regulatory submissions is very, very important, the characterizations data. Now, biotherapeutics are highly complex molecule. As I told, if suppose you assume you generate a molecule in E. coli and you generate a molecule in CHO cell, what is the difference? One is a protein, which is a non-glycosylated form. Another part is the protein, which is a glycosylated form. The moment you are talking about something called glycosylation, although the protein backbones is same, but the glycosylation features among the innovator and your molecule may be different. So you cannot say that your molecule is biosimilar. So regarding that purpose, I am saying the molecular structure of that particular protein is quite complex in nature, and you have to prove that characterization is the most essential part where you can prove that your molecule is exactly same with the innovator molecule. Now, characterization of biotherapeutics is needed at the each stage of drug development. In my next slide, I have summarized what are the process of drug development, in that where the analytical characterization in which step it is essential. So that is playing a very important role that I will discuss in my next slide. And as per the guideline, now also EMA, FDA and ICH guidelines, everywhere, even ICH 14s now have launched. So these tells us method development, biosimilarity, biocharacterization, everything you have to report to the regulatory agencies. Then only you can confirm that your molecule is very similar to the innovator molecule. Now this is the biotherapeutic process. I have just summarized it. From the cloning, we are starting from the cloning. Most of the companies are taking clone from the outside, and they are doing the process development. We are submitting the data to FDCA, and then there is called IBSC meeting. In IBSC meeting, you have to submit that a biophysical functional characterization part. So that is very important, because this process development is attested the similar kind of molecule manufactured or not, that has been characterized through this biophysical and functional characterization purpose. Then it is going to the preclinical. In preclinical, they are giving this data to the RCGM, and from there, before the preclinical, they will take it for, I have not mentioned it in deep, for phase 1, phase 2 and phase 3. Biosimilar will only follow phase 1 and phase 3, not phase 2, since it is biosimilar. If it is a novel drug, everywhere you have to submit the same data. Phase 1, phase 2 and phase 3. Now when you are doing this preclinical study, you might have taken the 10-liter batch. But for a clinical trial, you might have taken the 10,000-liter batch. Just imagine that when your protein is 10 liter to 10,000 liter, this scale up from the small scale to large scale. Did you think that your glycosylated part of that particular protein is exactly will remain same? No. There is a challenge, because this glycosylation part will play a very important role in case, for example, of monoclonal antibody. Even for insulin, I will come in the different picture, that for monoclonal antibody part is a very difficult things, because that glycosylation pattern will change and it will impact your in vivo activity or the functional activity of the particular protein. So for that purpose, biophysical characterization in compare from the small scale to large scale, whenever you go, you have to compare in each step. That is called the comparability study, and that will be attested by the characterization purpose. Now, we all know that what we are talking about characterization. Some people will say, no, only you do the mass, you do the SDS page, and you can prove that your molecule is very similar to your innovator molecule. No, it's not enough. Previously it was accepted, but now the people, those who have joined DCGI, those who have joined in a RCGM group, they are asking more data. Your protein from the primary structure, secondary structure, tertiary structure, as well as the quaternary structure, in all stage, you have to describe in details that this protein is exactly similar to talking to your innovator molecule. So for that purpose, for primary level characterization, you have to do it by peptide mass fingerprinting, intact mass analysis, N-terminal sequencing, amino acid composition, disulfide linkage. Now, aggregation is a part of the protein because monoclonal antibody, the concentration is DS is very high. In that case, the aggregation, chances of aggregation will be very high. So the formation of dimer or oligomer, it will not so easy to detect without help of the ACC, HPLC. Now, in addition to we have to do sec mols. So the glycan profiling, SDS page, binding assay, RPHPLC, IEC, and thermostability of the protein also you have to describe in order to show that your protein is very similar to your innovator molecule. At the same time, you have to go for the secondary level characterization, and in that case, you have to do the far UV analysis. So far UV analysis at a concentration of 0.1 to 0.5 mg per ml, the scanning range will be around 190 nanometer to 250. It will define your alpha helix, beta sheet, turn, and random coiling. In all component, that will be comparable with your innovator. So that's why the far UV analysis is very important. In case of FTIR, we are getting the two different type of peaks like amide 1 and amide 2. So amide 1 is generally compensate your helical structure, beta structure, and this. And the pattern of linkage, it will be denoted by the amide 2. So that everything you have to determine and you have to mention by the FTIR that your protein is very similar to this. Tertiary structure of this particular protein, in that case, what we did, we have seen that the molecule is excited at 280 nanometer or 295 nanometer to show that tryptophan and tyrosine residues, those are aromatic group of amino acids, these aromatic group of amino acids in the surface or in the buried conditions. For that purpose, we are doing the fluorescence spectroscopy by means of intrinsic fluorescence and as well as the extrinsic fluorescence spectroscopy by excitation with the 280 and 295, and we are taking the emission spectra from 300 to 400. And there is, I will describe in details also, and in near UV CD analysis, it is also defined that phenylalanine, tryptophan, and tyrosine, how the response of your particular test sample against the innovator sample will be remain same or not. Apart from that, we are also doing the AOC. AOC is a kind of technique that is an analytical ultracentrifuge. Without leveling, this protein will be analyzed, and this will define the quaternary structure of the protein. It will divide the monomer, aggregates, or HMW, LMW, everything in a single panel. When you will do the AOC, the picture will be very clear and you can correlate with your ACC HPLC. So that primary level characterization and quaternary level characterization both will correlate with each other in order to submission the high order structural characterization of the protein. There is a list of tests because I have just jotted down. Few tests the physiochemical characterization, they have divided into the two different categories. First category is the CQA, that is called the critical quality attributes. The critical quality attributes is directly impact if your protein amino acid sequence are found different than your innovator sample, the folding and everything will change and it will behave differently. So for example, this identification of the protein, post-translational modification of the protein, and these are directly impact on your particular molecule. So that's why they have categorized as a CQA, that is called the critical quality attributes. And another one is thing is that called KQA, that is the key quality attributes. In KQA type of structure, somehow if you see the charge variant heterogeneity. Now there is called the IEX, it is going to impact on this, but that is not be directly impactful. In order to do this, that there is another thing also I have jotted down. For example, residual DNA or residual HCP, these are the, because your host cell either is E. coli or CHO cell, so you have residual DNA and HCP analysis, so that will be coming under KQA. So in addition to do that, we are doing the SPR study or octet study. You don't know how this protein is behave inside the body or in vivo conditions. So you have to do the same kind of testing in the SPR or octet system to understand the receptor binding study. So in that case, these are the few different ligands which I have already noted usually carried out for the MAV in order to understand the immunological aspect of that particular protein. I will take now example because there's a huge number of tests. If I go one by one, it will be very time consuming. I will take one test that is called the end-linked glycan. It is a very crucial test. Now, when this glycan is processing inside the cell, what will happen? That will start from the year 2. You just imagine inside the cell how it is coming out. So from endoplasmic reticulum to cis Golgi to medial Golgi, and then trans Golgi. When it is coming out from the trans Golgi, that you will start that particular glycosylation. If you see that particular backbone of this particular protein, so this particular backbone of the protein will remain same, but when it will show the glycosylation part, so this glycosylation part will start in the trans Golgi, and that is called the terminal part of that particular molecule. And this is the core part of that particular molecule. In core part, everything is same, but when you will see the terminal part, there is a difference. And the different variety of particular glycan moiety, for example, G0F, what it denotes? There is an absence of fucose moiety. So that is the yellow color is the fucose moiety. And in addition to that also some sialic acid that also impact on the receptor binding activity. So it is a very important part that glycosylation need to understand when the cell, inside the cell, the molecule is processing. Now this N-link glycan and O-link glycan, it is as per the requirement. This is a very important part. Now in the end, if you see that the structure of that monoclonal antibody, there is a 2 heavy chain, 2 light chain. And in asparagine residues, it is linked with that particular glycan. So that's why it is called the end-linked. If it is linked with the serine or threonine, so then it will be O-linked. But end-linked glycan is highly variable. And in that case, this end-linked, particular end-linked glycan moiety is need to be analyzed to understand the mannosylation part, galactosylation part, and afucosylation. Everywhere there is some functional diversity, you can notice if your molecule is more mannosylation part inside the body, when it will inject, it will directly clear out from the body. Because in the receptor, there is a lot of receptor in the kidney. So the mannosylation, if it is high, then it will easily clear out from the molecule, and the shelf life of the molecule inside the body will be less. It will not retain in the body. So mannosylation monitoring is very important. Similarly, galactosylation and afucosylation both are important for ADC and CDC activity. So these are important factor to analyze your glycan in order to prove that biophysical characterization part is needed to compare your innovator molecule versus your manufactured molecule is the same or the similar. Now, if you look the structure of monoclonal antibody, why this structure is I have given, because there is a part, if you see from the, this is the N terminal and this is the in terms of biosimilarity through the characterization process. So just if you don't have SPR, if you don't have octet in your lab, you can also do this kind of study if you have a fluorescence, same fluorescence. You need to keep it with a receptor and incubate it and see the way I have taken the tertiary structure analysis after 280 excitation and the emission spectra, see the changes of response after reacting with that anti-HER2 molecule with the receptor. So if your receptor moiety is directly reacting with the molecule, you can see the changes. But it is a very impure kind of experiment, but more precisely if you want to do, you have to show the octet. Now if you remember, this is the untreated versus deglycosylated part. So this untreated molecule, here this is the glycan moiety, and this glycan moiety you can remove by using the PNGS enzyme. PNGS enzyme is very specific for end-linked glycan deglycosylation. So once you remove that, how it is going to differ in the biological activity in the system? See this. This is the HER2. So HER2 binding sites, particularly, if you see the particular value of the KD value, there is no change in the KD value for the anti-HER2 molecule when you are talking about HER2, because this is the epitope site which is going to bind with the HER2 molecule. But if you are deglycosylated, so this FcRn receptor binding activity is changed. One log difference, it is showing that the molecular association versus dissociation constant when it will be changed when you do the kinetic study at different concentration. So that depends on that particular molecule to decide that the pathway, whatever it is following up, so these are the receptor protein which is going to impact when it is deglycosylated. There is another example called the oxidation, deamidation, and aggregation. When the molecule is oxidated, deamidated, and aggregated, oxidation means methionine is converting in the form of methionine sulfoxide, tyrosine is converting in the form of bityrosine, and deamidation is the asparagine converting in the form of aspartic acids, or glutamine in the form of glutamine acid. So glutamic acid. So this kind of cases, this molecule is change its conformation and it will directly going to impact that activity, so that we can monitor in the octet system. So these are the part of this. The KD value already will tell you the how it is different, how the association versus dissociation is showing, and how the KD value has changed because of the particular modification of oxidation, deamidation, and aggregations. With this, the advantage of BLI platform, I think I have particularly delivered that how it is going to impact that the comparability study in order to understand the efficacy and evolution of the potency of the molecule. So it is already required for the submission of regulatory purposes when you are talking about the molecule. Similar way, that is the differential Canning colorimetry we are doing, that is a determine of the TM value. If you look the monoclonal antibody, in monoclonal antibody, there is a CH1, CH2 and FC region. You will get the different type of TM value. When it will be distorted or deglycosylated, the TM value will change. In other case, also these are same kind of examples I have shown, and these are the CD. The temperature changes the structure of the secondary structure of the molecule, and that has been already noticed here when we do the temperature changing of this particular molecule and going to impact on the native conformation of the protein as change, and it is the due to change of the conformation, the particular alpha turn, alpha helix, beta turn, and random coil has already changed. Now this is the fluorescence study as I told earlier. This is also show the somehow the difference, and with this the deep understanding of the structural and molecular characterization is very, very important in order to potential drug candidate for a identity of advantage with as well as disadvantage, because these are the very, very important factor I cannot say it is a disadvantage, but there is a lot of struggle or challenges in order to prove. So that's why the protein characterization is very important. And it also helps the bioprocess, which is optimized or not, it will tell you very clearly when you compare the molecule at different stage in order to prove the safety and efficacy. With this message, I am just ending here. Due to scarcity of this time, I will not extend. So thank you very much again for this.
Thank you, Dr. Muzumdar, for your detailed and insightful presentation. On behalf of everyone, we truly extend our sincere thanks to you.
With this, we bring the industrial session to a close. These lectures have given us valuable perspectives on environmental monitoring, industry expectations, bioinformatics, and protein therapeutics.
The exchange of ideas and insights shared today has truly enriched our understanding. We thank all speakers, presenters, participants for their valuable contribution today. A gentle reminder for tomorrow, day 2 of the conference. Breakfast will be served from 7 a.m. to 8 a.m. We have several prominent speakers lined up, and the sessions will run from 8:05 to 2 p.m., followed by 12 parallel online presentations. We warmly invite you to join us here for yet another day of insightful academic exchange.
We are about to begin the cultural session. I request everybody to be seated. Every academic gathering finds its true balance when intellect meets imagination. After a day filled with stimulating ideas and discussions, it is now time to unwind and celebrate creativity in its many forms. Our cultural program this evening is designed to let you experience the colors, rhythms, and traditions that make Ahmednagar College so vibrant.
Celebrate achievements. Following the performance, we will have the much awaited EPO on occasion of excellence, dedication, and talent in academics.
But before that, let us immerse ourselves in performances that reflect the energy and spirit of our students and staff. Each performance this evening is not just an act, but a story woven with passion, tradition, and joy.
Together, these performances remind us of the unity that shines through our diversity, where every rhythm, every gesture, and every song speaks of harmony in difference.
We now invite you to experience the magic of Kathak Bharatnatyam fusion, where Indian classical elegance meets the pulse of contemporary rock. It will be performed by our talented students of IMS Academy of Fine and Performing Arts.
Thank you for the mesmerizing performance where every step truly became poetry in motion.
Next, our BCom students step in with a lively medley that captures the youthful energy of Indian music, reminding us how melodies carry both joy and rhythm into our lives.
Music has always been the heartbeat of celebration. It uplifts, it unites, and reminds us that joy is best shared when it is sung, when it is danced, and when it is celebrated together.
Salsa, not flamenco, my brother. Do you know Desi Nach?
What's Desi Nach?
बैल जैसे धूल उड़ा के सींग उठा के तुम भी नाचो बाज जम के ताल ढोल बेटा राजू उड़ के नाचो
हीरो से भी तेज कोई कर सके जो बेद नाचो
अस्तबल में घोड़े जैसे बाग डोर छोड़ नाचो मिट्टी जो रोट मोटा मिर्च खा के ऐसे नाचो हाँ जा छोरे
हाँ जा गोरे
हाँ जा छोरे नाचो 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 वीर नाचो 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 यार नाचो 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 कच्ची कैरी जैसा खट्टा नाचो 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 बिच्छू काटा लागे ऐसा नाचो
एक पल का जीना फिर तो है जाना तोहफा क्या लेके जाइए दिल ये बताना खाली हाथ आए थे हम खाली हाथ जाएंगे बस प्यार के दो मीठे बोल झिलमिलाएंगे तो हंस क्योंकि दुनिया को है हंसाना ऐ मेरे दिल तू गाए जा ए आए आओ आए आ ऐ मेरे दिल तू गाए जा ए आए आओ आए आ
फिर से बोलो दादा चलते तो मास दादा हिलते तो मास दादा देखे तो मास मम्मा मास फिर से बोलो मेरे खाई तू ही बता जाऊं मैं कहाँ की लगी खाई आके बता रहा हूँ तो यहाँ 1 2 3 4 get on the dance दादा चल दे तो मास दादा हिल दे तो मास दादा देखे तो मास मम्मा मास इसकी पैंट भी है मास इसकी शर्ट भी है मास इसके बस्तर में मास ये है मास जाने चाहे फटके मेरी माई कुंडली से वो जैसे उल्टी दशा आई क्यों घंटी लगे कोई तेरे कानों का झुमका
That was truly spirited. Thank you to our BCom students for filling the stage with so much life and energy.
Going forward, our TY BCom students present a performance that beautifully balances depth of emotion with the vibrance of celebration. Their art speaks the language of both heart and soul.
When the body moves to rhythm and the heart follows emotions, dance becomes a language without words, one that everyone can understand and one that everyone can feel.
मेरे मन ये बता दे तू किस ओर चला है तू, क्या पाया नहीं तूने, क्या ढूंढ रहा है तू, जो है अनकही जो है अनसुनी, वो बात क्या है बता मितवा। कहे धड़कने तुझसे क्या मितवा, ये खुद से तो ना तू छुपा।
ये भी न जाने वो भी न जाने, नैनों के रंग नैना जाने, मिला जो संग तेरा उड़ा पतंग मेरा हवा में होके मलंग। जग की कोई रीत न जाने, मैं तो बस तेरी हुई दीवानी, मिला जो संग तेरा उड़ा पतंग मेरा हवा में होके मलंग। मैं छुड़ाई घर बार मेरा ओ मखना वे मखना, अब तू ही है संसार मेरा ओ मखना वे मखना, ये पागल सा है प्यार मेरा ओ मखना वे मखना। मैं छुड़ाई घर बार मेरा ओ मखना, छुड़ाई घर बार मेरा ओ मखना वे मखना, अब तू ही है संसार मेरा ओ मखना वे मखना, ये पागल सा है प्यार मेरा ओ मखना वे मखना। मैं छुड़ाई घर बार मेरा ओ मखना।
A heartfelt thank you to our TY BCom students for bringing such emotions and grace to the stage.
And to showcase the essence of our land, our computer science students bring the rich cultural pride of Maharashtra to the stage through a spirited performance where rhythm, tradition, and devotion come together in celebration.
The soil of Maharashtra has given us saints, warriors, and storytellers. Its festivals, songs, and dance echoes the spirit of devotion and the strength of community.
लटपट लटपट कमर दामिनी अधर रागिनी हो, हे कैसी सजी धजी देखो मेरे पिया की सावरी जिया से बावरी मेरे अंगना में देखो आज खिला है चाँद कि बाजे धुन छम छम छमाते छा तो नाचे मन छम छम छमाते छा कि बाजे धुन छम छम छमाते छा तो नाचे मन छम छम छमाते छा हे लटपट कमर दामिनी अधर रागिनी मेरे दर आई कैसे सजी धजी देखो मेरे पिया की सावरी जिया से बाबरी मेरे अंगना में देखो आज खिला है चाँद कि बाजे धुन छम छम छमाते छा तो नाचे मन छम छम छमाते छा कि बाजे धुन छम छम छमाते छा तो नाचे मन छम छम छमाते छा पिंगा गपोरी पिंगा गपोरी पिंगा गपोरी पिंगा पिंगा गपोरी पिंगा गपोरी पिंगा गपोरी पिंगा मेरे जिया में उतारी तूने तैनी पिया की कटारी हाँ तू जाने ये दुनियादारी मैं तो हूँ बस मोहब्बत की मारी जो पीर मेरी है सो पीर तेरी और दोनों की मांग लगे सुनी आधी आधी लात कि बाजे धुन छम छम छमाते छा तो नाचे मन छम छम छमाते छा कि बाजे धुन छम छम छमाते छा तो नाचे मन छम छम छमाते छा पिंगा गपोरी पिंगा गपोरी पिंगा गपोरी पिंगा पिंगा गपोरी पिंगा गपोरी पिंगा गपोरी पिंगा पिंगा गपोरी पिंगा गपोरी पिंगा गपोरी पिंगा पिंगा गपोरी पिंगा गपोरी पिंगा गपोरी पिंगा
Thank you for taking us into the cultural heart of Maharashtra with such energy and pride.
Our cultural journey now takes us to the vibrant and picturesque northeast of India, a land of hills, rivers, and rich traditions. Known for its colorful festivals, rhythmic dances, and deep connection with nature, the northeast embodies harmony, joy, and celebration.
The dances of the Northeast mirror the rhythm of flowing rivers, the sway of bamboo groves, and the vibrance of its festivals. They remind us that culture is not just performed, it is lived, celebrated, and passed on. Thank you, dear students, for giving us a glimpse of the Northeast, a performance that brought color, energy, and rhythm straight from the hills to our stage.
We now move to the award declaration ceremony for the oral and e-poster presentation competitions.
May I now request our Honorable Secretary, Mr. Vishal Barnabas, to kindly come on stage to grace this occasion.
We begin with the awards for research excellence. The award for the best e-poster presentation goes to Shreya G for a poster titled Targeting Acetyl Esterase by Natural Polyphenol to Combat Alzheimer's Disease. I request everyone to please give a big round of applause.
Thank you, sir. Next, the award for the best oral presentation goes to Jagdish Shitore. Please give a huge round of applause. Mr. Jagdish Shitore. The title of his presentation was Development of Chitosan-based Gel Matrix for DNA Electrophoresis as a sustainable alternative to algorose gel. Thank you, sir. We extend our warmest congratulations to all the participants. Your presentations reflected immense hard work and scholarship.
With the kind permission of the organizing committee, we now declare that today's session has come to a close. We thank you all for your gracious presence and enthusiastic participation, and we look forward to meeting you again tomorrow. Wishing you a pleasant evening.
We request all the participants to join us for the banquet dinner in the adjacent hall. A gentle reminder once again for tomorrow, day